Hi everyone, welcome to PrepFusion. So this is going to be our second marathon on Fourier transform. Okay, so first marathon you would have already watched. So this was the first video that you need to watch. Then secondly you need to watch this marathon, and then third you need to watch this particular video, which is another marathon. Okay, so introduction was given in a separate video. Then there was this marathon where we discussed these many topics. Now this is the marathon when we are going to discuss these many topics. And once you complete this marathon, you will watch this particular video. Okay, so in these 4 videos your Fourier transform will end, and in a very good manner it will end, and you will love it. Okay, so did you understand the flow? First video, second video, this is the third video that you are currently watching, and after that you will watch this video which is of LTI system, analog filters and sampling. Okay, in that manner your Fourier transform will end. Okay, then yeah, thank you very much. Let's get started with the video. I hope you are enjoying the content that we are delivering here. Yeah, thank you very much. Hi everyone, welcome back. So now we are going to study about Fourier transform of periodic signal, because whatever the signal we have taken till now, all were aperiodic signal. Now we need to take periodic signal. Before starting this particular chapter, or before starting this particular topic, let's see a property. So this property we already know that if xt is having a Fourier transform of x of omega, then what will be the Fourier transform of e to the power j omega naught t xt? What will be the Fourier transform? That would be x of omega minus omega naught. You agree to this point, right? Similarly, what is the Fourier transform of 1? Fourier transform of 1 is 2 pi del omega. So it can be treated as xt only. Xt is equals to 1. Can I take that? Yes. Xt is equals to 1. That means xt is always constant. So 1 is having a Fourier transform of 2 pi del omega. Now if I multiply 1 with e to the power j omega naught t, 1 multiply with e to the power j omega naught t, that means it will be e to the power j omega naught t only. It will be e to the power j omega naught t only. What will be its Fourier transform? That would be 2 pi del omega minus omega naught. Say yes or no. Or what you can write down? If I take 2 pi outside from this, then 2 pi will come downward and 2 pi to 2 pi will get cancelled. So it can be written as del of f minus f naught as well. You agree to this point? Like whenever in the impulses, if we take out 2 pi from here, because del, it would be 2 pi f minus 2 pi f naught. So I will take out this 2 pi will come out as 1 by 2 pi. So 2 pi will get cancelled, del f minus f naught. Similarly, e to the power minus j omega naught t, that will have 2 pi del omega plus omega naught. Or what we can write down? Del f plus f naught. All good? All easy, right? So we will be using these properties somewhere. So that's why I wrote it down here. Now, if xt is a periodic signal, so how you can write down your xt if it is a periodic signal? Can I write it down in this manner? Minus infinity to infinity Cn e to the power j n omega naught t, where Cn is the exponential Fourier series coefficient. Cn is exponential Fourier series coefficient. Can I write it down in this manner? Yes. Let's open it up. So xt is dc value c naught. I can take n equals to 1 and then I will take n equals to minus 1. So c1 e to the power j omega naught t. So you guys would have understood what I am doing now, right? You guys surely would have understood what I am doing here. And so, right? So c naught as it is. Now, no, not c naught as it is. Sorry. What we are doing now? Now I need to find the Fourier transform of this particular xt. So what I need to do? Xt should be replaced with x of omega. What I am doing? I am finding the Fourier transform. So what will be the Fourier transform of c naught? Fourier transform of 1 is 2 pi del omega. Fourier transform of 1 is 2 pi del omega. If I multiply c naught here, so this will also be multiplied with c naught, right? So what will be the Fourier transform of c naught? That would be 2 pi c naught del omega plus what will be the Fourier transform of c1 e to the power j omega naught t. So e to the power j omega naught t is having a Fourier transform of 2 pi del omega minus omega naught. So if I just multiply here c1, this will also be multiplied with c1. So what will be the answer? Answer will be 2 pi c1 del omega minus omega naught plus 2 pi c of minus 1 del omega plus omega naught. Do you agree to this point? 2 pi c of minus 1 del omega plus omega naught. What about this one? C2. C2 is having 2 pi c2 del omega minus 2 omega naught plus 2 pi c of minus 2 del omega plus 2 omega naught. In that manner we are keep on going. So how you can write down your x of omega? So x of omega can be written as, this is nothing but simple derivation. N goes from minus infinity to infinity, 2 pi cn del omega minus n omega naught. Do you agree to this point or not? Because if you are putting n equals to 1, 2 pi c1 del omega minus omega naught, n equals to 1, 2 pi c1 del omega minus omega naught. If I put n equals to minus 2, so what I will get? 2 pi c of minus 2 omega plus 2 omega naught. 2 pi c of minus 2 omega plus 2 omega naught. Is that clear to you? Now 2 pi is not a function of n, so 2 pi can come outward. So 2 pi can come outward. So 2 pi is coming outward. Del omega minus n omega naught. There you go. This is the Fourier transform of a periodic signal. This is the Fourier transform of a periodic signal. There you go. Okay, and you can write it down in terms of f as well. If you write down in terms of f, then what will happen? 2 pi f naught. So 2 pi will come outward and 2 pi will get cancelled. So the answer would be n goes from minus infinity to infinity del of f minus n f naught. And what is omega naught f naught? So those also I need to specify here. So what is omega naught? Omega naught is fundamental frequency, which is equals to 2 pi by t naught. And what is t naught? T naught is the time period, fundamental time period. So all these basic things we have already seen in our Fourier series chapter, right? Now, do you need to mug this up? Yes, you need to remember this expression. You need to remember this expression, but eventually you will be able to remember when we solve question. We will solve now 3 to 4 question on this particular concept. Then eventually you will be able to remember this. Okay, so don't put effort in remembering. Eventually you will be able to remember, but you need to remember this particular expression, that it will be 2 pi cn del omega minus n omega naught, where n is going from minus infinity to infinity. It is not that tough, because I will tell you a technique how you can remember this particular expression, but it should be remembered. For problem solving, it should be remembered. So let's solve this question. Very simple, very straightforward. You just need to find the Fourier transform of a sinusoid function, sin omega naught t, right? So don't go by anything else, just go by the pure concept. Don't remember any formula, don't go by this formula. Just go by the pure concept, and then you need to draw the graph of Cn versus n. Also you need to draw the graph of x of omega versus omega. Okay, so what we need to find? X of omega we need to find. So what I will do, I will write down my xt as e to the power j omega naught t. I am not going by this formula. Okay, general trend, how I would have solved it. So just going by the general trend, this is how I could have represented my sinusoid function, right? Divided by 2j and divided by 2j. It will be whole divided by 2j, so I just broke it down, 2j. Now what will be the Fourier transform of this one? 2 pi del omega minus omega naught minus 2 pi del omega plus omega naught divided by 2j divided by 2j. So what we are getting? Pi by j here, del omega minus omega naught minus pi by j del omega plus omega naught, right? So this is your x of omega. Well and good. Now can you draw the graph of Cn versus n? Yes, because I remember the value of C of 1. You don't need to derive it again and again. From here only you can see C of 1 is 1 by 2j and C of minus 1 is minus 1 by 2j. And without even deriving it, or without even writing down this expression, you should be remembering 1 by 2j minus 1 by 2j. So Cn versus n, 1 by 2j minus 1 by 2j. What is your x of omega versus omega? So you are having an impulse. You are having an impulse at omega naught of area pi by j. At omega naught, you are having an impulse at omega naught of area pi by j. And you are having another impulse at minus omega naught of area minus pi by j. If you know the graph of Cn versus n, can you come to the graph of x of omega versus omega? Yes. You draw the graph of Cn versus n. What you need to do? Multiply these amplitude with 2 pi. Multiply these with 2 pi. Replace n with omega, because x of omega always shows the continuous frequency. So here omega value can go from 0 to infinity, right? But here the frequency could go from 0, omega naught, 2 omega naught, 3 omega naught, 4 omega naught, 5 omega naught. But here all the frequencies could be there. So replace, if you are drawing the graph of x of omega, you will draw the graph with respect to omega only, no? Right? This is clear to you, right? If I am drawing the graph of x of omega, I will draw it with respect to omega. If I am drawing the graph of c of n, then I will draw it with respect to n. So replace n with omega. And whatever these sequence you are having, just replace them with impulses. That's it. What did I tell you? Multiply these sequences with 2 pi. Multiply these sequences with 2 pi. Replace n with omega, or surely this will be x of omega. Here these frequencies n equals to 1, so this will become omega naught. This will become minus omega naught. If n equals to minus 2 was there, then this will become minus 2 omega naught. Plus 2 was there, then that will become plus 2 omega naught. Basically, we need to write down the frequency content. So here omega naught frequency content, 2 omega naught frequency content. That will become impulsive. Impulse will be there. In place of sequence, you will make the impulse with the area multiply by 2 pi. With the area multiply by 2 pi, you will get the graph of x of omega. Do you agree to this point? Pi by j minus pi by j minus omega naught plus omega naught. X of omega, omega, omega. Yes. Are you able to understand this point or not? So as of now, I am just changing it. But this is the way I have told you. And if you remember this way, then it will be easy for you to remember the previous formula as well. Which formula? The previous formula we just wrote down, this formula. It will be easy for you to remember. Okay, we will see that. But as of now, let's make it C of n versus n only. This is not an impulse. This is a sequence. N equals to 1, n equals to minus 1. So this is the height of the sequence, but this will become the area of the sequence. So what is the conclusion now? That x of t can be written as this. X of t can be written as n going from minus infinity to infinity. This is your x of t, Cn e to the power j n omega naught t. If you need to write down x of omega, then what you need to do? The Cn should be multiplied with 2 pi. Cn should be multiplied with 2 pi. Now the height remains the same. The height remains Cn only. Height remains Cn only, but that is multiplied with 2 pi. Now at every discrete frequency, what you are having? You are having the impulses. At every discrete frequency, you are having the impulses. If you remember in this manner, then you will be able to remember it. This Cn, this height becomes the area, but area will be multiplied with 2 pi. Height becomes the area will be multiplied with 2 pi. And all these sequences will become impulsive. And these impulses will be there at all the discrete frequencies, omega naught, 2 omega naught, 3 omega naught. So in that manner, you will be able to write it down. Is that clear to you? X of t, you know, x of omega. Cn will be multiplied with 2 pi. So always, like if someone asks you what is the Fourier transform of a periodic signal, so you will never write down this formula directly. You might mess up somewhere. So first what you write down? X of t. Then Cn will be multiplied with 2 pi. This will be replaced with impulses at discrete frequency. So del omega minus n omega naught. In that manner, you will be able to write down. Say yes or no. And from this expression, x of f will be a cakewalk for you, right? Because in x of f, 2 pi will not come. Del of f minus n f naught. Always remember what is f naught, what is omega naught. That we already know, fundamental frequency, right? So is it tough? No. But if these kind of questions are coming like sinusoid, cosinusoid, so there it would be easy for you to solve, right? It will not take much time. And if possible, always remember the Fourier series expression of, Fourier transform expression of sinusoid function. If possible, always remember the Fourier transform expression of sinusoid function. So sin omega naught t is having a Fourier transform of pi by j at omega naught frequency minus pi by j at minus omega naught frequency, and both will be impulses. Then you will be able to write down. Just keep this diagram in your mind. You already have this diagram in your mind. It will be not tough to remember this diagram, right? It would be easy only. Just a second. Yeah. So if you remember the diagram, okay, what you will see, okay, pi by j del omega minus omega naught minus pi by j del omega plus omega naught. If a diagram is there in your mind, then you will be able to write down the expression very easily. So this is the Fourier transform of sine omega naught t. Well and good. Now Cn versus n graph is given. Fundamental frequency is omega naught. You need to draw the graph of x of omega versus omega. So what you need to do? All these sequences will be replaced with impulses with the area being multiplied with 2 pi. So I will just copy this diagram. I will just remove C of n and n. In place of that, I will write down x of omega versus omega. X of omega versus omega. Now all these frequencies will become discretized frequencies. So this will become omega naught. This will become 2 omega naught. This will become 3 omega naught. This will become minus omega naught, minus 2 omega naught, minus 3 omega naught. And this will become impulsive, impulses, 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 and all these will be multiplied with 2 pi. All these will multiply with 2 pi. So it is easy for us to remember the diagram, and whenever we need to solve the problem based on this, mostly we will have to make the diagram. So no issue there. Okay. Well and good. Let's see the Fourier transform of cosinusoid function. So in the similar manner, you can find out the Fourier transform of cosinusoid function as well. How will you do it? Look, one way is you go by the mathematics, or other way is you go by the diagram. Because I remember the diagram of C of n versus n. Do you remember it? Yes. I remember the diagram of C of n versus n. N equals to 1, n equals to minus 1. What do I get? 1 by 2 and 1 by 2. Here I get 1 by 2. Here also I get 1 by 2. But what will happen? Multiply with 2 pi. C of n will become x of omega. N will become omega. X of omega versus omega. Discretized frequency would be there. Omega naught minus omega naught. Minus omega naught, omega naught. These will become impulses. So you are having two impulses, one at omega naught, other one at minus omega naught, with the area of pi. So area of pi. So what is your x of omega now? So from here, your x of omega is coming out to be with the area of pi, del omega minus omega naught, and another one area is also pi, del omega plus omega naught. There you go. Okay. And if you don't remember this technique or anything, although you will be able to remember, then you can derive it, right? What you can do? Cos omega naught t. So x of t would be e to the power j omega naught t plus e to the power minus j omega naught t divided by 2 divided by 2. So if I need to find the Fourier transform, so 2 pi dial omega minus omega naught, 2 pi dial omega minus omega naught. So 2 and 2 will get cancelled. What I will get? Pi dial omega minus omega naught. Here also 2 pi dial omega plus omega naught. So 2 and 2 will get cancelled. Pi dial omega plus omega naught. So this is your x of omega. So n number of ways are there. I have told you the technique as well. I have told you how to draw the diagram as well. Let's find out the Fourier transform of these expressions. Okay. So what you will do? First task would be to find out Cn, because if we know the Cn, after that only we can write down the Fourier transform, right? Because what will be the Fourier transform? That would be Cn will be multiplied with 2 pi. Cn will be multiplied with 2 pi, and I will be having impulses at all the discrete frequency. So if you say in this manner, if you keep on, if whenever you write down the formula, you should say in this manner. What you should say? Again, let's try doing it again. So what you will say? Sir, for a periodic signal, my Fourier transform, that my exponential Fourier series coefficient will be multiplied with 2 pi, and I will be having impulses at all the discrete frequencies. Here, what is the value of omega naught? Directly I can see that my value of omega naught is 2 pi. Why so? Because value of t naught is 1, right? Value of t naught is 1, so value of omega naught is 2 pi. Well and good. Now task is to find Cn. So what we will do? Apply the differentiation property. Feels like very easy to me, applying the differentiation property. What I need to do? Here the differentiation, what is the slope? Slope is 1 here, right? Slope is 1. So always the slope is 1, but I will be having impulses here. So slope is always 1, and whenever I get the DC part, I always ignore that. I hope you have studied the basics of a Fourier series. Okay, you have completed the Fourier series, then only you are coming here. Don't directly jump to Fourier transform. So all the impulses I am having. minus 2, 1, 2, 3. So I don't care about this amplitude because I told you I don't care about the DC value at all, because DC value I can find separately. But now I am having an impulse strain of area minus 1. What I am having? Impulse strain of area minus 1. So what is your dxt by dt? It is having a DC value that I don't care, because DC value, C naught value I can find out on my own. What will be the C naught value? 1 by divided by the time period. What is the time period? That is 1. And then area of one time period. What is the area of one time period? That is half into base into height. So what you are getting? 1 by 2. So C naught value is 1 by 2, which is fixed. We need to find the Cn value. For that, what we have got to know is that our dxt by dt, what is that? Impulse strain of time period equals to 1. There was another thing, the time period has to be same. This time period and this time period has to be same. If both are same, yes, you are doing good. So impulse strain of time period equals to 1. There is no shift. What is the area? Area or amplitude, whatever you can call it. Area is minus 1. So what will be the what will be the exponential Fourier series coefficient for this one? That would be minus 1 by T naught, minus area divided by T naught, minus 1 by 1. And here what will be the Cn? D by dt will be replaced with J and omega naught, and this will be your Cn. What is the value of omega naught? Omega naught is 2 pi. Omega naught is 2 pi. So J 2 pi n Cn is equals to minus 1. So Cn is equals to J divided by 2 pi n. So this is the value of Cn you are getting. But n cannot be 0 here. Apart from n equals to 0, everything is true here. So what is your Cn? Cn is actually like this, that it is 1 by 2 for n equals to 0. Neck issue, back issue, neck issue. Getting older. Just at the age of 24, I am getting older. J divided by 2 pi n. N is not equals to 0. So this is your Cn. What we need to write down? We need to write down x of omega. Right? So basically, what is your x of omega? X of omega is 2 pi summation n goes from minus infinity to infinity Cn del omega minus n omega naught. What is the value of omega naught? Omega naught is 2 pi. So here I will write down 2 pi n. 2 pi n. So basically this will be your x of omega, where Cn is this, where this is your Cn. That's it. Nothing else you need to do. Okay. Better we can draw the graph, but graph is also not necessary. The job is done basically. This will be your x of omega. Cn value I already know. So now I can replace my x of omega something like this. Right? They can ask you like what they can ask you, like they will never ask you directly the what will be the exponential, what will be the Fourier transform of this particular signal. Directly it will not be asked, but it will be used somewhere. Okay, somewhere we will be using it. So that's why we are studying it. Okay, when we study sampling, all these things will be used. So Fourier transform of a periodic signal, directly it may not be asked, but it will be very useful. And this year I feel that there will be one question from this particular concept, that you will have to write down the Fourier transform of a periodic signal in the examination hall. So this formula should be there in your mind. Just 1 second guys, I need to pause the video. Yeah, welcome back. So yeah, this question is done. Okay, you can represent x of omega like this. Basically x of omega will be 2 pi c naught del of omega. That means what is the value of c naught? C naught value is 1 by 2. So pi del omega plus 2 pi c1 del of omega minus 2 pi, right? 2 pi c1 del of omega minus 2 pi, right? Omega minus 2 pi remains as it is. What will be the value of c1? That would be j by 2 pi. So 2 pi will get cancelled. So this will simply be j only. This will simply be j only. So j del omega minus 2 pi. In that manner you can write down basically. Okay, so somewhere if they are asking in this manner, then you can write down in this manner. Otherwise there is very high chance that they will ask this expression only. Okay, or they will ask the expression of Cn. But there is higher chances are there that they will not even ask these kind of questions. It will be used somewhere. Somewhere it will be used. So let's see the next question. this is your xt given. Is it periodic? First you need to know whether it is periodic or not, and then if it is periodic, then find out the Fourier transform of this particular signal. So let's draw this signal. Okay, whenever you get these kind of signal where impulses are there in the time domain, impulses are there, that means certainly it will be periodic. And how will you get to know the periodicity? By drawing the graph. So n equals to 0 you put, what you are getting? minus 1 to the power 0 delta t, that means delta t you are getting. Basically what I am doing, I am putting the value of n. So n equals to 0 I put, minus 1 to the power 0, that would be 1, here it would be 0 only, so delta t. Then I put the value of n equals to 1, so what that would be? Minus 1 to the power 1, that would be minus 1 only, delta of t minus 1 by 2. I can put the value as minus 1 as well, what that would be? Minus 1 to the power 1, so minus 1 to the power minus 1, that would be minus 1 only, delta t plus 1 by 2. Then you put n equals to 2, so minus 1 to the power 2 will be 1, delta of t minus 1. Then you put n equals to minus 2, so that would also be 1, t of plus 1. So in that manner there are impulses, right? So at half the area will be minus 1, then at minus half the area is minus 1, then at 1 the area is 1, then again the area will be minus 1, because minus 1 to the power 3 will be minus 1, then again it will be 1. So this is the way, right? In that manner we will keep on going. So minus 1, minus 2, 1, 2, 3, 4. Oh, sorry. The time window is half, no? This is half second, 1 second. So this is 0.5, half, 1, 3 by 2, 2. This is minus half. This is minus 1. In that manner it will keep on going here, and here also it will keep on going. Area being 1, minus 1, 1, minus 1, 1, minus 1. Time period, what is the time period? So this window is being repeated. So what is the time period? Time period is 1. T naught value is 1. What is the value of omega naught? Omega naught value is 2 pi. Now how will you find out the Cn value? Because first we need to find out the value of Cn. So how will you find out Cn? Impulse train, amplitude 1 and time period of 1. Impulse train, amplitude 1, time period of 1 plus another impulse train. Look, there are two impulse trains, right? This we have already seen in our Fourier series. So there is an impulse train and then there is another impulse train. So two impulse trains are there. First impulse train having amplitude of 1 with the time period of 1 plus impulse train amplitude of minus 1 having a time period of 1 shifted by t naught by 2. Because if this is t naught, this value will be t naught by 2. And I told you whether you do the left shift or right shift for t naught by 2, it doesn't matter. Like basically you can say that this is shifted by t naught by 2 to the right, or you can say it is shifted by t naught by 2 to the left. Both are the same thing. So for t naught by 2 it doesn't matter, left shift, right shift doesn't matter, right? So this is how you will write down impulse train, time period of 1, area of 1. Impulse train, time period of 1, area of 1, but why is that so? Because I have put the negative sign here. I could have put the positive sign here, and here I could have put area of minus 1, and then it is shifted by t naught by 2. So what will be the Cn value? For this the Cn value will be 1 by t naught. 1 by area is 1 divided by t naught. And for this it would be 1 by t naught. What is the area? Area is minus 1 divided by t naught. What is the value of t naught? That is also 1. E to the power j n omega naught t naught by 2. Because it is shifted, right? X of t is having Cn. X of t minus t naught will have e to the power minus j n omega naught t naught Cn. So similar thing is there, right? Omega naught t naught by 2, it can be replaced with pi. So 1 minus e to the power j n pi. So 1 minus e to the power j pi to the power n. And what is the value of e to the power j pi? That is minus 1. So 1 minus minus 1 to the power n. So this is actually not your xt. Okay, this is your xt only. Sorry. Yeah. So this is your xt only. This is something that we are not getting by differentiating. This is the general way that we are getting. So this is your C of n. So what is your C of n is coming out to be 1 minus minus 1 to the power n. Do you agree to this point? Let's check back the calculation. Okay, all fine. Here all fine. Impulse train, time period 1, area 1, impulse train, time period 1, area minus 1, shifted by t naught by 2. E to the power j pi is minus 1. Do you remember e to the power j pi? Cos pi plus j sin pi. So e to the power j pi will be minus 1 only. So minus 1 to the power n in that manner. This is what something that we are getting. Now let's check all the values. At n equals to 0, what you are getting? What is the value of C0 here? Minus 1 to the power 0 will be 1 only. So 1 minus 1, value is 0. At n equals to 1, what is the value? At n equals to 1, the value is 2. Because minus 1 to the power 1 will be minus 1 only. So the value is 2. At n equals to 2, C2, what will be the value? N equals to 2. Minus 1 to the power 2, that would be 1 only. So 1 minus 1, 0. At n equals to 3, minus 1 to the power 3. So what will be the value of C3? Minus 1 to the power 3. What that would be? Minus 1. So value will be 2. What is the value of C of minus 1? Minus 1 to the power minus 1. The value will be 2. What is the value of C of minus 2? Minus 1 to the power minus 2. Value will be 0. So what you are getting to know? Cn is equals to 2 for n equals to odd, and Cn is 0 for n equals to even. Say yes or no? Cn is equals to 2 for n equals to odd. If n is equals to odd, then it is 2, otherwise it is 0. And you can check here as well. What you can check? There is half wave symmetry here. There is half wave symmetry. Shift this graph bit with t by 2 and then take the mirror image. You are getting the same thing. So there is half wave symmetry here. And if there is half wave symmetry, what does that mean? Only odd components will be present. That means omega naught, 3 omega naught, 4 omega naught, these components will be present. So what do you think? What will be your x of omega? So here we can write down our x of omega will be 2 pi. Again n goes from minus infinity to infinity. Cn, I will be having impulses at these discrete frequency. And what is the value of omega naught? That is 2 pi. Cn value we already know. So this is our x of omega. But this can be written in this manner. In which manner it can be written? It can be written something like this. C0 value is already gone. So 2 pi. C1 value is, for odd value, C1 value is 1. So 2 pi into 2 del of omega minus 2 pi plus then n equals to even, C0 value is gone. Then I will put n equals to 3. So if I put n equals to 3, what I will be getting? Again I will be getting 2 pi into 2 del of omega minus 6 pi. In that manner, basically I can write it down. Okay. So here 4 pi can also come common, and what you can write down? Can there be any better expression for this? Basically 4 pi will come common here, del of omega minus, I need to make it odd. So 2 pi into 2n plus 1 if I do, will that work for me? N equals to 0, 1, n equals to 1, 3, n equals to 3. If I put n equals to 3, if I put n equals to 1, I will get 6 pi. Yeah, this is working. If I put n equals to minus 1, I will get plus 2 pi. If I put n equals to minus 1. Yeah, this is also working. So basically this can also be a representation. What I mean to say is that this x of omega, shall I add a page? So let me add a page here. Just another way of representation I am telling you, nothing else. Just another way, nothing else. So what we get to know, this is our x of omega. So in x of omega, we can put the values of n. If I put n equals to 1, then I can, if I put n equals to 0, then C0 value is 0 only. So this whole expression will become 0. So I can only put the odd values of n. So 2 pi C1, what is the value of C1? C1 value is 2. So value of Cn is actually constant. So 2 pi into 2 del of omega minus omega naught. Then what I will put? I will put n equals to 3. Again the value will be 2 only, but here I will be getting 6 pi. Then I will put n equals to 5. Say yes or no. Now similar thing I can do for n equals to minus 1 as well. N equals to minus 3 as well. then I can do n equals to minus 5 as well. Right? So what we are getting, 4 pi is coming common, and here in the bracket we are getting del of basically dot del of omega minus 10 pi plus del of omega minus 6 pi plus del of omega minus 2 pi plus del of omega plus 2 pi, then del of omega plus 6 pi. Just another way of representation we are doing, nothing else. Del of omega plus 10 pi. So just saying that the answer could be written in this form as well. In which form? In this form the answer could be written 4 pi summation n goes from minus infinity to infinity. Okay. Del of, now what do you think what I can write down? Omega minus 2n into 2n plus, sorry, omega minus, I need 2, 6, 10. In that manner I need. Then I would need 14. Right? So there is a gap of 4. Mm-hmm. 2 into 2n plus 2 into 2n plus 1. Yes. Yes. So this would work. 2 into 2n plus 1 pi. There you go. You put n equals to 1, what you are getting? If you put n equals to 0, what you are getting? 2 pi. You put n equals to 1, what you are getting? 3 into 2, 6 pi. You put n equals to 2, what you are getting? 10 pi. You put n equals to minus 1, what you are getting? Minus 2 plus 1 will be minus 1 plus 2 pi. Plus 2 pi. You put n equals to minus 2, what you are getting? Minus 4 plus 1 will be minus 3. So minus 3 into minus 2 will be plus 6. So here 6 pi. You put n equals to minus 3 here. So that would be plus 10 pi. So in that manner we are getting. Okay. So this is your x of omega. Okay. You keep on putting the values of n. This is also could be the representation of x of omega. Okay. Here there is no term of Cn. So when we put the value of Cn, this could be the representation we got. So nothing else. This is very simple, right? Let's go to the next question. Not the next question. This is the next concept. Now you would have understood what we are doing here. I hope this is clear to you that what we wanted to study in the previous part of this video. So just there will be a periodic signal. You just need to find out the value of Cn. If you know the value of Cn, then what you need to do? 2 pi into Cn, and then those sequences will turn into impulses. And impulses will be written as del of omega minus n omega naught. Basically at every discrete frequency, at omega naught, 2 omega naught, 3 omega naught, there will be impulses present. There you go. So this is how you can represent your Fourier transform of a periodic signal. Now when we were studying Fourier series, I told you that at that time, if I ask you that what will be the Fourier series coefficient of this particular signal, this is given, this is a periodic signal that is given, what will be the Fourier series coefficient of this particular signal? How would you calculate? Till this point you would have calculated by differentiation property. You will differentiate it, there will be two kind of impulses, you will write down the impulses in this manner, and then you will find out the Cn value. But you can use the Fourier transform as well to find out the Fourier series coefficient of a particular signal. What I am saying, using the Fourier transform, you need to write down the Fourier series coefficient of a particular periodic signal. So inverse process we are doing. Are you able to understand what we are doing? What we are going to write down? We are going to write down the Fourier series coefficient using the help of Fourier transform. So this is just a process, this is just a method, nothing else. Okay, this is just a method. So what is that method? What we need to do? So in this time window, what we will do? We will pick one time window. What we will do? We will pick one time window. So this is one time window. In one time window, we will see this particular structure. What is this? Rectangular signal, right? And do we remember the Fourier transform of rectangular signal? Yes, we remember the Fourier transform of rectangular signal. So what is our rectangular signal? What we will do? First, we will pick only one window. What we will do? Only one window of time period we will pick. In one window of time period, we can see a rectangular signal, and we remember the Fourier transform of a rectangular signal. What is our target? Our target is to write down the Fourier series. But when I saw this particular diagram, when I saw this particular waveform, then I saw that if I take a window of one time period, in one time period I can see a rectangular signal, and for this rectangular signal I know how to write down the Fourier transform. So what is this rectangular signal? This is A rect t minus center upon time width. So what will be its Fourier transform? 2a t1 sampling of omega 2 by 2. This will be its Fourier transform, right? A rect t by 2, a2 sampling of omega 2 by 2. Now what I need to do? This was its Fourier transform. Now from Fourier transform, if I need to go to Cn, what I will do? First thing is that I will divide by t naught. Whatever the expression that I am getting, this is my x of omega, right? I will divide my x of omega by t naught, and I will replace my omega with n omega naught. There you go, this is your Cn. That's it. No differentiation property, nothing else. I remember the Fourier transform of some particular standard signals. When I saw this waveform, in between I picked this particular waveform. I know that this is a rectangular signal, and for rectangular signal I remember my Fourier transform. What is that Fourier transform? So this signal A rect t by 2t1, right? So this signal is only for one window. I am picking one signal, which is rectangular signal. So A rect t minus center upon time width being 2t1. So what will be its Fourier transform? 2a t1 sampling of omega 2 by 2, so omega t1. Now what I need to do? I will divide this. What I am doing? I am dividing my Fourier transform with the t naught, and I am replacing omega with n omega naught. This is my Cn. Okay, and this I am picking for one time period. Only for one time period I am taking this Fourier transform. I am not calculating the Fourier transform of this waveform. No, I am calculating the Fourier transform of only one time window. I calculated the Fourier transform of one time window. Then I replaced omega with n omega naught and divided it with t naught. So you can write it down somewhere in your notes where there is a blank space. So I am keeping this space blank. So you can write down the method. What is the method? Replace omega with n omega naught and then divide by time period. There you go. This is your Cn expression. That's it. And if I ask you what is the Fourier transform of this particular signal, what will be the Fourier transform of this particular signal? So this is not your x of omega. This is not your x of omega. No. This is just a method. What is the method? That in one window only I took this particular waveform and then I wrote down the value of x of omega. This is not our x of omega. If someone asks you what is the Fourier transform of this particular signal, what is the Fourier transform of this particular signal, then what you would have done? First you would have calculated the Cn value, and from there you could have calculated your x of omega. So my x of omega is 2 pi summation goes minus infinity to infinity Cn, and then I will be having impulses at every discrete frequency. This would have been my x of omega. So this is not your x of omega. This is only your Fourier transform of xt for one time window. Fourier transform of xt for one time window. So what is your Cn actually? That is, for one time window you are calculating the Fourier transform and you are replacing your omega with n omega naught, and then you are dividing this Fourier transform with t naught. This is your Cn value. This is the value of Cn. Okay, so this I have written already here, so you don't need to write on your own. So again I am repeating, you will see a periodic signal. In the periodic signal for one time window, if you feel like that there is a standard signal, if there is a standard signal, then my job is done. For standard signal, if I know the standard Fourier transform, then I will write down the Fourier transform, and then I will replace omega with n omega naught, and then I will divide with t naught. That would be my Cn. But if someone is asking you the Fourier transform of xt, Fourier transform of the periodic signal, then this is something not the Fourier transform of the periodic signal. No, this is just the Fourier transform of only one time window. But completely, if you need to write down, then this is how I will write down. So is everything is clear for this particular waveform? Yes, everything is crystal clear. Let's see the next one. Now these kind of questions will be asked. What kind of questions? Then you need to tell the absent harmonics in xt. So very important. I would say this is important. Absent harmonics means like what all frequency content are not present. It will have omega naught, 2 omega naught, 3 omega naught, 4 omega naught, 5 omega naught. It might happen that 6 omega naught is not present, 7 omega naught is not present. So which all frequency component are not present, which harmonics are not present, that you need to find. And for that, what you need to calculate? Cn value, right? Because if you have the Cn value, if your C of n is coming out to be 0, what is the meaning of absent harmonic? Absent harmonic. Absent harmonic means your C of n should be equal to 0. Absent harmonic means your C of n should be equal to 0. So for, let's just say for n equals to 1, let's just say C1 is equal to 0. That means first harmonic is not present. C of 7 is equal to 0. That means seventh harmonic is not present. C of 3 is equal to minus 3j. That means third harmonic is present, right? So what we need to find out? We need to find out the value of Cn. Will we find out the Cn by differentiation property? Absolutely not. Why is that so? Because what I can see is that in one time window, I can see one signal, I can see a signal which is absolutely standard. And for this standard signal, I already know the Fourier transform. And in the Fourier transform, if I replace omega with n omega naught and then divide by the time period, my job will be done. So what is this signal? A rect t minus center upon time width. What is the time width? Here, this is the negative sign. That is 2 t naught by alpha. So that would be A2 sampling of, let me see, 2 t naught by alpha only. Yes, okay. So A2 sampling of omega 2 by 2. Right. So what will be your C of n? So C of n will be 2 t naught by alpha divided by t naught. Sampling omega will be replaced with n omega naught. 2 and 2 will get cancelled. N omega naught t naught divided by alpha. 2 and 2 will get cancelled. Omega n omega naught t naught divided by alpha. So 2a t naught alpha divided by t naught. What we are doing? We are dividing this by t naught and replacing omega with n omega naught. There you go. So what we are getting? C of n as 2a by alpha sampling of omega naught t naught is 2 pi divided by alpha. So this is your Cn. This is your Cn. What all are the questions now? You need to find the absent harmonic. First you need to take alpha equals to 4. So first case, taking alpha equals to 4. So what will be your Cn? That would be a by 2 sampling of alpha equals to 4, that would be n pi by 2. So for which value of n it would be 0? What do you think? N equals to, this would throw 0, 4. I can directly see n equals to 2, 4, 6, 8. Along with that I need to plus minus. Why is that so? Because sampling function n pi by 2 should be equals to 2k or should be equals to k pi. Because what is sampling function? Sampling is sine n pi by 2 divided by n pi by 2. At n equals to 0, it will throw 1. At n equals to 1, it will be sine pi by 2. Basically, if this becomes a multiple of pi, if n pi by 2 is a multiple of pi, then this will throw 0. There you go. So it will throw 0. When it will throw 0? When n is equals to 2k, where k value goes from 0 to, k value goes from 1 to infinity and minus 1 to infinity as well, or you can say minus infinity to minus 1. So basically, value of k will be all integer. Value of k is all the integers minus 0. Minus 0. So these harmonics are absent. That means second harmonic, third harmonic, second harmonic, fourth harmonic, sixth harmonic, eighth harmonic. These harmonics are absent. Okay, so these are the absent harmonic. A very simple question, very straightforward, right? Second case, alpha equals to 3. What I need to put? Alpha equals to 3. So 2n pi by 3 should be equals to, or I can write down what will be my Cn. What will be my Cn? So Cn will be 2a by 3, sampling of 2n pi by 3. So 2n pi by 3. Directly I can see that if I put the value of n equals to 3, if I put the value of n equals to 1, no issue. If I put n equals to 2, no issue. If I put n equals to 3, yes, issue is there. If I put n equals to 4, no issue. Because if I put n equals to 3, what will happen? 3 and 3 will get cancelled out. 2 pi. Yeah, that is a multiple of pi. So n equals to 3 will not be present. If I put n equals to 4, 8 pi by 3, no issue. If I put n equals to 5, 10 pi by 3, no issue. If I put n equals to 6, 4 pi, yes, this is a multiple of pi, so there is an issue. So n equals to 3, 6, 9, 12. So these harmonics are not present. So which harmonics are not present? 3, 6, 9 in that manner, right? Or what you can do, 2n pi is equals to k pi. So pi get cancelled. What is the value of n you are getting? That is 3k by 2n. 3k by 2. But value of n has to be integer. If you put k equals to 1, that doesn't matter. You cannot say that sir 1.5th harmonic will not be present. If I put n equals to 1, if I put k equals to 1, so what I will be getting? 3 by 2. So n equals to 3 by 2, that itself doesn't exist. There is no meaning of 1.5th harmonic. Harmonics will be integer, first harmonic, second harmonic, third harmonic. So directly in the examination, you don't need to do this process. In the examination, here you will see that when it becomes the multiple of pi, it could be odd multiple, it could be even multiple. If in the sinusoid you are having a multiple of pi, then it will throw 0. So when it will have the multiple of pi, n equals to 3, 6, 9, 12. Okay, so what we are getting? N equals to 3, 6, 9, 12. In that manner we are getting. So n equals to 3, 6, 9. In that manner we are getting. So what I can write down? N equals to 3k, where k is all the integer but not 0. Okay, so third harmonic, sixth harmonic, ninth harmonic, in that manner. Well and good. So these kind of questions are usually asked in the examination, that find out the absent harmonic. So there people might be thinking that sir, I would apply half wave symmetry there. Okay, in the first one half wave symmetry can be applied, it is fine. But always half wave symmetry will not be applicable. In half wave symmetry, you can only say that odd harmonics will be present, even harmonics will not be present. So here what you are seeing, that even harmonics are not present. That means second, fourth, sixth, eighth, even harmonics are not present. So yes, there is half wave symmetry in alpha equals to 4, but in alpha equals to 3, there is no half wave symmetry. Right? So for that you have to find out the value of Cn by the conventional method. But conventional method we have dropped because we know that we know the Fourier transform. Or you can apply the differentiation property, you will get the answer. By the differentiation property as well, you can find out the value of Cn. But we can use the Fourier transform property to find out the value of Cn as well. Right? What about this question? If this question is coming, you need to find the absent harmonic. What you will do in the examination hall? I'm telling you guys, not more than 50 people will be able to solve these kind of questions in the examination. Okay, not more than 50. Highest number 50, I'm telling. And a lot of forget about it. Yeah. So how will you solve this kind of question in the examination? You would get to know one thing, that I require the value of Cn, right? I require the value of Cn to tell the absent harmonics. Can I see any standard signal here that I can write down the Cn expression directly? Yeah, kind of I can see a triangular signal, right? A triangular signal in one time period I see a triangular signal, but this triangular signal is shifted downward. This triangular signal is shifted downward, right? If I shift it upward, if I shift this triangular signal by a, then what will happen? I will get a good triangular signal, and for that I remember the Fourier transform. Basically what I need to do, I need to shift this upward, and you know one thing, that if you are shifting a signal upward, then only your DC value will change, nothing else will change. So if I do xt plus a, then my DC value will change, harmonics will not change. So DC value I can calculate on my own, but here I don't need the DC value, I only need the absent harmonics. So what I will do, I will just shift this graph upward. When I shifted this upward, what I did, xt plus a. So if I shifted this upward, then my magnitude here become 2a, and this magnitude became 0. So all graph is shifted upward. So from 0 to 2 t naught by 3, this middle point is t naught by 3, then this is t naught. So in one time window, I can see a triangular signal. This is one time window. In one time window, I can see a triangular signal. What is this signal? The amplitude is 2a. So 2a triangular t minus center. Where is the center? Center is at t naught by 3. T minus center upon width of one side. What is the width of one side? T naught by 3. In triangular signal, we write down width of one side. To amplitude triangular t minus center upon width of one side. What is the width of one side? That is t naught by 3. So what will be its Fourier transform? 2a t naught by 3 sampling square. So a tau sampling square omega tau by 2. Right? A tau sampling square omega tau by 2. Tau by 2. Right? But along with that there is a shift as well. So e to the power minus j omega t naught by 3. Now if you need to write down the value of Cn, what you will do? Divide this with the t naught. So t naught will get cancelled. What you are getting? 2a by 3 sampling square n omega naught t naught divided by 6. Right? E to the power minus j n omega naught t naught by 3. What is the value of omega naught t naught? That is 2 pi. So this is 2 pi by 3. What I need to do? I need to make this as 0. One thing I am pretty sure that this will never throw 0. Complex exponential will never throw 0. This never throws 0. It can never be 0. And this can never be 0. 2a by 3. So only this guy is responsible for being 0. Now here what I am getting? Omega naught t naught. That would be 2n pi. I hope you are getting all these things, right? What we started with, we saw this expression. We got to know that it is not a standard expression. I can shift this upward. When I shifted this upward, this is the expression that I got, which is 2a triangular t minus center upon time width. Time width of one side, that is t naught by 3. So 2a t naught by 3 sampling square omega tau by 2 t naught by 6. This is very important. Whenever you write down this particular thing, you need to take care of you need to have good amount of patience. Along with that, you need to have good amount of patience here as well in case of triangular signal, right? Because in case of triangular signal, one width would come, but in case of a rectangular signal, the complete width will come, right? Now omega will be replaced with n omega naught. So n omega naught t naught will be 2n pi, and then 2a by 3. All these things are there. Now from here, can you tell the absent harmonics? Surely I can tell. N equals to 1, is there an issue? No. N equals to 2, is there an issue? No. N equals to 3, yes, there is an issue. So n equals to 3. N equals to 4, issue? No. N equals to 5? No. N equals to 6? Yes. N equals to 7? No. N equals to 8? No. N equals to 9? Yes. Because 9 by 9 to 18, 18 by 6 will be 3. So 3 pi, then there is an issue. So in that manner, these are the absent harmonics. So what all are the absent harmonics? And you are finding the absent harmonics for xt plus a. So in xt, these only will be absent. Only the DC value will change. So whatever the DC value you are getting for this one, minus a will be the DC value for xt. What I am saying, whatever the DC value xt plus a, whatever the DC value plus all the harmonics. So xt will have DC minus a plus the same harmonics. So harmonics, these will not change. Only DC value will change. So absent harmonics are n equals to 3k, where k is all integer minus 0. There you go. This is the answer. This is the final answer. Well and good. You do this question on your own. What you need to find? You need to find the power of 7th harmonic to the power of 5th harmonic. In the examination hall, how you would have solved it? Power you need to find. Ratio of power you need to find. You know power would depend, harmonic power. xt can be replaced as c naught, c1 e to the power j n omega naught t plus c of minus 1, in place of n you put 1. So if I ask you what is the power of first harmonic, that would be mod of C1 square plus mod of C of minus 1 square, because all are orthogonal to each other. So simply take the mod and then square, take the mod then take the square. So in that manner. So what they are asking, power of seventh harmonic, power of seventh harmonic, what that would be, mod of C of minus 7 square, and then power of fifth harmonic, that would be what is xt? Xt is odd. Xt is odd, right? If you take the mirror image, then another mirror image. That means C of n is equals to minus C of minus n. Mod of Cn is equals to mod of C of minus n. Basically, C of 5 is equals to C of minus 5. C of 5 is equals to minus of C of minus 5. But if you take the mod, then minus sign will be gone. So C of 7 will be equals, mod of C of 7 will be equals to mod of C of minus 7. That means this would be replaced as, and this would be replaced as C of 5. What you need to find? You need to find the ratio. Seventh harmonic to the power of fifth harmonic. Ratio you need to find, 2 and 2 will get cancelled. So basically you need the value of C7 and you need the value of C5. That means you need to find the value of Cn. So Cn you can find by differentiation property, or I told you, if you see a standard signal, then your job is done. Can you see a standard signal here? Absolutely not. No, there is no rectangular signal. This is a square, right? This is not a rectangular. Square of plus a and minus a. To make it rectangular, what you need to do? Shift it upward. If I shift it upward by a, because I care about fifth and seventh harmonic, I don't care about the DC value. And harmonics will not change if I shift the graph. So if I shift it up by a, then there will not be any issue. Right? So shift it upward by a, then you find out the Fourier transform. From Fourier transform you find out the value of Cn, and from Cn you comment on C of 7 and C of 5. So in between suddenly we are studying Fourier series, because this point I thought that I should be teaching you after teaching Fourier transform. In the Fourier series only, if I started to teach all these things, then it would be very difficult for you to understand all these kind of things. But now after studying Fourier transform, you have good amount of patience, you have good amount of understanding, so you can find out the value of Cn here. So do it on your own. I will take a break and then I will come back. Yeah, so did you try this one? What is our first step? That first we will shift it upward so that we get a rectangular pulse. So if I shifted it upward, so I am getting this amplitude will be 2a and this amplitude will be 0. So we are getting a rectangular pulse, right? This pulse we are getting with the time period of 2. So what will be this signal? What do we know the Fourier transform of this particular signal? Yes. What is that? 2a rect. In one time period I am getting a rectangular pulse, that is 2a rect t minus center upon time width. Time width is 1. 2a rect t minus center, center is at 1 by 2 upon time width. So what will be its Fourier transform? 2a sampling of omega tau by 2. A tau, 2a into 1 sampling of omega tau by 2. What is the value of tau? Tau value is 1. So this is something we are getting. Along with that there is a shift as well, e to the power j omega into 1 by 2, right? Now what we need to do? We need to find Cn. So for Cn what we will do? Divided by the time period. What is the time period? Time period here is 2. Sampling. In place of omega what I need to put? N omega naught divided by 2 j n omega naught divided by 2. What is the value of omega naught? Omega naught is pi, right? Because time period t naught is 2. So omega naught value is pi. Say yes or no, right? So what we are getting? A sampling of omega naught value is pi. So n pi by 2 e to the power minus j n pi by 2. So this is the value of Cn. If I find the mode of Cn, because what I required mode of C7, mode of C5. So if I find mode of Cn, so mode of Cn is A. Look, this amplitude A could be a positive number, it could be anything, it could be a what do we say, it could be an imaginary number as well. Here they have just written a, so a could be imaginary, it could be complex, it could be real. I don't care about that, so that's why I'm putting mode of a here. Okay, and then mode of sampling of n pi by 2. So this is your mode of Cn, right? So my mode of Cn is mode of a sampling of n pi by 2. What I need to find now? Mode of C5, mode of C5, that would be mode of a, mode of sampling of 5 pi by 2. That would be, basically I need the ratio. What is our answer? What is our answer? Our answer is mode of C7 square divided by mode of C5 square. This is our answer, because this is the ratio I require. This is the ratio I require. 2 and 2 will get cancelled, right? So mode of C7 square, this square, sampling of 7 pi by 2 square, divided by mode of a square divided by sampling of 5 pi by 2 a square. A square got cancelled. What we are getting? Sampling of n pi by 2. What is that? Mode of a sine of n pi by 2 divided by, in the examination or you will not be carrying this mode, right? You will be doing the rough calculation. Here we are doing it fairly, that's why I am carrying this mode. Basically you will not carry this mode, because you know that I will be doing the square, then eventually the number will become positive only, divided by n pi by 2. So here what is the value of sine 7 pi by 2? That would be equals to 7 pi by 2. At any multiple of pi by 2, the value will be 1 or minus 1. Pi by 2, sine pi by 2 will throw 1. Sine 3 pi by 2 will throw minus 1. Sine 5 pi by 2 will throw 1. Sine 7 pi by 2 will throw minus 1. But you don't need to care about 1 or minus 1. One thing you know, that at any multiple of pi by, at any odd multiple of pi by 2, you will get 1 or minus 1, and then it will be squared, right? Are you getting this point? Then it will be squared. So here what we are getting, a square getting cancelled. Upper side 7 pi by 2, although 7 pi by 2 is minus 1, but I don't need to care about this in the examination hall. Why is that so? Because I know that it will be squared, divided by 7 pi by 2 whole square. And what is the value at 5 pi by 2? That is 1. But I don't need to care about 1 or minus 1, because I know that it will be squared, right? So what we are getting? 5 pi whole square divided by 7 pi whole square. So pi will get cancelled, 5 whole square will be 25 divided by 49. Basically it was depending on n, nothing else. If you see the Cn, value, what do you see? It was a sine n pi by 2. Cn value was, if I talk about mode of Cn, let's talk about mode of Cn. So mode of Cn was mode of a sine n pi by 2 divided by n pi by 2. So for n equals to even, if you put n equals to even, so forget about the DC value. If you put n equals to 2, it will be 0. If you put n equals to 4, it will be 0. If you put n equals to 6, sine 3 pi, it will be 0. So Cn was 0. Cn was 0 for n equals to even. And Cn was inversely proportional to n for n equals to odd. Do you agree to this point? Here I should write down mode of Cn. Do you agree to this point or not? How? If your n equals to odd, let's just see n equals to 3. So what it will become? Sine 3 pi by 2. Sine 3 pi by 2 will be 1 or minus 1. I don't care about that, but mode will be there. So I basically don't need to care about 1 or minus 1. I don't need to care about the negative sign, right? Here what you will put? 3. So mode of Cn was mode of a, and then it will become 1 divided by 3 pi by 2. But I only need to take the ratio. So if I say that my mode of Cn was inversely proportional to 1 by 3. Basically here inversely proportional to n. So you can see that your mode of Cn is inversely proportional to n. So directly you could see that mode of Cn, the power of 7th harmonic divided by the power of 5th harmonic will be n square, 25 square divided by 49 square. Basically in the inverse proportion. So if I do the square here, then square also can come here. So for 5 square, 25 divided by 7 square, 49. This is the answer we are getting. Is that clear to you? So this is just mathematics now, nothing else. From here, everything is mathematics. Our task was to find till this point. At this point, you would get to know that now rest of the things will be mathematics only. Why it will be mathematics? Because I need to find the ratio. If I need to find the ratio, then I would know that 5 and 7. If they were asking the ratio of 4th harmonic to 7th harmonic, then you would know that 4th harmonic doesn't exist. So power would be 0. 0 divided by 7. Ratio would be 0 only. So 4th harmonic doesn't exist. 6th harmonic also 0. 2nd harmonic also 0. 8th harmonic also 0. But 5th harmonic is non-zero. 7th harmonic is non-zero. So you need to find out the values of Cn now. Is that clear to you or not? Right? So in the examination, first thing I will be looking at this is that can I get half wave symmetry? Yes, I can get half wave symmetry. So here there is a half wave symmetry. That means 2nd, 4th, 6th, 8th, these harmonics will not be present. So in the examination, if it was written that find out the power of 2nd harmonic to the power of 5th harmonic, then you would not have to solve this problem, because 2nd harmonic will have the 0 power. So 0 divided by anything will be 0 only. Are you able to understand this point? So basically find out the value of Cn and then calculate the ratio in this manner. This is the job. Okay, and all these things you don't need to care about much, that 5, 7, what will be the value. You just know that it will be 1 or minus 1. Although it was, let's just say it was not 1 or minus 1, it was something else, then also you don't need to care about that. Why is that so? Because these will be cancelled out. Sin 5 pi by 2 will be cancelled out to sin 7 pi by 2. Just you need to take care that whatever the value you are getting at sin 5 pi by 2, the same value should be at sin 7 pi by 2 as well. Just the mode would be there. So one will be minus 1, another one will be plus 1. So mode will cancel out the negative sign, right? So this kind of answer you are getting. Well and good. Let's move to this question. So again, I am taking the same kind of question. You need to find the Fourier transform of this xt. So you know that, sir, this is the method. This you have already taught us. That is that your Cn will be multiplied with 2 pi and you will be having impulses at all the discrete frequency. This method has been already taught to us, right? And sir, here the value of omega naught, you can see that time period is 3. So I can write down, sir, omega naught value is 2 pi by 3. So I can find out the value of Cn, my job will be done. So how I can find out the value of Cn? So in one time window, what is this time window? Minus 3 by 2 to 3 by 2. In one time window, I can see the triangular function. So what is my triangular function? 2 tri. So I will teach two things here. So have the patience. This is the first way. I will tell you another way as well. Because in the options, different ways could be there. For one question, there could be multiple answers. Just there could be different way of representing x of omega. So that's why I took this question again. The same kind of problem, whatever that we were solving previously. The signal was given, you need to find out x of omega. So for a periodic signal, you need to find out the Fourier transform. So for that, what we do? We try to get a standard signal, and here we are directly getting the standard signal, right? If we get the standard signal, then I can replace omega with n omega naught, and then I can divide it by time period to get the value of Cn. If I get the value of Cn, my job is done. I can write down my x of omega, right? So my target is to find out Cn value. So A try t minus center upon width. Width of one side is 1. Basically, this is the triangular signal, no? So A try t minus center, width of one side. So what it will throw? A2 sampling of omega 2 by 2. First I wrote down 2 triangular t minus center upon width of one side. So that will be A2 sampling of omega 2 by 2. Now what I need to do, if I need to find Cn, then I need to divide this by time period. Time period is 3, and replace omega with n omega naught, right? So what I will be getting? 2 by 3 sampling of n pi by 3. This is my Cn. So Cn value I have got here. So what I will be getting as my x of omega? So my x of omega will be 2 pi n goes from minus infinity to infinity. Cn value is 2 pi by 3 sampling of, how I am getting this value, because omega naught value is 2 pi by 3, so 2 and 2 will getting cancelled out and only pi by 3 I am getting, so n pi by 3, right? So what I am getting, 4 pi by 3, 2 pi into 2 by 3, so 4 pi by 3 summation n goes from minus infinity to infinity sampling of n pi by 3. This is my x of omega. So this option, okay, just one second. Then here del of omega minus omega naught, that I forgot. Del omega minus n omega naught. What is the value of omega naught? That is 2 pi by 3. So 2n pi by 3. So this option could be there in your examination. So this is one of the option. Well and good. Very easily I have find it out. First I got that triangular signal, then I wrote down the triangular signal, then I got to know that this is a sampling square, really sorry. A2 sampling square omega 2 by 2. Because this is triangular, no? So this is a blunder from my side. Sampling square, sampling square, sampling square. So A2 sampling square omega 2 by 2. So this is something that I am getting. Then omega is replaced with n omega naught, then divided by time period as well. Time period is 3. Then this is the value of Cn I am getting. Then I can put the value of Cn here, because I remember that Cn is multiplied with 2 pi with the impulses at discrete frequencies of omega naught, 2 omega naught, 3 omega naught, minus omega naught, minus 2 omega naught to minus 3 omega naught. Then omega naught value I put here. This is the expression I am getting. This is the expression of x of omega. Is that clear to you? Well and good. Now what could be the other way? Just see one thing. I am treating this as another signal yt. What I am doing? I am taking another signal yt. I am taking another signal yt. And the yt I am picking from this one time period. Are you able to understand this point? This yt I am picking from this one time period. This will be way 2, not method 2. This is not another method. This is way 2. Way 2. Okay. This is another way of representing it. So minus 3 by 2. 3 by 2. This is minus 1. This is minus 1. Well and good. This amplitude is 2. And this I am calling as yt. This is my yt signal. After that it is all 0. After that it is all 0. So this is the yt I have picked. Always it is 0 now. It is only a triangular signal. It is only a triangular signal. So there is no point of showing this 3 by 2 or minus 3 by 2. So this signal I am having. Now can you write down your xt as yt plus y of t minus 3. Basically if you shift this signal to right side by 3, then this 0 will come to 3. This 0 will come to 3. If you shift this signal, shift this signal to right side by 3. So y of t minus 3 plus y of t plus 3. Similarly you can do to this side as well. But there are like n number of these kind of triangular signal. So along with that there would be y of t minus 6 as well and y of t plus 6 as well. Say yes or no? Because time period is 3, no? Time period is 3. So 0, 3 and then at 6, 9, 12. In the similar manner 0, the center is at 0, then center will be at minus 3, the center will be at minus 6. So in that manner you are keep on getting these kind of things, right? So it will keep on going like this. Say yes or no? Agreeing to this point, right? So this is your x of t, which I will be copying to the next page. So from here, what will be your x of omega? That will be your y of omega. Yt will be replaced with y of omega. What this will be replaced with? E to the power j 3 omega y of omega. What this will be replaced with? E to the power j 3 omega y of omega. What this will be replaced with? E to the power minus j omega y of omega, plus what this will be replaced with? E to the power j 6 of omega y of omega, and so on. Now y of omega plus y of omega. Now e to the power minus j3 of omega plus e to the power j3 of omega. I divide by 2 and multiply by 2. Why I am doing so, you would have understood, right? Plus similarly here as well, 2y of omega e to the power minus 6 omega plus e to the power 6 omega divided by 2. What we are getting? X of omega as y of omega. I am taking y of omega as common. 2. What this will be? Cos 3 omega. Plus what this would be? Cos 6 omega. Then cos 9 omega and so on. Say yes or no. Can I write down the value of y of omega? Yes. What will be your y of omega? Y of omega will be, first you write down your yt. What is your yt? Yt is 2 triangular t minus center upon width of one side. That would be a tau sampling square omega tau by 2. So this is your y of omega. So your y of omega is 2 sampling square omega by 2. Plus 2 cos 3 omega, cos 6 omega, cos 9 omega, and so on. This is your x of omega. So this can also be mentioned in your final answer. Are you able to understand this point or not? Basically this can be written as 2 sampling square omega by 2 summation n goes from 0 to infinity. Why this is 2? Why this 2 is here? Okay, this 2 will be everywhere actually. This 2 will be everywhere actually. Right? This y of omega you are taking common. Okay, so 2 will be there everywhere. Y of omega you have taken common out. Okay, fine. Yeah, so can I write it down in this term? 2 sampling omega, then cos 3 n omega. 2 cos 3 n omega. That would be wrong actually if I write down cos 3 n omega. Because n, if I put 0, cos 0 is 1. So this will be 2. So it cannot be written like this. So it has to be written in this manner. Into 1 plus summation n goes from 1 to infinity. 2 goes outward. Cos 3 n omega. There you go. This could be also one of the option, right? Because if you put n equals to 1, 3 omega. If you put n equals to 2, 6 omega. If you put n equals to 3, 9 omega. And n equals to 4, 12 omega. In that manner, this is something that you are getting, right? So this could also be mentioned. So are you able to understand the point? That another way could be, this could be the first way, this could be the first way, and this could be the another way. Now this can be done with all the problems that we have studied previously. Let's get back to the previous problems. This we have seen. Yeah. So for this one as well, it could be done that you find the Fourier transform of this particular signal. Although we haven't find the Fourier transform of these kind of signals. For finding the Fourier transform, you know the Fourier transform of a triangular signal, right? Triangular signal is symmetric, but this is not the triangular signal. This is not triangular signal. So you don't know the Fourier transform of this particular signal. We will learn it. In the next lecture only, we will learn it. So once you have studied it, you will be able to write down the Fourier transform of this particular signal. Then you see that this signal is being repeated. Nothing but this signal is just being shifted by 1, right? If you keep this as your yt, then this would be your y of t minus 1. Why is that so? Because here where is the center? Center is at 1 by 2, and where here the center is at 3 by 2. So if this is your yt, if this signal is your yt, then y of t minus 1, basically shift by 1, because your time period is 1, here time period is 1. So if you shift by 1, so yt plus y of t minus 1 plus y of t minus 2 plus y of t minus 3, and in the similar manner y of t plus 1, y of t plus 2, y of t plus 3. So if you are able to write down the y of omega, then you know that there will be cosinusoid, because y of t minus 1, y of t plus 1, that will result in 1 cosinusoid. Y of t plus 2, y of t minus 2, that will result in cosinusoid. Y of t plus 3, y of t minus 3, that will also result in cosinusoid. So if your answer is given in terms of impulses, that means you need to find Cn. But if your answer is given in terms of cosinusoid, then you need to find in this particular manner. Now what may happen in the examination? So let me erase all this. In the examination, let's get back to our last question. In the examination, what if they are not saying that it is being repeated? What if they give only these 3 rectangular pulses? That means this is not a periodic signal. If it is not a periodic signal, then this method will fail. If it is not a periodic signal, then this method will fail. Cn value will fail, because you can find out the Cn value only for periodic signal. If I have said that this is 0 everywhere, this is also 0 everywhere, only 3 rectangular pulses I have given, that's it. So now this Cn method will fail. So what will be the answer of this particular signal? Are you able to understand what I am saying? What I am saying, let me frame a question. What I am saying, I will just frame a question. In the examination, I have framed this question. This is my xt, but this dot 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 is not there. So basically it is not periodic. What I am saying is that after this it is all 0. After this it is all 0. So now I am asking you, what is your x of omega? What is your x of omega? Now I am asking you this question. So can you apply the Cn method here? Can you find out the Cn value here? No, because xt is not periodic. Xt is non-periodic signal. That means which method I need to apply now? That this is my yt, then y of t minus 3, then y of t plus 3, that's it. So basically your xt is yt plus y of t minus 3 plus y of t plus 3. So what will be your x of omega? That will be y of omega e to the power minus j 3 omega, y of omega e to the power j 3 omega. So what we are getting? Y of omega, here you can take y of omega common, then 2 would come out, so it would become 2y of omega cos 3 omega, right? So what would be the answer? X of omega would be, y of omega we already know, which was 2 sampling square omega by 2, 2 sampling square omega by 2. This was your y of omega, and from here what we are getting, 1 plus 2 cos 3 omega. This is your x of omega. That's it. This is the answer. This is the only option that will be present. Are you able to understand this point? So this method that we studied here in the last, it can be useful for aperiodic signal as well. In aperiodic signal where a particular pulse is being repeated, not for infinite times. If this pulse is being repeated for infinite times, that means it will become a periodic signal. But if it is repeated only for 1 time or 2 times or 3 times or 4 times, that means it will not be a periodic signal. And for that, how we will find out? That one pulse is there, that is being repeated. So what I am doing, I am assuming another signal, and that signal is being shifted and added. Shifted, added. So all the shifted signal I am getting, and then I am adding them up. So if I add them up, then this kind of xt I am getting, and from there I can find out, by applying the basic property, I can find out this particular answer. Are you able to understand this point? So this method that we studied for multiple purpose. One for periodic signal. In the periodic signal, this kind of option can be present, or in the periodic signal, this kind of option can also be present. So if the option is present in terms of impulses, then you will do this analysis, and if the option is present in terms of cosinusoid, then you will do this analysis. Is that clear to you? Finding the Cn value is becoming easy for you now, because in the previous, if you just solve by the concept of Fourier series, then you would do the differentiation. Here also you would do the differentiation. Then you will get a rectangular pulse here, rectangular pulse downward, then again you will do the differentiation, and that will be a hectic process. But now we have understood a good method that if you know the Fourier transform of a particular signal, if you know the Fourier transform of a particular signal in one time window, then you can find out Cn value very easily, right? Let's get back here. Like here we did. Now for this particular signal, can you apply the concept of that Fourier transform? Like in this particular signal as well, you need to find the Cn value, right? So for finding the Cn value, can you say that in one time window, I will find out the Fourier transform? Do you know the Fourier transform of this particular signal? No. I don't know the Fourier transform of this particular signal because this is not a standard signal. If it was a standard signal, then I would be remembering the Fourier transform of this signal. But as of now, we don't remember it. That's why I applied the differentiation property. And with the differentiation property, I easily got the answer. With the differentiation property, I easily got the answer of Cn. But this will also have a shortcut technique. With the help of Fourier transform, you are not finding the Fourier series coefficient here. With the help of Fourier transform, you are not finding this Cn value. You are finding this Cn value with the method that we have already studied by the differentiation property, right? It might happen that differentiation property can become hectic in the examination hall. You don't want to apply the differentiation property. Then what you will do? You will apply Laplace transform here. So in such kind of signal where you don't know the standard Fourier transform, then with the help of Laplace transform, you can find out the Cn value. So I told you, for finding the Cn value, you can use the Fourier transform as well, you can use the Laplace transform as well. Okay. So whenever I can use Fourier transform, I will use the Fourier transform, then I will replace omega with n omega naught and then divide by t naught. After studying Laplace transform, I will tell you again, we will come back to this topic, and then I will tell you how to find the Fourier series coefficient using Laplace transform, because here I don't know the standard Fourier transform. Is that clear to you? The discussion is clear to you, the flow is clear to you, right? Why I have made the flow like this, that is clear to you. All good? All fine? I hope you are enjoying the lectures. Yeah. So that's it. But one important point or one very small point I forgot doing Fourier series. This is very standard point. This you can do on your own as well. What we are doing, we are just doing an important discussion for Fourier series. So this has nothing to do with Fourier transform. It will be a 5-minute discussion only. So this is something that I forgot in the Fourier series. That's why we are studying it here. So if your xt is even, surely your xt is periodic. Xt is periodic and it is even as well. So can I write down my xt in this manner? That it will be C naught and it will only have cosinusoid. Say yes or no? Now this is a constant value, no? C naught is a constant value. Can I replace C naught with A naught? Because it is a constant value. So what I am doing? I am replacing C naught with A naught. Now can I write it down in this manner? Summation n goes from 0 to infinity an cos n omega naught. Why is that so? Because if you put n equals to 0, what you are getting? A0 cos 0 omega naught t. What is the value of cos 0? That is 1. So when you put n equals to 0, you are getting A0 only. Plus A1 cos omega naught t. Plus A2 cos 2 omega naught t in that manner. Yes. So I can write down my xt as, what I can write down? My xt as summation n goes from 0 to infinity an cos n omega naught t, right? Cn can be written as an minus jbn by 2. So bn is 0 here, but an is non-zero. So from here an value is 2cn. So an value is 2cn. So what is your xt? Xt is 2cn. There you go. This is your xt. What about the scene when xt is odd? So basically your answer could be represented in this manner as well, or it could be represented in this manner as well. Both are the same thing if your xt is even. So two ways could be there to represent the answer. Basically in what it can be argued, that if xt is even, then xt can be represented as this. If xt is even, then xt can be represented as this. Yes. So in true false, this kind of option could be there, which is very simple. You can do it on your own as well, right? Even if I haven't taught you this particular concept, still you would be able to answer. But some guy asked this particular concept, so that's why I am dealing it here. Okay, so some guy as a doubt he asked you that can we write down in this manner? Yes, you can write down in this manner. Options can also be framed in this manner as well. Okay, so that's why I am dealing it here. So what about if xt is odd? So surely your DC value will be 0, only sinusoids will be present. So only sinusoids will be present. So sinusoids will go from 1 to infinity bn sin n omega naught t, right? And what is your Cn? Cn is an minus jbn by 2. Let's do it on the next page. So what is our Cn? Cn is an minus jbn by 2. This is 0. So what will be your bn? Bn can be written as 2jcn, right? Minus j goes here, it would be plus j. If minus j goes to the other side, then it would be minus 1 by j, and minus 1 by j will be plus j only. So 2jcn we are getting. 2jcn. So bn is equals to 2jcn. This is what we are getting. So what is our xt? Our xt is bn is 2jcn. So 2j can be taken outside. Here I could put from 0 to infinity as well, just for having the symmetry. Just for having the symmetry with this one, because here also you are putting 0 to infinity. So here also I am putting 0 to infinity, because if you put 0, sin 0 will be 0 only. So this value will be 0 only. So here also you can put 0 to infinity. So bn is 2jcn sin n omega naught t. Okay, so 2jcn sin n omega naught t. So here we are getting two kind of expression. This is the expression, or what I should have done is that let's take this as downward and copy this part. Copied this part, right? So these are the two possible answers. There you go. A very simple discussion, a very straightforward discussion. Nothing complex is there. So what was the target of this video? The target of this video was to understand that how to write down the Fourier transform of a periodic signal. Two methods we have studied. And now for writing down the Fourier transform of a periodic signal, you would require the Cn value. And you can find out the Cn value with the help of Fourier transform. If you know the Fourier transform of a standard signal, just write it down, replace omega with n omega naught, then divide by time period. That's it. You can find out Cn from there. All good, all fine. So I hope you enjoyed the lecture. So just revise it, and then let's move to the next lecture. There again we will see some property. So we will see the differentiation property now. Along with the differentiation property, we will understand other properties as well. Okay. So again we are going to move to the properties now. In between we took one lecture that was talking about your Fourier transform of periodic signal. So what we started with, first we started about basics of Fourier transform. Then we saw the properties. Then we saw the Fourier transform of some standard signal. In the standard signal, we took exponentials, then we took ut, signum t, delta t, and then we took rectangular and triangular sampling and sampling square. After that, we saw the Fourier transform of periodic signal. Now again we are moving to property. So again we will study property, and with the help of property we will find some more Fourier transforms. Okay, so our task is to find out the Fourier transform only. And where all these frequency analysis will be used, that will be used in sampling. So one use of this, all this process we will understand in sampling. Okay, so have the patience and keep on going in this manner. I hope Fourier transform is one of the finest chapter for you. I hope that. Yeah, thank you very much. Hi everyone, welcome back. So in this video we will study that we will be commenting on the nature of a particular signal by studying its frequency spectrum. The signal will be xt and the frequency spectrum will be x of omega. So there will be some information about x of omega and you need to comment on xt, or there will be some information about xt, you need to comment on x of omega. So that we are going to study, but before that there are some prerequisites, so that we need to study. And before watching this lecture you need to have good amount of concentration. Okay, have your full concentration here, otherwise you will not be able to understand this particular lecture. So have the full concentration and it will be very, very interesting. So there is a signal called y of omega. I am assuming there is a signal called y of omega, which is equals to angle of x of omega. Basically, the phase spectrum is represented by y of omega. The phase spectrum of xt, which is angle of x of omega, is represented by y of omega. Now I am asking, y of omega is even or odd, whether it is even or odd. So this spectrum you can see. So is this graph even or odd? What one would say that, sir, you take the mirror image and then you take another mirror image. So mirror image about y-axis and then mirror image about x-axis. So yes, we are getting the symmetricity here. That means yes, it is odd. So one guy, just by looking at this graph, he can say that, sir, it is odd, because one mirror image and then another mirror image I took. So it feels like it is odd. But if you look closely, minus pi and pi both are same, right? What is the value of e to the power j pi? Minus 1. What is the value of e to the power minus j pi? That is also minus 1 only. 2 pi and minus 2 pi both are same. What is the value of e to the power j 2 pi? That is 1. What is the value of e to the power minus j 2 pi? That is also 1. Pi and minus pi both are same. 2 pi and minus 2 pi both are same. Minus pi and pi both are same. So if I make this minus pi as plus pi, and if I take this minus 2 pi as plus 2 pi, and if I take this minus pi as plus pi, then what kind of graph I will be getting? So let's make that graph. So x of omega can be made in this manner, that whatever the negative angle, I am making all those angles positive. So at 3 omega naught, I was having the negative angle, but now I am making it positive, because minus pi is equals to pi. Minus pi is equals to pi. And minus 2 pi is equals to plus 2 pi. Now looking at the graph, what it looks like. What do you think? What is the nature of this graph? Now someone will say it is even. Here someone was saying that it is odd. So what did you understand by this concept? What did you understand by this particular question? That for a phase spectrum, there is no meaning of even or odd, right? Look, this is your pi. I could have written it as 3 pi as well, because pi and 3 pi both are same. Pi plus 2 pi is equals to 3 pi. So if you have taken one more round, that means pi and 3 pi both are same. So if I had made it as 3 pi, what I am saying is that, what I would have done, I would have copied the same graph and just I would have changed this pi as 3 pi, because what is the value of e to the power j 3 pi? What is the value of e to the power j 3 pi? That would be equals to e to the power j pi plus 2 pi. That would be equals to e to the power j pi into e to the power j 2 pi. What is the value of e to the power j pi? That is minus 1. What is the value of e to the power j plus 2 pi? That is 1. So e to the power j 3 pi is also minus 1, which is equals to e to the power j pi only. So this pi can be replaced as, or this pi can be replaced as 3 pi. This pi can be replaced as 3 pi. Now looking at the graph, what do you understand? This is neither even nor odd. So only one graph. This graph was saying that it is odd. This graph was saying that it is even, and this graph is saying that it is neither even nor odd. What do you understand by this conclusion? That for a phase spectrum, there is no meaning of even or odd. So in any textbook or in any notes, if you find out these kind of statement written, that phase spectrum will be even, phase spectrum will be odd, phase spectrum will be neither even nor odd, then those statements are wrong. There is no meaning of those statements, because phase spectrum can never be defined as even, odd, or neither even nor odd. Magnitude spectrum can be defined, but phase spectrum can never be defined. Is that clear to you or not? So phase spectrum, what is the meaning of this discussion? The only meaning of this discussion is that there is no meaning of, in phase spectrum, there is no meaning of even, odd, or neither even nor odd. That's it. This is the conclusion. So if you any day see that phase spectrum is even, because in test series you will find these kind of questions. In some other test series, not in PrepFusion test series, in some other test series you will find out that for if xt is real, then your phase spectrum will be even. Absolutely wrong. Doesn't make any sense. If xt is real, they will write down your phase spectrum will be odd. This is what they will write down. If xt is real, then your phase spectrum will be odd. Doesn't make any sense. Okay, because phase spectrum can never be defined as even, odd, neither even nor odd. So how we can comment on phase spectrum, that we will see. But as of now, this is the conclusion that we have made. So this was the first conclusion. So all these are prerequisite of something that we are going to study. Now x of omega can be written as mode of x of omega and angle of x of omega. This we can write down as mode of x of omega e to the power j angle of x of omega, because this is how the angle is represented, right? Are you able to understand this point? 2 plus let us say 1 plus j, 1 plus j. So I can write it down this as under root 2, which is the magnitude, e to the power j 45 degree, because here the magnitude is under root 2 and the angle is 45 degree. So similarly, x of omega is having the magnitude of mode of x of omega and angle of angle x of omega. So e to the power j angle x of omega. This is what I have written. In the similar manner, you need to write down all these things. X of minus omega, x of minus omega, x of minus omega. Okay. So let's write down x of omega here, x of omega here. So this was your x of omega. What will be your x of minus omega? Just in place of omega, you need to put minus omega. That's it, nothing else. In place of omega, you need to put minus omega. That will be your x of minus omega. This is the answer. Okay, all these are prerequisite. No one will ask you all these things in the examination hall, but they are prerequisite of something that we are going to study. Now, what about x conjugate omega? So, what is the meaning of conjugate? J will be replaced with minus j. That's it. J will be replaced with minus j. So, what did you understand from here? That in conjugate of x of omega, the magnitude remains same. The magnitude remains same as mode of x of omega only, but the angle became negative. So whatever the positive angles were there, they became negative, and negative angle became positive. If you take the conjugate, then there is no change in the magnitude. The magnitude remains the same, but angle becomes negative. That means positive angle will become negative angle and negative angle will become positive angle. And what about x conjugate minus omega? So in this one only I will replace, in place of omega I need to replace minus omega. That's it. So nothing here you need to mug up. You don't need to mug up anything here. But you should be having the habit of writing down these expressions. And if you are having the habit of writing down these expressions, then you would be able to comment all these things. Right? Here, what was the magnitude? This was the magnitude. So you cannot say that both are same, both are different. Right? Both could be different. And angle is also different. Basically, in the angle, you are just simply taking the mirror image. Here, whatever the angle was there, whatever the graph was there, if you just take the mirror image with respect to angle, then you will get the x of minus omega phase spectrum. And same goes for your magnitude spectrum as well. You just need to take the mirror image, nothing else. And sorry, here minus omega I need to put. So here for the spectrum, I need to take the mirror image. For the phase, for the magnitude spectrum, I need to take the mirror image. But for the phase spectrum, you need to take the mirror image as well. Along with that, you need to multiply by minus 1 as well. Basically, positive angle will become negative angle and negative angle will become positive angle. All good for you? All clear? Right? So, just basic discussion we are doing. Now, the similar thing I am asking, what is the, find the relation between mode of x of alpha and mode of x of alpha where x of alpha is being conjugated. So, you know one thing that magnitude spectrum will not change if I take the conjugate, and you can verify it here. This was your x of alpha. So what is your mode of x of alpha? that is under root a alpha square plus b alpha square. This is your mode of x of alpha. And if I take the conjugate, then what will be my x conjugate alpha? That will be a alpha minus j b alpha. And what will be its mode? Its mode will be under root a alpha square plus b alpha square. So what did you get to know from here? That mode of x of alpha is equals to mode of x conjugate of alpha. That means taking the conjugate will not change the mode. Taking the conjugate will not change the magnitude spectrum. All good? All good for you? Okay. Now we are starting our concept. If your xt is real, then you need to comment on the magnitude and phase spectrum. Okay, you need to comment on the magnitude and phase spectrum of x of t. If xt is real, what does that mean? That x of t will be equals to x conjugate t. These things we have already studied. Like at least 20 times we have repeated these kind of things. What is the Fourier transform of x of t? X of omega. What is the Fourier transform of x conjugate t? You take the conjugate, along with that there will be a negative sign as well. Along with that there will be a negative sign as well. Well and good. Now, can you write down the phase? Can you write down it in this manner? That mode of x of omega e to the power j angle of x of omega. How will you write this down? Mode of x conjugate minus omega and e to the power j angle of x conjugate minus omega. Right? Now just tell me one thing. What if your x of omega is this? Then what will be your x conjugate omega? Here there is an angle sign. Sorry, there is an angle sign. If you just take the conjugate, then what will happen? This plus sign will be changed to minus sign. And secondly, if I write down minus here, then what will happen? This is something will happen. Just if I take the conjugate, then plus j will be replaced with minus j. Nothing else will change. Now in place of omega, I need to put minus omega. That's it. In place of omega, I need to put minus omega. And if I take the conjugate, this will not change. Right? So this is just in place of omega, I am putting minus omega. Nothing else is changing. So what did you understand here? That mode of x of omega e to the power j angle of x of omega is coming out to be mode of x of minus omega. This is some separate discussion. This discussion is separate. E to the power minus j angle of x of minus omega. Say yes or no. Now again I am writing down mode of x of omega e to the power j angle of x of omega will be equals to mode of x of minus omega. Can I write it down in this manner? j2 and pi. Will that make any difference? What is the value of e to the power j2 and pi? Another discussion I am doing here. Although I have already done it. What is the value of e to the power j2 and pi? That would be equals to e to the power j2 pi to the power n. What is the value of e to the power j2 pi? 1 to the power n. Value will be 1 only. So I can write down e to the power j2 and pi here. Minus angle of x of minus omega. Basically what I did here is that I just introduced, out of nowhere I just introduced this particular thing, and then this was already there. This was already there. Now angles can be added. So here the angle is 2 n pi and here the angle is minus angle of x of minus omega. So minus angle of x of minus omega. Right? So from here what you can see? What all two things you can conclude? you can see that this magnitude to magnitude I will compare and angle to angle I will compare. So here I should have written angle of x of omega. So magnitude to magnitude, angle to angle. So mode of x of omega is equals to mode of x of minus omega, right? And angle to angle, angle of x of omega will be equals to 2n pi minus angle of minus omega. So from here what we are getting, angle of omega plus angle of x of minus omega is equals to 2n pi. And this is the another thing we are getting. What you can get from here, the magnitude spectrum is even. Say yes or no. Mode of x of omega is equals to mode of x of minus omega. Let's just say y of omega is equals to mode of x of omega. This is what I am saying. Then what will be your y of minus omega? That would be mode of x of minus omega. Now y of omega is coming out to be y of minus omega. Now we have the habit of looking at it in terms of t. So y of t is coming out to be y of minus t. Just I am replacing omega with t. I am not taking inverse Fourier transform. Don't think that I am taking inverse Fourier transform. No, no, no. I am just telling that can I say that my y of omega is even? Say yes or no. In any function, if I take its mirror image and that is coming out to be the same. When I took the mirror image, there was no difference. If it is coming out to be the same, what does that mean? That that particular function is even. That means magnitude spectrum is even. Magnitude spectrum is even. In some way you would find out that what they would do, angle of x of omega is equals to minus angle of minus omega. They will not introduce this 2n pi. Then they will say that phase spectrum is odd, because this is the odd graph, right? Minus sign is coming out. When I took the mirror image, sorry, not mirror image, mirror image only. So when I took the mirror image, what is happening? Minus sign is coming out. So what does that mean? It is odd. So someone would say that magnitude spectrum is even and phase spectrum will be odd, but that is not making any sense, right? Because in case of angle, you can never ever define whether it is even, odd, or neither even nor odd. So what you will say? The addition of x of omega to the x of minus omega, basically x of omega and x of minus omega added will give you odd multiple of pi, right? So magnitude spectrum is even and this is giving you, the addition is giving you odd multiple of pi. Sorry, not odd multiple of pi, even multiple of pi. Really sorry, even multiple of pi. 2n pi is there, no? So if you put n equals to 0, you will get 0. If you put n equals to 1, 2 pi. If you put n equals to 2, 4 pi. So what did you understand? If your xt is real, then magnitude spectrum even, along with that angle of x of omega plus angle of x of minus omega will give you 2n pi. There you go. This is the conclusion. You will be able to remember it. No need to worry. So all the real world signals will have a even magnitude spectrum. Now are you able to understand what is the meaning of these negative frequencies? Look, whenever e to the power minus at ut, what was its Fourier transform? 1 upon a plus j omega. What was the magnitude spectrum? 1 upon a square plus omega square under root. We draw the magnitude spectrum something like this. So we define it for positive frequency, we define it for negative frequency as well. Sir, what is the meaning of negative frequency? You have always said that frequency will be positive. What is the meaning of frequency? That how many cycles you cover in 1 second, that is frequency. So what is the meaning of negative frequency, sir? Can you cover minus 1 cycle in 1 second? What is the meaning of minus 1 cycle? So there is no meaning of negative frequency. All the real world signal has to be even. All the real world signal has to be even when we talk about magnitude spectrum. So if you want to make it even, that means you need to define the negative frequencies, no? Like I cannot say that my magnitude spectrum is something like this. That's it. This is my magnitude. This is my magnitude spectrum, which will be wrong. If I say that this is my magnitude spectrum, then this signal can never be real. So for a real signal, you need to define the negative frequencies, the same negative frequency. That's it. Is that clear to you? All good. So this is the meaning of negative frequency, because some people will be having the doubt that, sir, why negative frequencies also we show? What is the meaning of negative frequency? And negative frequency just shows the circulation in the other direction. If I write down e to the power j 2 pi t, do you remember the explanation of complex exponential? Complex exponential, I took 1 hour to understand, to make you explain this complex exponential. So if I took e to the power j 2 pi t, that means in 2D it will look like circle, but in 3D we are actually moving ahead, but we are moving in the anti-clockwise direction. So on the circle we were moving in the anti-clockwise direction, but if I take this as negative, then on the circle we will move in clockwise direction. So negative frequency is just showing the rotation, nothing else. E to the power j 2 pi t, that means circulation is there in the anti-clockwise direction, and e to the power minus j 2 pi t, circulation is there in the clockwise direction. So there is actually no practical meaning of negative frequency. This is what I was telling. Okay, because this doubt could be there in the starting of Fourier transform, but at that time I did not take this doubt, because I know that when I am teaching xt is real, then this kind of spectrum I will be getting, and there I will be telling you why we make negative frequencies as well. Because if we don't make negative frequencies, then there is no chance that you can make your magnitude spectrum even, and if you cannot make it even, then it can never be a real world signal. So for all the real world signal, you need to show the negative frequencies. Okay, and the magnitude spectrum for a real world signal or for a real signal, it will be even. And what about the phase? So phase spectrum, so for positive frequency, this is the angle made by the positive frequency, and this is the angle made by the negative frequencies. Are you able to understand this point? Basically, if I draw the graph of x of omega, so here I am saying that this frequency is 1 radian and this frequency is minus 1 radian. This is making an angle of pi, and this is making an angle of minus pi. So I can say that this is pi and this is minus pi, and this is something I need to add up, because what I need to add up, angle of x of omega plus angle of x of minus omega. So pi minus pi will be 0, which is equals to 2n pi. Yes, that means surely here angle of x of omega plus angle of x of minus omega is showing you 2n pi. Now you need to see at the magnitude spectrum. If your magnitude spectrum is coming out to be even, then surely your x of t will be real. Although problem solving or some examples, everything we will see, but as of now, are you able to understand the conclusion of this discussion? Because the conclusion is very important. You should know the derivation as well. This is not the derivation, this is just simple intuitions, nothing else. That this is how you will write it down. This is how you can write it down. Then you know that there is no meaning of the conjugate when we talk about the mode. So if we talk about the mode, then you can remove the conjugate. But in the angle, if there is a conjugate, that means plus j should be replaced with minus j. So you actually don't need to follow all this process. Directly from here to here you can come. If mode is there, no meaning of conjugate. If in the angle there is conjugate, then plus j will be replaced with minus j. So how to remove this conjugate, that you have understood. In case of mode, nothing. In case of angle, plus j will be minus j. And then you can add this up. So from here you get to know that they are even, and angles are, when positive frequency added to the negative frequency, it should throw 2n pi. Right? The same discussion will go for if xt is imaginary. So if xt is imaginary, then you need to comment on magnitude and phase spectrum. So you will do it on your own. If xt is imaginary, that means x of t will be equals to x conjugate t, but there will be a negative sign outward. So this already we have seen. That means x of omega, x conjugate of minus omega. What will be its mode? Can I write it down in this manner? J angle of x of omega. Right. There is a minus sign, so keep this minus sign as it is. E to the power j angle of x conjugate minus omega. So keep this minus sign as it is here. In case of mode, there is no meaning of this conjugate. Well and good. Oh, sorry. In case of mode, there is no meaning of this conjugate, so I have removed this conjugate now. In case of angle, if there is a conjugate, then minus sign should come outward. What I can do of this minus 1? Take this as e to the power j pi. E to the power j pi, right? Or you can take this as e to the power j. Let's write down this thing. You can take this as e to the power j 2n plus 1 pi. Why is that so? Another discussion. E to the power j 2n plus 1 pi will be equals to e to the power j 2n pi into e to the power j pi. What is the value of e to the power j 2n pi? That is 1 is equals to e to the power j pi, that is minus 1 only. So e to the power j 2n plus 1 pi is equals to minus 1. So this is equals to minus 1. Along with that, there is another angle, which is this particular thing, and this is equals to this thing, right? So from here, what you are getting, compare magnitude with magnitude, what you are getting, mode of x of omega is equals to mode of x of minus omega, right? What about the angle? Angle of x of omega, angle of x of omega is equals to 2n plus 1 pi minus angle of x of minus omega, minus angle of x of minus omega. That means from here what we are getting, angle of x of omega plus angle of x of minus omega is equals to 2n plus 1 into pi. So from here what we are getting to know, magnitude spectrum is again even, but when you add up the phase of positive frequency to the phase of negative frequency, then you are getting the odd multiple of pi. In the previous case, what you were getting, even multiple of pi. So what you have to know, that if your xt is imaginary, then if your xt is imaginary, then mode of x of omega, or what did I write down here? What did I write down here? Magnitude spectrum. Okay. So similarly here also I will write down the same thing, that magnitude spectrum will be even. Even if it is imaginary, again the magnitude spectrum is even. But what about the angle? For the angle we cannot define even or odd, so we will write down this thing. There you go, this is the answer. Okay, just a second, I just got someone, just 1 second. Yeah, so from here what did you understand? If I say that my magnitude spectrum is even, can you say that your xt will be always imaginary? No. If your magnitude spectrum is even, then your xt could be either imaginary or it could be real. But if I say that addition of angle of positive frequency to the negative frequency is odd multiple of pi, then surely it will be imaginary. And addition of positive frequency to the addition of negative frequency is equals to even multiple of pi, then surely it will be real. And rest all the cases, that means xt is complex. Rest all the cases. Okay, so let's write down the conclusion. Have some patience. Okay, if mode of x of omega is even, if your magnitude spectrum is even, then your xt could be real or imaginary. You cannot say, it could be either real or imaginary. Say yes or no. Is this discussion clear? Look, these kind of concepts, hardly 10 people will be able to answer in the examination, or hardly 10. A very good question we can frame on this kind of concept. Now if your mode of x of omega is not even, I did not even write down odd here. Just tell me one thing, mode of x of omega can ever be odd? Can you make mode of x of omega odd? No, because if we take the mode, this is a odd signal, but if I take the mode, then what will happen? Negative part will become positive part. Here also you are having the positive part, here also you are having the positive part. So it can never be odd, because in the odd what we do, we take one mirror image and then another mirror image. one mirror image and then another mirror image. So there has to be negative part for the odd signal, but this can never be odd. So the conclusion is that your phase spectrum, sorry, that your magnitude spectrum can never be odd. So either it will be even or it will be nothing. So if it is even, if your magnitude spectrum is even, then either your xt will be real or it will be imaginary, right? But if it is not even, what does that mean? It has to be complex. Say yes or no. Is this conclusion clear to you? Right. Now if your angle of x of omega, angle of positive frequency to the addition of angle of negative frequency, if it is coming out to be even multiple of pi, if it is coming out to be even multiple of pi, then your x of t will be real. Is it sure? Only this information is given. Only this information is given. They did not talk anything about x of omega, mode of x of omega. What I am saying, only this information is given. They did not say anything about mode of x of omega. Then here you cannot say that surely it will be real. No. For real, what is the condition? This condition should be satisfied. Along with that, this condition should also be satisfied. What if only this condition is satisfied, but mode of x of omega is something like this? What I am saying, this condition is surely satisfied. But what if mode of x of omega is not even? What you will do then? Are you able to understand this point? So it would be real or complex. And if it is odd multiple of pi, so it would be either imaginary or complex. And if angle of x of omega is anything except is these cases, then it cannot be real, it cannot be imaginary, it has to be complex. So is this discussion clear to you? We will see how to solve the problem. But what is the conclusion that we have made? That if my mode of x of omega is coming out to be even, if it is coming out to be even, then I will be interested that whether my xt will be real or imaginary. But if it is not coming out to be even, then surely my xt will be complex. So discussion will be over there. Now my mode of x of omega is even. That means I have two chances, real or imaginary. So now I will go to the angle. Now if I see the angle, addition of positive angle to the addition of positive frequency angle to the addition of a negative frequency angle, if they are throwing even multiple of pi, then it will be real. If they are throwing odd multiple of pi, then it will be imaginary. And if they are throwing anything else, then it will be complex. Is this discussion clear to you? Is this roadmap clear to you? That x of t is having its frequency spectrum you can say, or Fourier transform you can say, as x of omega. Then first I will look at magnitude spectrum. It would be either even or it would be not even. If it is not even, my job is done. My xt is complex. But if it is even, then I have two chances, whether it will be real or imaginary. So here I have two chances, xt will be real or imaginary. I have two chances there. Now to differentiate between real or imaginary, where I need to go? I need to go to angle of x of omega. So angle of x of omega plus angle of x of minus omega. If that is throwing even multiple of pi, that means it is real. And if it is throwing odd multiple of pi, then that means it is imaginary. Say yes or no. All good? All fine? Say yes or no. Let's solve some questions now. So x of omega versus omega is given. It is real, imaginary, complex or none. So first I need to draw mode of x of omega. So can I draw mode of x of omega? Yes. So I need to draw mode of x of omega. So I am just copying this graph. If I need to take the mode, what does that mean? That this negative part will become positive part. Negative part will become the positive part. So this is my mode of x of omega. So here, what is this? This is even. And if mode of x of omega is coming even, that means it could be real / imaginary. So at least these options I have cut now, right? It would be either real or imaginary. Now angle. So a positive value here, it is a triangular function, but always it will throw a positive value, no? So positive value means 0 degree angle, or pi, or 2 pi, or 4 pi, or anything. And negative values means here every value is negative. Here the value is 0, so I don't care about this. Value is 0, value is 0. 0 means 0 degree angle, 0 magnitude, nothing else. So I don't care about this 0 value. But here the value is 0, 2 pi, 4 pi. Sorry, the angle is 0, 2 pi, 4 pi, 6 pi, anything. So positive value will throw 0 degree angle and negative value will throw pi angle, right? You can write down plus pi, minus pi, or simply you can write down, here also you can write down the same thing, plus minus 2 pi, plus minus 4 pi. So here you can write down plus minus pi, plus minus 3 pi, and so on. Similar for here as well. So let's draw the graph of angle of x of omega. If I draw the graph of angle of x of omega. So between 3 to 4 you are having 0 degree angle. 0 degree angle. Angle is 0 degree. Or you can say 2 pi. Let's call it 2 pi. Okay. 0 degree, or let's call it 2 pi. And between 5 to 6 you are having minus pi. Let's call it minus pi. You can call it plus pi as well, but let's call it minus pi. Here between minus 3 to minus 4 you are having minus pi. And here between minus 5 to minus 6 you are having plus 2 pi. Plus 2 pi you can say, or 0 degree also you can say, but here I prefer to say plus 2 pi. So this is your angle of x of omega. Minus 6 to minus 5, minus 4, minus 3, 0, 3, 4, 5, 6, 2 pi, minus pi, minus pi, and 2 pi. What I can see here, angle of, let's just say I take the angle at 3.5, angle of x 3.5 plus angle of x minus 3.5. Here the angle is plus 2 pi, here the angle is minus 3.5, here the angle is minus pi, here the angle is plus 2 pi, here the angle is minus pi. Basically this is equals to pi, 2 pi minus pi. What is the answer we are getting? Pi. Angle was 2 pi, angle was minus pi. Another value I can check, angle of, let's take at this point 5.5 plus angle of x of minus 5.5. Why I am doing at minus 5.5? Because I know that I need to check the angle at positive frequency and the same negative frequency. Because what I need to check? I need to check this particular thing. So in place of omega, if I put 5.5, then here I will put minus 5.5. So here at 5.5 the angle is minus pi, and here at minus 5.5 the angle is plus 2 pi. So again, what is the answer I am getting? Pi. Now someone will say that, sir, check here at 2 and minus 2. So you don't need to check where the values are 0. Are you able to understand this point? Where the values are 0, you don't need to check. If value is 0, then angle is also 0. Basically, what is the scenario? Here, if your x of omega becomes 0, then this will be 0, this will also be 0. 0 is equals to minus 0. So yes, here this condition is satisfied. So wherever your frequency spectrum is 0, you don't need to care about that particular point. When it is non-zero, only that point you need to take it. Only that point you need to care about. What I mean to say is that if my x of omega is 0, then this will also be 0. Then 0 is equals to minus 0. The condition is satisfied here as well. So you can say yes, it is imaginary only, and the condition is satisfied here as well. If I put x of omega is 0, 0 is equals to 0. So condition is satisfied here as well. So 0 cannot comment on anything. Are you able to understand this point? Okay, so whenever your frequency spectrum is 0, we will not care about that particular thing. Right? So whenever it is non-zero, whenever my frequency spectrum is non-zero, what I am getting? This equals to pi. What does that mean? It is odd multiple of pi. What does that mean? Between real and imaginary, who won now? Imaginary is winning the game. Right? So what is the answer? Imaginary. Because if it is having a odd multiple of pi, then answer would be imaginary. So what is xt? Xt is imaginary. Is that clear to you or not? A very good discussion, right? Okay. What about this one? Comment on xt. Comment on x of omega, sorry, comment on xt. So if I draw the mode of x of omega, if I draw mode of x of omega, I am pretty sure that it will not be even. What I am pretty sure, that mode of x of omega will not be even. Not even. What does that mean? xt is complex. There you go. Job is done. If it is not even, then it can neither be real, it can never be, it can nor be imaginary. It will be complex. And discussion is done here only. If you feel like that, if you get to know that x of omega, mode of x of omega is not even, then discussion is done. It is complex only. There you go. Right. So first thing, I will always look at mode of x of omega. So here if I look mode of x of omega, what do I see? It is even. So from here what you can comment, that x of t could be either real or it could be imaginary. But who will win the game, that we don't know. Then we came here. What we saw? Angle pi by 2. At negative frequency the angle is 3 pi by 2. Pi by 2 plus 3 pi by 2. At A you are having angle of pi by 2. At minus A you are having angle of 3 pi by 2. 2 pi. At this is plus C. At C you are having angle of minus pi. And at minus C you are having angle of pi. 0. At B you are having an angle of 0. Wherever the angle is 0, I don't need to care about that thing. So I am not caring about the 0 angle. So what did you get to know? 2 pi 0. That means angle of x of omega plus angle of x of minus omega is coming out to be even multiple of pi. What does that mean? That xt is your real. So here can you say that angle of x of omega is a even graph, odd graph? Nothing you can comment, right? Even graph, odd graph. So there is actually no meaning of even or odd signal in terms of phase spectrum. So phase spectrum can never be even, it can never be odd, it can be nothing. You cannot even comment. So here we got to know that x of t is real. Yes or no? Now we will see more things. So this was one concept that is clear to you, right? If the conclusion is of 2 minutes only, within 2 minutes you will be able to revise this 45 minutes thing. What is the conclusion? That first we need to see mode of x of omega. If it is coming out to be even, then it could be real or imaginary. Then your xt could be real or imaginary. But if it is coming out to be not even, then my job is done, my xt is complex. Now if your mode of x of omega is real, if mode of x of omega is even, then you need to go to the phase spectrum now. So in the phase spectrum what you will do, you will add up the angle of positive frequency to the same negative frequency, and in all of them, if they are coming out to be the even multiple of pi, then your x of t is real. If they are coming out to be odd multiple of pi, then your x of t is imaginary. So this was a very good discussion, which was very, very important. Okay, so this is the conclusion, right? And we have seen 3 questions as well. Now we will see more thing, that if your x of t is even, then what will happen to x of omega? If x of t is odd, then what will happen to x of omega? If x of omega is real, then what is the meaning of x of t? If x of omega is imaginary, then what is the meaning of x of t? So nothing you need to mug up, only you need to remember this particular graph. This particular graph you need to remember, and here we will just derive everything. Here we will derive everything, so you don't need to mug up anything. So we will just see it after a break. I will take a break and then we will proceed. Okay, so let's start. So if x of t is even, then you need to comment on x of omega. So if x of t is even, that means x of t is equals to x of minus t. Now what is the Fourier transform of x of t? That is x of omega. What is the Fourier transform of x of minus t? That is x of minus omega. So what you are getting? X of omega is equals to x of minus omega. What does that mean? That means that x of omega is also even. So if your signal is even, then its frequency spectrum will also be even. You can remember the example of cos omega naught t. So in cos omega naught t, these 2 kind of impulses we got. So cos omega naught t is a even signal, and the frequency spectrum was also even. right? And with very basic mathematics you have proved it. What about if xt is odd? If your xt is odd, then x of t will be equals to minus of x of minus t. Then x of omega would be equals to minus of x of minus omega. From here, what did you get to know? So these kind of questions can be asked in the statement that a real signal will have, a even signal will have a even frequency spectrum, and a odd signal will have a odd frequency spectrum. There you go. Okay, very basic question, very straightforward. You can remember the example of sine omega naught t. So there was one impulse like this, another impulse like this. So it was also odd. So this was also odd, right? If x of omega is real, x of omega is real, x of omega is real. This is the meaning of real, right? If you take the conjugate, then there would be no meaning. There wouldn't be any effect by taking the conjugate if your x of omega is real. So what will be the inverse Fourier transform of x of omega? That would be x of t. Inverse Fourier transform of x of omega, that would be x of t. And what will be the inverse Fourier transform of x conjugate of omega? So xt is having a Fourier transform of x of omega. X conjugate t is having a Fourier transform of x conjugate minus omega. Now x conjugate minus t will have a Fourier transform of, if t is replaced with minus t, because x of minus t always have a Fourier transform of x of minus omega. So if t is replaced with minus t, here t is replaced with minus t, so this minus omega will be replaced with plus omega. Are you able to understand this point? So this will be the inverse Fourier transform of x conjugate minus t. Because if you just take the conjugate, then here negative sign would come. But if you have taken minus t, then negative will become positive. So x of t is equals to x conjugate minus t. What does that mean? X of t is conjugate symmetry. Again, in the statement wise problem, what they can ask, that a frequency spectrum, they are not talking about the magnitude spectrum, or they are not talking about the phase spectrum. They are just saying that frequency spectrum is even, the frequency spectrum is real. That means your xt will be conjugate symmetric. If they are specifically talking about if they are specifically talking about magnitude spectrum or phase spectrum, then you need to think xt is real or imaginary. But as of now, what they are saying, that your frequency spectrum, complete frequency spectrum is real. So from there you go to know that my x of t is conjugate symmetry. And if your x of omega is imaginary, so nothing you need to remember it, okay? You don't need to remember it that x of omega is real, then this would be the condition. No. You should be able to derive it there. If x of omega is imaginary, then this should be the condition. What will be the inverse Fourier transform? X of t. What will be the inverse Fourier transform here? X conjugate minus t, but minus sign would come out. So from here, what you get to know? X of t is conjugate anti-symmetry. There you go. Right? Now, can you fill this table on your own? If x of t is real and x of t is even, then also x of t will be conjugate symmetry. Do you remember this table when we studied our Fourier series coefficient Cn? Because all the properties are same. Basically, x of t is having a Fourier series coefficient of Cn. X of t is having a x of omega, Fourier transform of x of omega. Then what will be the Fourier series coefficient of x of minus t? That would be c of minus n. What will be the Fourier transform of x of minus t? That is x of minus omega. So here n is replaced with minus and omega is replaced with minus omega. All properties are same. X conjugate t will have a Fourier series coefficient of c conjugate n is replaced with minus n. Similarly, x conjugate t will have a Fourier transform of conjugate will come, omega will be replaced with minus omega. So everything is same. So whatever that we have studied in our Fourier series coefficient, the same thing we are studying for Fourier transform as well. And there we proved it. There in the lecture we have already proved it, that if xt is real and imaginary, if xt is real and even, then xt will be conjugate symmetry as well. And how do we remember it? Real, even and conjugate symmetry, these are the good guys. And odd, or you can say imaginary, odd and conjugate anti-symmetry, they are the bad guys, right? So good guy plus good guy, real plus even, good guy plus good guy will make a good guy. Good guy real plus bad guy will make a bad guy. Bad guy plus good guy will make a bad guy, and imaginary plus odd, bad guy plus bad guy. Two bad guys are there, then certainly they will make a good guy. Or you can remember in the like this is positive. Good guy means positive. So positive into positive will be positive. Positive into negative will be negative. Negative into positive will be positive. And sorry, negative into positive will be negative. And negative into negative, negative into negative will be positive. So basically, good guy will make good guy. Bad guy will make good guy. Good guy plus bad guy will make bad guy. And bad guy plus good guy will make bad guy. So this is the way to remember, nothing else. And then here, comment on x of omega. How will you remember? If even is there, then nothing will change. So real plus even plus conjugate symmetry. If odd is there, then everything will change except odd itself. So odd will say that I will be there as it is because I am the deciding guy. Now real will be replaced with imaginary. Odd will say that I will be there as it is, and conjugate anti-symmetry will become conjugate symmetry. If even is there, nothing will change. So imaginary plus even plus conjugate anti-symmetry. So if even is coming, then the same thing is getting out. Even is coming, the same thing is getting out. But if odd is coming, then odd will say that I will be there as it is, but real will become even and conjugate anti-symmetry will become conjugate symmetry. What this odd will say? That imaginary will become real, odd will say that I will be there as it is, and conjugate symmetry will become conjugate anti-symmetry. In the worst case, if you forget this table, then any day you can derive it in the examination hall. What they can say in the examination hall? That your x of t is imaginary plus even. Comment on x of omega. So what you will do? X of t is imaginary. X of t is imaginary. So from here you get to know that x of omega is equals to x conjugate minus omega minus sine. So from here you get to know that it is conjugate anti-symmetry. First conclusion. Second thing, x of t is even. X of t is even. X of t is even. So you get to know that this is also even only. So x of omega is even as well. Second conclusion you have made out. Third conclusion, for the third conclusion you need to get out another thing. So here you can see that your x of t is equal to x of minus t. So here I can replace that x of t. Here x of t conjugate is there. So what I can get? X of t is equal to x of minus t. So here in place of x of t I am replacing x of minus t. So minus sign as it is, then I am taking the conjugate. Basically in this equation, in place of x of t I have put x of minus t. So from here what do I get to know? X of omega is equal to x conjugate omega. Because of the negative sign, another negative sign came, and then minus sign here. So what did you get to know here? That your x of omega is imaginary as well. So imaginary plus even plus conjugate anti-symmetry. Imaginary plus even plus conjugate anti-symmetry. So in the examination hall, any day you can derive it. It will take you hardly 1 minute. If you don't remember the table, then you can derive it as well. If you remember the table by the help of good guy, bad guy, then it will be easy for you. Well and good. Okay, so only 2 information will be given and you will be asked the third information. These 2 will be given. They can ask all these, or they can give this and this, then they can ask all these. Okay, so they are simple thing. We have spent more than enough time when we were studying exponential Fourier series coefficient. So that's why I have just made the table here. Now we will just see the questions. But before that, there is one important note. So just let me know, if I am multiplying 2 real signal, will the answer be real, imaginary or complex? 2 real signal, 3t, 5t. What that would be? 15t square. Surely it will be real only. Real into real will be real only. Imaginary into imaginary. What that would be? Again real. Imaginary into imaginary. So j into j. j 3t into j 5t. So j into j will throw minus 1. 15t square. So minus 15t square you are getting. So j and j will be multiplied. That will give you real. Right? J into j is minus 1. So imaginary into imaginary will also be real only. Another thing we can see. Next, another thing we can see. What is that? So this will be fourth. Imaginary and real. If you multiply imaginary and real, what you will get? Imaginary, because j into 1 will be j, imaginary, or you can say j 3t into 5t. What you will get? 15t square j. So what is this? Imaginary. Now this is interesting. If you multiply complex to complex, what you will get? 3 plus j2t multiply with 4 plus j5t. You can calculate it, you can multiply, it will be complex only. But is it 100% sure that it will be complex only? 3 plus j2t multiply with 3 minus j2t. What you will get? 9. 3 into 3, 9. 3 into, this would be minus j60. j2t into 3 plus j60. And j into j will be minus 1, then another minus sign is there, so this will be 4t square. This and this is getting cancelled out. 9 plus 4t square. What is this? Real, right? It could be real as well. But in what condition? One should be conjugate of the other. If I multiply x1t multiply with x1 conjugate t, what will be the answer? Answer will be mod of x1t square. This we have already seen at a lot of places. And if you have taken the mode of a particular thing and then you are doing the square, certainly it will be real only. By the real example, we have seen it. 3 plus j2t, 3 minus j2t, we have seen it. Or what I can do? X of 2t multiply with x conjugate t. This will also be real. So basically the conclusion is your x of t is complex, okay? x1t is complex, x2t is also complex, but x1t is equals to the x2t conjugate. Basically another one is the conjugate. So when I do x1t dot x2t, then what I can write down? In place of x1t, I can write down x2 conjugate t. And x2 conjugate t multiply with x2t, what it will throw? Real. So if this is the condition, or from here another thing you can get to know, because conjugate you can take both of the side, or this is the condition. If these two are the condition, then x1t dot x2t will be real. So complex multiply with complex, it's surely, we cannot say for sure it will be complex. It could be real as well. And when it will be real, then one should be conjugate of the other. Is that discussion clear to you? Because it will be used in solving the problems. Let's move to the problems now. Mod of x of omega is even, mod of x2 of omega is even. You need to comment on the true statement. You need to comment on x1t, x2t, x1t multiply with x2t. These things you need to comment on. Okay. Mod of x of omega is even. If your mod of x of omega is even, can you surely say that your x of t will be real? No. X of t could be either real or imaginary. So here they are saying that it is purely real for sure. Wrong. It could be real or imaginary. Same goes for x2t as well. Right? Because the graph is even. The graph is even. Right? So it could be real or imaginary. Here there is no comment on the angle. Here there is no comment on the phase spectrum. So I cannot surely say that it will be real. I cannot surely say that it will be imaginary. Now multiplication will be purely real for sure. Is this true? What if I say that x1t is real and x2t is real? So real into real will be real. What if I say that x1t is imaginary and x2t is imaginary? Imaginary into imaginary, again real. But what if I say x1t is real and x2t is imaginary? Because both cannot, it might happen that both are not having the same nature. If it is real, it might happen that it is imaginary. So real into imaginary, what it will throw? Imaginary, right? Real into imaginary, it will throw imaginary. So purely real for sure, this is also wrong. So none of the above. Is this clear to you? All good? Next question. Correct statement. x1 omega is given, x2 omega is given. This time they have given the graph, not a phase spectrum, not magnitude spectrum or not phase spectrum, nothing is given. So x1 omega, if you draw the phase spectrum, mode of x1 omega, what you will get? You will get this thing only, mode of x of omega. And if you draw mode of x2 of omega, you will get this thing only. So what do you understand from here? Is it even? Basically, mode of x1 of omega is not even, because if it was even, then here for positive frequency if you are defining, then you should define for negative frequency as well, no? Like if you are just making the frequency on one side only, here there is nothing, that means x of t has to be complex, right? Because if it is even, sorry, if it is imaginary or real, then positive frequency will also be defined and negative frequency will also be defined, and one will, and both will be each other's mirror image, or you can say that your mode of x1 of omega will be even. But if mode of x of omega is not even, that means your x of t is, x1 of t is complex. Same goes for x2 of t is also complex. So x1t is complex and x2t is also complex. Now multiplication of both of them should be complex only. Is that so? No, because I told you complex into complex could be real. So this we need to find out, that how complex into complex could be real. So I know the condition. What is the condition? One should be conjugate of the other. Now in these kind of scenario, what you should do? You should start commenting on whatever that is there. You have this thing on your screen. These will be visible on your screen. So you will start commenting on whatever that you are having. So what you are having? You are having that x1 of omega is real. Only two things you will comment on. What all are the two things? Real imaginary, even odd. Because here we have studied real imaginary, even odd. Real, even, real, odd. So only two things you will comment on: even, odd, real, imaginary. So we have already commented on even and odd. This has been done, because from here we go to know that it is complex. Now we need to comment on real or imaginary. So one thing I can see here is that the value is real. Here if they have written 2j, then there would be issue. So it should be given. They would have written 2 here, and here also they have written 2, or here they have written 3. So this is given in the question, that values are real here. So these are the real axes. So x1 of omega is real. x1 of omega is real. Is that clear to you? So only two things we will be commenting on. So this you can write down somewhere here in your notes, that first you need to comment on even, odd, then you need to comment on real or imaginary. So x1 omega is real. So from here what do you understand? x1 omega is equals to x1 conjugate omega. So from here x1t will be equals to x1 of conjugate minus t, and same goes for x2 of omega as well, that x2 of omega is also real. So from here we go to know that x2 of omega is equals to x2 of x2 conjugate omega. So from here we go to know that x2t is equals to x2 conjugate of minus t. But we need to make the relation between x1t and x2t, because this is our target. Because if we are multiplying x1t and x2t and we get to know that one is conjugate of the other, then the multiplication would be real. This thing we already know. So our target is to stabilize a relation between x1t and x2t. So what I can see in both of the graph, that x1 of omega is equals to x2 of minus omega. Because if I take the mirror image of this particular graph, then I get this graph. Mirror image about y-axis. So x1 of minus omega, x1 of minus omega is equals to x2 of omega. Say yes or no. And why I am doing so? Because I need to stabilize a relationship between x1t and x2t. So x1 minus t is equals to x2 of t, right? x1 of minus t conjugate. Can I take conjugate on both of the side? Yes. Taking conjugate on both of the side is not wrong. You can take conjugate on both of the sides. So if I take conjugate on both of the sides, x1 conjugate minus t, x1 conjugate minus t is equals to x1t. So x1t is coming out to be x2 conjugate t. There you go. And this is something that I wanted. So x1t dot x2t will be equals to, x1t can be replaced with x2 conjugate t dot x2t. That would be mode of x2t square, and from here I can comment that it is real. So yes, third option is also true. That means all are true. Are you able to understand this particular question or not? A very good question. These kind of concepts are very, very good. Okay. So what did I tell you? That first we need to comment on complex real or imaginary. So how do we comment on complex real or imaginary? That we comment looking at the magnitude spectrum. So first I saw the magnitude spectrum. Basically this is the conclusion of everything that we have studied in this lecture. Conclusion of everything. So first I see the magnitude spectrum. I know that if I take the magnitude, it will be the same. And magnitude spectrum is not even. If it is not even, surely my x1t will be complex. x2t will also be complex. Now, if two complex functions are being multiplied, then it could be real as well, it could be complex as well. So for that, I need to stabilize a relation between x1t and x2t. But before that, what I can comment on x1 of omega? That x1 of omega is surely real. x1 of omega is real. If x1 of omega is real, if x1 of omega is real, then this is something that I can write down, and from here this relation I am getting. That means my x1t is conjugate symmetry, but conjugate symmetry, this is not important here, and x2t is also conjugate symmetry, which is not important here, right? Another relation I can find out, that if I take the mirror image, then x1 of minus omega is equals to x2 of omega. x1 of minus omega is equals to x2 of omega. Then what did I do? Then from here, okay, wait a second. Okay. Yeah, just one error I did here. What did I did here? Yeah, no, sorry, no error is there. From here, what is the relation that I was getting? x1 of minus omega is equals to x2 of omega. So from here, I got the relation as x1 of minus t is equals to x2 of t. Say yes or no, right? And then I took the conjugate on both of the side. x1 of minus t conjugate is equals to x2 of t conjugate. From here, I got to know that x2 of t conjugate is x1 of minus t conjugate is equals to x1t. So x2 of t conjugate is equals to x1t. And this is my target. My target was that one function should be conjugate of the other, and that I got to know here. That means surely my x1t dot x2t is real. So if there is relationship between these two graphs and they are asking the multiplication, then surely there is very high chances that it could be real. Are you able to understand this point? And this will be positive real, right? Because this value will be positive only. Let's just say xt was minus 3t, x2t was minus 3t plus 2j, whatever it was. Then what I am doing, I am taking the mode of it. What will be the mode? Under root minus 3t whole square plus 4. So it will be 9t square plus 4. And then what I am doing, I am taking the square. So what is the function I am getting? 90 square plus 4. And it will always be positive. If you draw the graph of 90 square plus 4, it will be somewhat like this. It will always be positive. So this is positive real. It is real, along with that it is positive real. When it can be negative? When there is a negative sign here. If there is a negative sign here, then it could be negative real. But here there is a positive sign, so it is a positive real. Say yes or no. Are you able to understand this point? So in place of this, here it would be written that x1t dot x2t is positive real. So x1t dot x2t is positive real here. Well and good. Let's see the last question of this lecture. A very good question. I would recommend you to try it on your own. Graph of xt is given. You need to comment on angle of x of omega. Just if I look at this graph, one thing I can feel here is that this graph can be even. If I just make a shift, this graph can be even. What kind of shift I need to make? If I do x of t plus 1, if I do the left shift by 1, what I will get? Yt, and yt will be even. And if my graphs are even, odd or anything, then I can comment something. If my graphs are even, then I can comment something on the frequency spectrum. Because here I need to see the frequency spectrum, then only I will able to get the phase spectrum. So one thing I got to know that if I just make a shift, I am getting an even graph. That means my y of t is even. So y of t could be equals to y of minus t. Say yes or no. That means y of omega could be equals to y of minus omega. Agreeing to this point? Well and good. Now from here, what you can get to know? What is your y of omega? y of omega is, can you apply the property xt is having a Fourier transform of x of omega, then what will be the Fourier transform of x of t plus 1? E to the power j omega t naught x of omega. T naught value is 1. So e to the power j omega x of omega. And what will be the value of y of minus omega? So in place of omega you put minus omega. So e to the power minus j omega x of minus omega. So here what I get to know that x of omega, y of omega is x of omega e to the power j omega. And here what is y of minus omega? That is e to the power minus j omega x of minus omega. Well and good. Okay. Now x of omega can be written as mod of x of omega e to the power j angle of x of omega e to the power j omega. This can be written as mod of x of minus omega e to the power j angle of x of minus omega e to the power minus j omega. Right. So mod of x of omega e to the power j omega plus angle of x of omega is equals to mod of x of minus omega e to the power j angle of x of minus omega minus omega. Say yes or no. All good. Can I add 2 and pi here? Surely I can add. Right? I am only interested in the angle. I am only interested in the angle. I am not interested in all these things. I am only interested in the angle. So what I can see was to angle of x of minus omega plus 2 and pi. I am interested in mode of, sorry, I am interested in the angle of x of omega. This is what I am interested in. What I can see, my xt is real. What I can see, xt is real. And if it is real, that means this should be even, which is coming out to be even. Here, from here you can check. It is coming out to be even. Another thing is that this angle plus this angle should throw 2 and pi. But here we are getting the upper another side. Let's see. Angle of x of minus omega should be equals to minus 2 omega plus 2 and pi. From here it is always not true. Okay. So here this is the one equation that I have got. This is the one equation that I have got. I am calling this equation as equation 2, and this is one equation that I have got. This is my equation 1. So let's write down these two equations again. Angle of x of omega plus angle of x of minus omega is equals to 2 and pi, right? Actually this n and this n both are different. Here I just added 2 and pi because I know that I can add 2 and pi any day. So both are different here. Are you getting this point? This n and this n both are different. Why I added this 2 and pi? Because I know that any day I can add 2 and pi here, because e to the power j 2 and pi is 1. So if I am calling this as n, I will call this as k. And the another equation I am getting is this minus 2 omega plus 2 and pi. This is equation 1, this is equation 2. I can add both of the equation. So here I should have put k pi, 2k pi. Basically this value could be 0, this value could be 1. Sorry, this value could be 0, this value could be 2 pi. So 0 plus 2 pi will be 2 pi. Or this value could be 2 pi, this value could be 2 pi. So 2 pi plus 2 pi, 4 pi. So if I add both of them, basically if I add both of them, what I will be getting? I will be getting a even multiple of pi. Do you agree with this point? Basically this will be a even multiple of pi. Even multiple of pi. And this is also a even multiple of pi. So if you add both of them, even multiple of pi plus even multiple of pi, you will get even multiple of pi only, right? So what I am getting, 2 angle x of omega, what I am doing, 1 plus 2. So 2 angle x of omega is equals to minus 2 omega plus 2 m pi, right? Because 2 m pi is also representing that it is a odd multiple of pi, sorry, even multiple of pi. Now 2 should be subtracted because I am interested in angle of x of omega. So 2 will be divided here. So what I am getting, minus omega plus m pi. There you go. This is the answer. That means angle of x of omega is minus omega plus any odd multiple of pi, or any multiple of pi, sorry, because divided by 2 I am doing, no. So m pi I am getting. So here value of m could be anything. Here value of m could be any integer. So here also you can put any value of m. You can put 0, 1, 2, 3. So what could be the answer? Minus omega plus pi, minus omega minus pi, minus omega plus 2 pi, minus omega minus 2 pi, minus omega plus 3 pi, minus omega minus 3 pi. All these answers are possible. So minus omega plus pi, minus omega minus pi, minus omega directly, minus omega minus 2 pi. So minus omega has to be there, that's for sure. Minus omega plus any multiple of pi, minus omega plus any multiple of pi, minus omega any multiple of pi, minus omega any multiple of pi. So did you understand how did we solve it? In the examination, what you will be thinking? That it can be even if I make a shift. So my y of t is even now. So y of t is even, then this is something that I can write down. Then I need to relate its frequency spectrum, or you can say Fourier transform. So y of omega will be equals to y of minus omega. Then I replaced y of omega in terms of x of omega because I need to find the angle of x of omega. So this is how I wrote down x of omega e to the power j omega is equals to e to the power minus j omega x of minus omega. Then I saw the magnitude and angle, again magnitude and angle. One thing then I noticed that my x of t is real, and if it is real then my magnitude spectrum will be even, and the relation in the phase spectrum will be something like this. So angle of x of omega plus angle of x of minus omega should be equals to 2 n pi, and this was the one of the equation that I was getting. That means both are just showing that here in place of n I am putting k. When I add both of the equation, the important point was here that minus 2 omega will come as it is, but 2 n pi plus 2k pi will make a even multiple of pi only. And if you divide any even multiple of pi by 2, then it would take all the values, all the multiple of pi. So here we are getting to know that we are getting all the multiple of pi. It could be pi, 2 pi, 3 pi, 4 pi, minus 2 pi, minus 3 pi, or even 0 as well. So these kind of answers we could expect. So angle of x of omega will be minus omega plus m pi. That's it. This is the end of this lecture. A very good lecture, a very interesting lecture. And if they want to frame a very good question on Fourier transform, then this is where they will frame the question from. All good. Just revise it again and you will feel very good after this lecture. Yeah. Thank you very much. Hi everyone. Welcome to PrepFusion. So in this video, we are going to learn about the properties of Fourier transform. So there are a lot of properties like differentiation property, integration property, then convolution property, multiplication property, area property, and then there is Parseval's theorem. So most of the properties we will try to cover in this video. If we need to make another part of this video, then we can make it 2 part. Otherwise, we will try to cover most of the properties in this particular video only. So first we will get started with differentiation property. But before that, you need to answer one of my question. So this is the question. There is a xt signal having non-zero DC value. You need to find the DC value of yt, and yt is defined as differentiation of xt. So what I am saying, xt is having a non-zero DC value of c0. So this is your xt having a non-zero DC value of c0. So in xt there will be a DC value. Along with that there will be other part of xt that I am showing by x bar t. Basically in the xt there is a DC value and some other part. What do I mean by that? Let's just say my xt is ut. Let's just assume that my xt is ut. if my xt is ut, then what is the DC value of ut? Half, right? What is the DC value of ut? That is half. So DC value of ut is half. This is the DC value, that is half, 1 by 2. Now what I need to do, I need to write down my ut in this manner. Ut is equals to the DC value plus the other part of ut. So what will be the other part of ut? That would be ut minus 1 by 2. Ut minus 1 by 2. So when you do ut minus 1 by 2, what you will get? When you do ut minus 1 by 2, because I need to write down this other part of xt, because xt I have assumed as ut. So ut is having, ut is equals to half DC value plus other part of xt. So what will be the other part? Ut minus half. Ut minus half. So 1 minus 1 by 2 will be 1 by 2 only. 1 minus 1 by 2 will be 1 by 2. And then 0 minus 1 by 2 will be minus 1 by 2. So half here and half here. So what you are getting? What is this? This is half signum t. So this is how I can write down my ut is 1 by 2 plus 1 by 2 signum t, where this is the DC part and this is x bar t. So any function I can write down, any function having non-zero DC value can be written in this form: DC value plus other part of xt, right? Now what I need to do? I need to differentiate it. So yt is defined as dxt by dt. So what will be your yt here? D by dt c naught plus other part. Now if you differentiate this d by dt of c naught, what that would be? 0. Differentiation of dc value will be 0. So what will be your yt? Yt will be d by dt of x bar t. So whatever the dc part was there, that was differentiated in yt. So when you do the differentiation, there can never be any dc part. So here the dc value will be 0. Say yes or no. Are you able to understand this point? Differentiation means killing the dc value, because the differentiation of dc value is 0. So if you do the differentiation of this particular signal or you do the differentiation of this particular signal, both will give the same result. Differentiation of this, there is a jump of 1. Differentiation of this, there is a jump of 1, from minus 1 by 2 to 1 by 2. So both are having the jump of 1. So differentiation of ut will give you delta t, and differentiation of half signum t will also give you delta t only. This was having a DC value of 1 by 2, this is having a DC value of 0. So if you have differentiated, that means you have killed the DC value. Will this point be there in your mind? Because this is a very important point. While applying the differentiation property, this should be there in your mind. If I have differentiated, that means I have killed the DC value. All good? Now let's see some prerequisites. These are the prerequisites only. You need to find out the DC value of x1t. How will you find out? Do you remember the formula of DC value? What was the formula? Limit t tending to infinity 1 by t. You take a period from minus t by 2 to t by 2 xt dot dt, and you take this period in a manner that the complete waveform will be covered. So minus t by 2 to plus t by 2. When you integrate, the area will be constant. So constant divided by t, where t is tending to infinity. So what will be the DC value? 0. So for this, DC value is 0. For a finite duration signal, DC value is always 0. What about this one? Here the DC value was a by 2. What about this one? This kind of signal can be broken into two parts. One will be the finite duration signal, plus other one will be this step signal, right? Two parts. So what was the DC value for this one? 0, because this is a finite duration signal. And what is the DC value for this one? That is a by 2. So what is the total DC value? That is a by 2. So this is how you need to see. You just need to break it into two parts. When we break it into two parts, one is finite duration signal, DC value 0, other one is step, so a by 2. And when you shift a waveform, DC value will never change. No matter wherever you shift the waveform, DC value will be same. So here also DC value is a by 2, here DC value is 0, and here it is a by 2. I am moving it I am moving fast here because this we have already seen in basics of signal. This is just a revision, right? In basics of signal, we have already seen how to find out the DC value. Now let's start studying the differentiation property. So we have studied the differentiation property in our exponential Fourier series coefficient. So xt was having an exponential Fourier series coefficient of Cn. Then what was the Fourier series coefficient of dxt by dt? That was Jn omega naught Cn, right? So d by dt was replaced with Jn omega naught. So here d by dt will be replaced with j omega. If you are doing it twice, then j omega square x of omega. Basically, first differentiation will be replaced by j omega, then another differentiation will be replaced by j omega. What I mean to say is that this is d by dt, dxt by dt. So dxt by dt j omega. Because of this d by dt j omega came. Because of this d by dt j omega came. So j omega into j omega square. So what we are getting? J omega square x of omega. And here n times. So j omega to the power n x omega. Well and good. So this is known as differentiation property. So if someone asks you xt is having a Fourier transform of x of omega, then yt is defined as dxt by dt. What is the Fourier transform of yt? That is y omega, and that is given by j omega x omega. There is no doubt about that. This is absolutely correct. If someone is asking you what is the Fourier transform of yt, but can you say the Fourier transform of xt, x of omega, is equals to y omega divided by j omega? Is this true? Is this true? Look, this is surely true. There is no doubt about this. Is this true? Do you really think so? What will be the DC value of yt? 0. That means y of omega will also have the DC value equals to 0. That means it will not have any frequency component omega equals to 0. Now what we are doing, we are just dividing it by j omega. That means we are not adding up any DC component from our side. Are you able to understand what I am saying? Xt is having a Fourier transform of x of omega. Then we did the differentiation d by dt x of omega. Then we applied this property. Whatever the property says, absolutely correct. There is no doubt about that. We have applied the property. Now from here I try to write down x of omega. That is y omega divided by j omega. Is this correct? What is the DC value of yt? That is 0. That means y of omega will not have any DC component. That means y of omega will not have any omega equals to 0 component. That means y of omega divided by j omega will also not have any omega equals to 0 component, right? What I am saying, y of omega is not having any omega equals to 0 component. That means y of omega divided by j omega, this will also not have any omega equals to 0 component. What does that mean? That x of omega is not having any omega equals to 0 component. That means x of t will not have any DC value, but who knows, xt might be having some DC value. So what really happened here, when you differentiated it, so here your DC value got killed. When you differentiated, here the DC value got killed. And after that you got this result. So the Fourier transform of y of omega will be j omega x omega. There is no doubt about that. But when you wrote down x of omega, so in this x of omega, there is no DC component because that has been already killed. So this is wrong. Are you able to understand this point? Let's understand by a Fourier transform. What I am saying, let's understand by Fourier transform. So I am writing down my xt as c naught plus x bar t. Do you agree to this point? What will be its Fourier transform? X of omega. What is the Fourier transform of a DC value? Fourier transform of 1 was 2 pi del omega. If I multiply by c naught here, so what I will get? 2 pi c naught del omega. That means if a signal is having a DC value, then certainly there will be an impulse. If a signal is having a DC value, 100% there will be an impulse. There is no one to stop this, right? If it is having a DC value plus x bar omega. What was your y of omega? Y of omega was j omega x of omega. Say yes or no? So y of omega was j omega. X of omega is 2 pi c naught del omega plus x bar omega. j 2 pi omega j 2 pi c naught omega into del omega plus j omega x bar omega. Tell me the value of this particular thing, omega into del omega. What is that? 0, right? Omega into del omega, t into del t. Del t can be written as t minus 0. So this 0 goes here. So 0 into del t will be 0. So omega into del omega will be what? 0. So this value is 0. What this will throw? 0. So what you are getting? J omega x. So whatever the DC component was there, that was killed. So in y of omega, what you are getting? 0 DC value. In y of omega, you are having a 0 DC value. So here what you are writing down? Actually, this is j omega x omega. If I write down j omega x omega, there is no issue. What I got to know is that j omega x omega is equals to j omega x bar omega. And what is x bar omega? That is the Fourier transform of x bar t. That means there was no use of the DC value. If you are multiplying any signal with j omega, that means already your DC value is getting killed. So j omega x omega is equals to j omega x bar omega. Are you able to understand this point? J omega x omega is equals to j omega x bar omega. So where is the DC value gone? DC value is gone here. So can you write down x of omega as y omega by j omega? No, this is x bar omega actually. So this is your x bar omega. But what is your actually x omega? Your x omega is x bar omega plus 2 pi c naught del omega. That means your x omega is equals to x bar omega plus Fourier transform of c naught. Are you able to understand? Can I write down my x of omega as Fourier transform of c naught plus x bar omega? A very important point which a lot of people don't understand, and those who understand, they will just mug it up. But this is the complete explanation that what all things are happening here. So this is your x of omega actually. So from here you will get the value of x bar omega. So this is not x omega, this is your x bar omega. When you have got the x bar omega, after that you need to add the Fourier transform as well. So when we solve the problem solving technique will be very easy. But here I have just given the explanation that what is actually happening when we are applying the differentiation property. So this differentiation property is not that straightforward, which it looks like. If someone asks you what is the Fourier transform of d by dt of xt, you can blindly say it is j omega x omega. Because I know that if I have multiplied j omega, that means it will already kill the DC value. And I know that DC value of d by dt of xt will be 0. But from here, if someone asks you what is x of omega, then you will never say it is equals to y omega divided by j omega. No, absolutely not. Because x of omega can have some DC component. X of omega can have omega equals to 0 component. X of omega can have the impulse. That impulse has been killed. So I need to add back that impulse again. So whenever I write down x of omega equals to y omega divided by j omega, along with that I will add Fourier transform of my DC value as well. Is that clear to you or not? Okay, so we will solve the problem, it will become easy for you, but this was the concept which was necessary to deliver. Okay, let's solve some problem. You need to find the Fourier transform applying the differentiation property. Although you already know the Fourier transform of this particular signal, this is a rectangular signal, it will be sampling, but applying the differentiation property you need to solve it. So whenever you apply the differentiation property, the first task will be you need to write down the C naught value. That means which is the DC value of xt. What is that? DC value of xt will be 0. Why is that so? Because it is a finite duration signal. So first thing I have written DC value of xt is 0. Now what I am going to do? I am going to differentiate. So at minus t by 2, impulse of area A, and here the impulse of minus A. Jump, decay, impulse of area A minus A, minus t by 2 plus t by 2. So dxt by dt. A delta t plus t by 2 minus A delta t minus t by 2, right? D by dt xt, j omega x omega, no doubt about it. There is no doubt. What we are doing, we are just writing down the Fourier transform now. What will be the Fourier transform of A delta t plus t by 2? What is the Fourier transform of delta t? 1. What is the Fourier transform of delta t plus t by 2? E to the power j omega t by 2 into 1. So it would be e to the power j omega t by 2. A remains as it is, e to the power j omega t by 2 minus e to the power minus j omega t by 2. So x of omega is coming out to be, a is coming out to be common, e to the power j omega t by 2 minus e to the power minus j omega t by 2 divided by j omega. Okay, what I am doing, t by 2, t by 2, multiply by 2, multiply by 2. Why I am doing so, you will understand. So 80 is coming out to be here, 80. Okay. 80 is coming out to be here. Then e to the power j omega t by 2 minus e to the power minus j omega t by 2 divided by 2j, and then 1 by j omega t by 2 is outside. Oh, sorry, 1 by omega t by 2 is outside. So what this will become? Sinusoid 80. So sine omega t by 2 divided by omega t by 2. This is your x of omega. So from here, x of omega that we are getting to know is 80 sampling of omega t by 2. Along with that, we need to add the Fourier transform of DC value. And what is the DC value? C naught. But what is our DC value? 0. So Fourier transform of 0. And what that would be? 0 only. So from here, x of omega is coming out to be 80 sampling of omega t by 2. Are you able to understand this point? A very, very important point and a very, very interesting point as well. So x of omega is 80 omega t by 2, which we have got from here as well, because what is our xt? Xt is a rect t minus center upon time width. So that would be a tau sampling of omega tau by 2, and we are getting the same answer. In the Fourier transform as well, you can see that DC component is 0, and here also the DC component is 0 only, right? You need to find the Fourier transform of ut applying the differentiation property. So what you will do? So dxt by dt will be equals to delta t. So j omega x omega will be equals to 1. Till this step, nothing is wrong. If I write down x of omega equals to 1 by j omega, this will be absolutely wrong. Why is that so? Because x of t can have some DC value. So here I will write down Fourier transform of C naught. So just as you start applying the differentiation property, your first task should be that what should be the DC value of xt. So what is the DC value of xt? That is 1 by 2. So Fourier transform of 1 by 2. 1 by j omega plus Fourier transform of 1 by 2. So that would be equals to 1 by j omega. So 1 by 2, 2 pi del omega. So what we are getting? 1 by j omega plus pi del omega. Yes. So Fourier transform of ut is 1 by j omega plus pi del omega. So always a very, very important point that you need to add up the Fourier transform of DC value. We will solve more problems. Okay, more problems we will solve. Solve this question. First you need to draw the diagram of xt, and then you need to find out x of omega. So let's draw the diagram of xt. Because for r of t you don't remember any standard result, because you know that for rt there is no Fourier transform possible. So you don't remember any standard result, but you know that there will be a slope of 1 at minus 1. There will be a slope of 1 at minus 1, and then there will be a decrease in the slope. So the slope will become 0. Initially the slope was 1, now the slope has become 0. So all these changes have happened at minus 1 and 1. minus 1 and 1. This is 1. So what is the slope here? Slope is 1. So what will be this point? This point will be 2. 2 divided by 2 will be 1 only, right? So this is your xt. I don't see any other possible option rather than differentiating it, right? Only the possible option feels like to me is differentiation. So what I will do, I will differentiate it. So when I am differentiating it, what I am getting? D by dt I am doing. So dxt by dt versus t. So what is the slope? Slope is 1. So between minus 1 to 1, the slope is 1. Previously the slope was 0. Previously the slope was 0. Between minus 1 to 1, the slope was 1. After 1, the slope has become 0. Say yes or no? Right? Now this is the signal whose Fourier transform we already know. But just as you have applied the differentiation property, your first task should have been to write down the C0 value. What is the C0 value here? What is the DC value? A by 2. Because this will be the part which will be having finite duration. So finite duration signal will have 0 DC value, and this is your 2 ut. So DC value is A by 2. That means DC value is 1. So your dxt by dt is rectangular t minus center upon time width. So from here, if I do j omega x omega, till this point everything is fine. What is the Fourier transform of rectangular t by 2? A tau sampling of omega tau by 2. So omega 2 by 2, 2 sampling omega. No doubt about that. But from here, if you write down x of omega, that would be 2 sampling omega divided by j omega plus Fourier transform of DC value. So answer would be x of omega 2 sampling omega divided by j omega plus Fourier transform of C0, that means Fourier transform of 1. So in place of C0, I should put Fourier transform of 1, that is 2 pi del omega. There you go. This is your x of omega. Is that clear to you? So this is how you apply the differentiation property for finding the Fourier transform of xt. If they were asking the Fourier transform of dxt by dt, then there was no doubt about that. This would be 2 sampling omega. So you can always write down j omega x omega equals to 2 sampling omega. But x of omega equals to 2 sampling omega divided by j omega, that would be wrong because I need to add up that dc part as well. All good? All fine? Solve this question. Solve this question. And then solve this question. 3 questions you need to solve on your own. Okay, very easy, very straightforward. You know every single thing about it. So have the patience and solve it on your own. Okay, so solve all these questions. I will take a break and then I will come back. So solve this question. Yeah, so let's get started. What we need to do, we need to apply the differentiation property. Why we need to apply the differentiation property? Because this is not a standard signal, right? A random waveform is given which is compiling of ut only. Here a random waveform was given which was compiling of rt. So in these kind of waveform, what we need to do, we just simply need to differentiate. Just apply the differentiation property. That's it. Okay, so just apply differentiation property here. dxt by dt. What you will get? Impulses. So initially at 0 there is an impulse of area A. Then at 1 as well there is an impulse of area A. Then at 2 there is an impulse of area minus 2A. And then 0, 0, 0. So A minus 2A. What is the DC value? 0 only. So what is dxt by dt? Impulse of area A plus impulse of area A at 1 plus impulse of area 2A at 2. So j omega x omega. What is the Fourier transform of delta t? That is 1. What is the Fourier transform of delta t minus 1? E to the power j omega t naught. T naught value is minus 1. What is the Fourier transform of a to the delta t minus 2? What is the Fourier transform of delta t minus 2? That would be 1 into e to the power j omega t naught. What is the value of t naught? Minus 2. Value of t naught is minus 2. So from here x of omega is coming out to be a plus a minus j omega minus 2a divided by j omega plus Fourier transform of dc plus Fourier transform of dc. That would be 0 only. So that doesn't matter. Just this would be the answer, right? So this could be one of the option in the examination hall. It could be MSQ as well. So there could be other option as well. How? Because this can be changed into sampling function as well. How it will be changed? Can you write down xt in terms of rectangular function? Yes. Let me write it down. So I am writing it down in this manner. A rect t minus center at 1. What I am doing? I am just breaking this waveform into two parts. What all are those two parts? This is the one part from 0 to 2 a, and then other part is from 1 to 2 another a. So between 0 to 1 it would be a, and between 1 to 2 a plus a will be 2a. So this is how I can break it down into two signals. So a rect t minus center upon time width. So a rect t minus center upon time width plus a rect t minus center, a rect t minus center upon time width. Time width is 1 here. Time width is 1. So this is how I can break it down. Say yes or no. All good. So from here as well I could have written down the Fourier transform x of omega. That would be a to sampling of omega 2 by 2 e to the power minus j omega plus a to sampling of omega 2 by 2 e to the power j omega. This could also be one of the possible option. Basically I am talking about other options. When you convert this, it can be converted in this manner as well. Like something you need to apply and then you will get this answer. Like some multiply with a particular factor, then divide by a particular factor. All these things you need to do, and then this form can be converted to this form. But this is how we will not do in the examination hall. We will just see that it can be broken into two parts: a rect t minus center upon time width, a rect t minus center upon time width plus a rect t minus center upon time width. Okay. Then from here we can write down the answer. So a2 sampling of omega 2 by 2 e to the power minus j omega, a2 sampling of omega 2 by 2 e to the power minus 1.5 j e to the power minus j 1.5 omega. Okay. Other form could also be there. They can break it down in this manner, that one rectangular function and then another rectangular function. Like between 0 to 1 it is a, and between 1 to 2 it is 2a, and then add them up. Between 0 to 1 it is a, between 1 to 2 it is 2a. So this is also how they can write it down. So your xt is a rect t minus center upon time width, right? For this one, t minus center upon time width plus 2a rect t minus center 1.5 upon time width. So what you will be getting, a2 sampling of omega 2 by 2 e to the power j omega e to the power j omega t naught value is minus 0.5, a2 sampling of omega 2 by 2 e to the power minus 1.5 omega. So this could also be one of the possible options. So just telling that multiple answers are possible here. This is what I am saying. Multiple answers are possible. In this manner, multiple answers are possible. All good. The best possible option would be that you find out the inverse Fourier transform of the given options. Let's just say this waveform is given and they ask you what is the Fourier transform of xt. Then they have framed 4 options and it is a MSQ. Some options will be straightforward. Now who knows what they have thought of it? Like this can be written down in n number of ways. Are you able to understand this point? Right? That I add up something, then I divide, I add up something, then I subtract, and then again I add up something. So all these things could be there. So best possible option would be that take all the options. Look, this you will be able to find out. This you will be able to find out. Then take all these options. Take this option, take this option. Can you find out the inverse Fourier transform of this one? Yes, very easily. Can you find out the inverse Fourier transform of this one? Yes, very easily. From there you will get to this expression. Sorry, from here you will get to this expression, and from here you will get to this expression. And then can you draw this waveform? Yes. If the drawn waveform is same as the given waveform, then your answer is correct. So I would say best possible way would be to check by the options. Although they will not ask these kind of questions because it will take a lot of time, and it doesn't test much of the things, because what they wanted to ask, the first thing they would look for this particular thing, that are you adding up the Fourier transform of DC value, and here the DC value is 0, so this question is not interesting. If they want to make the question interesting, then they will ask these kind of questions. No, not these kind of questions, they will ask these kind of questions if they want to make the question interesting. Okay, so although they will not ask this kind of question in MSQ, that one option they will frame like this, second and third, no, they will not ask all these kind of things. Otherwise, because it will take a lot of time, again and again you have to calculate the inverse Fourier transform, then you need to draw the waveform, then again you inverse Fourier transform, then draw the waveform. Just a manual process, right? But they want to test your brain, not your calculation skills, right? So yeah, next thing, again, not a standard. This is a standard waveform. No, the standard waveform was triangular. This was the standard waveform, but this is something like this. So this was symmetric, but this is not symmetric. So not a standard waveform. You cannot write down a tri center minus a tri t minus center. Those things you cannot do here, right? So what you have to do? Differentiation. What I am doing? dxt by dt. What is the slope? Slope is 2. Slope is 2. Then slope becomes 0. Now it has become a standard waveform. Say yes or no, right? So here the slope was 2 and then the slope was 0, 0. All good. But yeah, another thing is there, right? There is a sudden jump as well. Are you able to understand this point? Slope was 2, slope was 0, but there is a sudden decay or sudden jump, whatever you want to say. So there is a sudden decay of 4. Decay of 4 is also there, no? So there is a decay of 4 also there. Here there is no jump, here there is a jump, no? So decay of 4 is there, that means the area will be minus 4 here. So what you can write down? Your dxt by dt. What is the DC value of xt? If I am applying the differentiation property, the DC value is already 0. So this is your A rect t minus center upon time width minus 4 delta t minus 2. Is that clear to you? There was a sudden decay which you need to notice. Are you able to understand this point? Okay. So sudden decay of 4 was there. So because of this decay, we have reached to this point. So this is how I can write down my dxt by dt. 2 rect t minus center upon complete width minus 4 delta t minus 2. J omega x omega 2 a2 sampling of omega tau by 2 e to the power minus j omega t naught minus 4 e to the power minus j 2 omega. So x of omega will be 4 sampling omega e to the power minus j omega divided by j omega minus 4 e to the power minus j2 omega divided by j omega. This is the answer. Okay, well and good. This question we have solved. Now try this one. Differentiate 0. Differentiate 0. Differentiate, the slope is minus 1 and here the slope is plus 1, right? 0, slope minus 1, then slope plus 1. 0, then at -2 the slope is -1, then the slope is +1, then slope again becomes 0, and there is no sudden jump, there is no sudden decay. So this is how we are getting it. Right. So sudden decay, sorry, no decay, nothing. Slope is -1, slope is +1, -2, 1, and t. So this is your dxt by dt. So one thing you can do is that dxt by dt you can write down in terms of rect. What I mean to say is that dxt by dt. What is the dc value here? Just tell me the dc value. So it can be broken into three parts. This waveform can be broken into three parts. Finite duration. Another part is this ut, and another part is this step. Step, finite duration. Are you able to understand this point? This point is -2, this point is 1, and this point is between -2 to 1. If you add all these waveform, you will get the same waveform. So this part will have dc value equals to 0. What will be the dc value of this part? A by 2, that means 2 by 2. And what will be the dc value of this part? That would be a by 2, that means 1 by 2. So 1 by 2 plus 1, the dc value will be 3 by 2. What will be the dc value? 2 by 2 plus 1 by 2. dc value is 3 by 2. Okay, so this is the dc value which is necessary. So here what you can do, either you can differentiate again, right, or you can write it down in terms of rect. Here I can again apply the differentiation property, like d square xt by dt square, d square xt by dt square. So impulse here, and impulse here. But here I can write down in terms of rect as well. What is the amplitude? -1. -1 rect t minus center. What is the center? Center will be -1. T minus center upon time width. What is the time width? Time width is 2 plus rect t minus center upon time width. What is the time width? Time width is 1. T minus center upon time width. T minus center upon time width is 2. All good. So j omega x omega is equals to a2 sampling of omega 2 by 2 e to the power j omega plus a2 sampling of omega 2 by 2 a2 sampling of omega 2 by 2 e to the power minus j 0.5 omega. So from here x of omega is coming out to be, if I write down x of omega, so whatever this expression divided by j omega, along with that Fourier transform of C naught. So what is the Fourier transform of C naught? Just let me know what is the Fourier transform of C naught. That means Fourier transform of 3 by 2. So that would be 3 by 2 into 2 pi del omega. So that would be 3 pi del omega. 3 pi del omega. So from here x of omega is coming out to be minus 2 sampling omega e to the power j omega divided by j omega plus sampling omega by 2 e to the power minus j omega by 2 divided by j omega plus Fourier transform of C naught, that is 3 pi del omega. So this could be one of the possible answer. Or what you can do, you can differentiate it again. If the option is given in terms of sampling function, then you will do this particular process. Or what you can do, you can differentiate it again. So what I am doing, I am making d square xt by dt. d square xt by dt square. Right. So if I differentiate, -1, 2, -1, decay, jump, decay, -1, 2 and -1. So at -2 you are having a decay of -1. Then you are having a increase of 2, then again there is a decay of minus 1, minus 1, 0, 1, minus 1. Again let me check, minus 2, 0, 1, minus 1, 2, minus 1, 2, minus 1, minus 1, 2, minus 1. So what is your d square xt by dt square? That is minus delta of t plus 2 plus 2 delta t minus delta of t minus 1. Okay, so here you are getting minus omega square x of omega will be equals to minus e to the power j omega t naught, because delta t will be having 1, so minus e to the power minus e to the power j omega t naught plus 2 minus e to the power j omega t naught. So x of omega will be equals to e to the power j2 omega minus 2 plus e to the power minus j omega upon omega square. That's it? No. Plus Fourier transform of C naught, because here x of omega is showing that it is not having any particular DC component, but it is having a DC component. That means 3 pi del omega should also come, because actually there is a DC component present. Look, the final thing is I will calculate till this point everything is fine, but from here if I write down x of omega only this, that would be wrong, because it is also having a DC component, and DC component of 3 by 2. So that Fourier transform also I need to add up. Someone will say that, sir, here the DC value is 0. Yes, dxt by dt will have DC value equals to 0. But here what you are doing, you are differentiating xt twice. So here I need to see. So differentiating xt twice will also have the DC value equals to 0. What is the DC value of this waveform? 0 only, right? DC value of this waveform you can calculate from minus t by 2 to t by 2. This will throw area minus 1. This will throw area minus 1. This will throw area 2. So 2 minus 1 minus 1. DC value is 0. Are you able to understand this point? So DC value of this particular thing is 0. So from here DC value of this thing is also 0. So till this point everything is fine. But DC value of xt is not 0. So that DC value I have added up. So there you go. This is the final answer. Okay. So this option could be there. If it is there in terms of exponential, then this is what I will do. And if it is there in terms of a sampling function, then this is what I will do. All good? All fine? Some important points we can see. These are the points regarding area only. So what I am doing, this is the equation 1. This we already know. X of omega equals to minus infinity to infinity xt e to the power minus j omega t dt, and then xt equals to 1 by 2 omega minus infinity to infinity x of omega e to the power j omega t. This we already know. Now in the equation 1, I am putting t equals to 0. Sorry, omega equals to 0. Really sorry. In the equation 1, what I am putting? Omega equals to 0. So what I will be getting? X of omega at omega equals to 0 will be equals to minus infinity to infinity. If you put omega equals to 0 here, what you are getting? Xt dot dt. So area enclosed by xt is given as Fourier transform at omega equals to 0. That's it. So whatever the Fourier transform that you are getting at omega equals to 0, that will be equals to the area enclosed by xt. If I say xt is having a Fourier transform of x of omega, and I give you the value of x of omega, and I ask you what is this particular thing. So will you calculate the inverse Fourier transform? No. What you will do, for calculating this particular thing, I will write down this formula, then I get to know that x of omega at omega equals to 0. X of omega at omega equals to 0 will give me this particular thing. So I just need to calculate x of omega at omega equals to 0, because I am already having x of omega. Are you able to understand this point? Or if I give you any xt whose integration you don't know, I am giving you any random xt, this integration becomes very difficult for you. Then what you will do? Sir, I don't know the integration, but sir, I can calculate x of omega. If I am having x of omega and then at omega goes to 0, if I calculate, then my job is done. So these properties will be used. We will solve the problems. There you will understand it. Okay. Or in this property as well, what you can put? Omega equals to 0. In this property as well, what you can put? Omega equals to 0. So in equation 2, not omega equals to 0, sorry, here I will put t equals to 0. Not omega equals to 0, here I will put t equals to 0. Here I will put t equals to 0. Why I am not putting omega equals to 0 here? because x of omega is being differentiated, x of omega is being integrated, no, right? X of omega is being integrated. Again and again I do the same mistake, d omega. So here I am putting t equals to 0 because t is independent variable here. Omega is being integrated. Omega is being integrated. So you are integrating with respect to omega. So you need to write down t equals to 0. Right? So if I put t equals to 0 here, what I am getting? X of 0. This 2 pi can be multiplied here. So 2 pi x of 0 is equals to minus infinity to infinity x of omega d omega. So if I tell you that xt is having a Fourier transform of x of omega, then find out the value of minus infinity to infinity x of omega d omega. And xt is given. So what you will do? Will you calculate this x of omega? Then you will do the integration? No. What you will do? I need this particular thing. That means here if I put t equals to 0 and then multiply with 2 pi, then my job is done. So you are not going to remember these results. Okay. What I am saying, you are not going to mug up these results. Anyway, these formulas you are going to remember. So with the help of these formula, you will derive it. Just you will write down this formula, then you will understand that area enclosed by xt will be given by x of omega at omega goes to 0. And area enclosed by x of omega will be given by 2 pi into xt where t is equals to 0. Just write down the formula and you will get the answer. Now other things can also be asked. What if in the examination hall? What if in the examination hall this thing is asked? What if I give this question that x of t is having a Fourier transform of x of omega, and then I am asking you minus infinity to infinity x of omega e to the power minus j omega, or what I should write, okay, minus j omega minus j 2 omega d omega. What will be its value? What you will do? Look, x of omega d omega, I know one formula, x of t is equals to 1 by 2 pi minus infinity to infinity x of omega t here, so here there will be a positive sign d omega, right? Now to make this particular thing, what I need to do? T equals to minus 2. If I put t equals to minus 2, x of omega e to the power t equals to minus 2. So minus j 2 omega d omega. So what you are getting? Minus infinity to infinity x of omega e to the power minus j 2 omega d omega is equals to 2 pi x of minus 2. There you go. This is the answer. Say yes or no. All good? 2 pi x of minus 2. Right? So basically just you need to have the patience that these kind of things we have already studied. This kind of patience you need to have. Or what if I ask you minus infinity to infinity xt e to the power I ask you this question, xt dot cos t dt or cos 2t dt. What if I ask you this question? What you will do here? So what you will do? Minus infinity to infinity cos 2t I can break down e to the power j 2t plus e to the power minus j 2t divided by 2 dot dt. So from here I am getting 1 by 2 minus infinity to infinity x of t e to the power j 2t plus 1 by 2 e to the power j 2t dot dt plus 1 by 2 minus infinity to infinity x of t e to the power minus j 2t dt. Right? Did I break it down in good manner? Yeah, 1 by 2 xt e to the power j 2t plus 1 by 2 xt e to the power minus j 2t dt. All good? Now one thing I know, x of omega is minus infinity to infinity xt e to the power j omega t dt, but there will be a minus sign, t is there, so minus sign will be there. Okay, so if I put t equals to minus 2, if I put t equals to minus 2, sorry, if I put omega equals to minus 2, here I cannot put t equals to minus 2 because integration is done with respect to t. So if I put omega equals to minus 2, if I put omega equals to minus 2 here, then this is something I will be getting, xt e to the power j 2t dt. So 1 by 2 at x of omega when omega is equals to minus 2 plus 1 by 2 x of omega where omega is equals to plus 2, because if I put plus 2 then this is something I will be getting. So if I am having the x of omega value, then I will just put omega equals to minus 2 and omega equals to plus 2 and then I will do this calculation. So this will be my answer. Are you able to understand this point? So in the integration, you will never ever have to solve the integration. You need to use your brain there. Have the patience and use your brain, because typical integration they will be asking. And if they are asking the typical integration, you need to have the patience there. That's it. Okay, so this was another kind of property, or you can say some important point it was. Now, this property is also very important, multiplication and convolution property. So let's understand it. So what I am saying, x1t is having a Fourier transform of x1 omega. Sir, when we will solve problems regarding this, we will solve the problems as well, but you need to have the patience. Okay, but first we will see this property and then we will see integration property as well. After that there are questions only, this question, then this question. So only questions and questions are there after these two properties. So just see this property as well, and then there will be questions only. So every concept will be used in those questions. From Fourier transform, like whatever that you have studied from first lecture to this particular lecture, every concept will be used there. Well and good. Okay. So x1t is having a Fourier transform of x1 omega and x2t is having a Fourier transform of x2 omega. If I am convolving both of the signal, what I am doing, I am convolving both of the signal and I am saying that yt is my new signal, that is x1t convolution with x2t. So what will be your y of omega? What will be your y of omega? So what will happen? Convolution in time domain will result in multiplication in frequency domain. What I am saying? Convolution in time domain will result in multiplication in frequency domain. So here there is convolution, so here there will be multiplication. There you go. And if you need to write down y of f, that would be x1 of f into x2 of f. Basically they can have x1 f as well and x2 f as well. Yeah, sorry for the interruption. So what I was saying, x1t convolution with x2t will result in x1 omega dot x2 omega. That means convolution in time domain will result in multiplication in frequency domain, and same goes for f as well. Now multiplication in frequency domain, multiplication in time domain will result in convolution in frequency domain. Just here one important thing you need to take care is that you need to multiply with 1 by 2 pi. So there will be division of 2 pi as well. That's it. This is what you need to remember. Are you able to understand this point? And if you write it down in terms of f, then there will not be any 2 pi. Again I am telling these two properties are there. Very important property. x1t convolution with x2t will be having a Fourier transform of x1 omega dot x2 omega, or you can say x1f dot x2f. x1t dot x2t will have the Fourier transform of x1 omega convolution with x2 omega but divided by 2 pi. If you write down in terms of f, then there will not be any 2 pi. How did this come? Look, x1f convolution with x2f, x1f convolution with x2f is equals to yf. This is what I am saying. Okay. Now if I multiply by a factor of 2 pi, then as per the property what will happen? This will also be multiplied with the factor of 2 pi, but 1 by mod of a will come outward. Do you remember this property? What is 2 pi f? Omega. What is 2 pi f? Omega. 1 by 2 pi. What is 2 pi f? Omega. So this was y of f. This is 1 by 2 pi y of omega. Are you able to understand this point? So 1 by 2 pi x1 convolution with x2. 1 by 2 pi x1 convolution with x2 will be equals to x1 convolution with x2 in the frequency domain. So all these derivation, nothing you need to remember, just erase it. Okay, nothing you need to remember. These two important points should be remembered. Convolution in time domain will be resulting in multiplication in frequency domain, but there is no other factor. But when you are doing the multiplication here, when I am doing convolution here, there will be a factor of 2 pi. This we need to remember anyhow. x1t dot x2t, x1 omega convolution x2 omega, but there will be a factor of 2 pi. In the convolution, there will be a factor of 2 pi. In the multiplication, there will not be any factor of 2 pi. Are you able to remember this point? Will you be able to remember this point? You need to remember this point anyhow. Okay. Multiplication, convolution, factor of 2 pi. Convolution, multiplication, no factor. All good? All fine? We will do the practice, then you will be habitual. Let's see the integration property. Yt is equals to, you are doing the running integration of x of t. So can I write down my yt as xt convolution ut? And now can I apply the convolution property? Convolution in time domain will result in multiplication in frequency domain. And if you are doing the multiplication, that means there will not be any factor of 2 pi. So x of omega I am keeping as it is. What is the Fourier transform of ut? That is 1 by j omega plus pi del omega. So x omega divided by j omega plus pi x omega del omega minus 0. This 0 can come here. So what you are getting? X of omega divided by j omega plus pi x of omega, sorry, in place of x of 0 del omega. This is your y of omega. This is the integration property which you will not be remembering. You don't need to remember the final result. What you need to remember, what is the meaning of integration? This is the meaning of integration. And when we are doing the running integration, that means you are convolving with ut. Do you remember the Fourier transform of ut? Yes. Do you remember the convolution multiplication property? Yes. So from there you will get this answer. You don't need to remember the property. What I am saying, remembering the property is not worth it. You don't need to remember the property. Just this is how you need to solve it. That's it. Okay. In any day, if they ask you the integration property in MCQs question, then this is how you will be solving it and you will write down the answer. Okay. Better here, instead of writing x of 0, I should write x of omega at omega equals to 0. This would be the better way of writing it. X of omega at omega equals to 0. Okay. And this was the multiplication and convolution property. A very, very important property. That's why I am showing it again and again. Convolution in time domain will be multiplication in the frequency domain. When you are multiplying, there is no factor of 2 pi, but when you are convolving here, there is a factor of 2 pi. In terms of f, there is no factor at all. All good? Now our target is to solve the problems. So these kind of questions would be there in the examination. Like integration is there, a lot of integration would be there. So if typical function are having integration, then you need to 100% sure that, you just have to be 100% sure that the question will be based on Fourier transform. So there is a running integration of sine 3 tau by 2 tau d tau. You would get to know that if I integrate this particular thing, it will take a lot of time, right? By the mathematics, by your engineering mathematics concept, if you integrate, it will take a lot of time. So what is your xt? Can I write down my xt as sine 3t by 2t convolution with ut? Say yes or no. Right? Do you know the Fourier transform of this thing? Yes. Do you know the Fourier transform of this thing? Yes. So I am assuming that this is my new function, which is yt. My yt is sine 3t by 2t. Sine 3t by 2t. And do you remember the convolution property? Why I am finding out the convolution? Why I am finding out xt? Because what I need to find? I need to find the value of a. What is my a? Minus infinity to infinity x of t e to the power minus j2t dt. This is what I need to find. What do I remember? X of omega is equals to minus infinity to infinity x of t e to the power minus j omega t dot dt. This is what I remember. In place of omega, if I put 2, then my job is done. So from here, what I get to know that a is equals to x of omega, omega equals to 2. That's it. From here, this is something that I needed to find out. Then I wrote down this particular formula: x of omega is equals to minus infinity to infinity x of t e to the power minus j omega t dt. Then if I put omega equals to 2, then my job is done. So my a is equals to x of omega at omega equals to 2. So this is my target. My target is to find x of omega and then put omega equals to 2. So what I need to find? X of omega. So from here, x of omega will be equals to y omega into, because what I am applying? I am applying the multiplication convolution property. So multiplication convolution in time domain will result in multiplication in frequency domain. If you are multiplying, there will not be any factor of 2 pi. 1 by j omega plus pi del omega. So x of omega is y omega divided by j omega plus pi y of omega at omega equals to 0 del omega, right? So now our target would become to find out y of omega. So yt is given as sine 2t by 3t, sine 2t by 3t. What I need to find? Y of omega. Do I remember the direct expression? No. What I remember? Sine 80 by pi t, sine 80 by pi t. So what I will do? Pi by 3. This is your yt. Since it is sinc, so what we will get? Rect. So what will be your y of omega? Sinc, or I should say, since it is a sampling function, so in the in the frequency domain it will be rect, where the limit will go from minus a to a. That means limit will go from minus a to a with the amplitude of pi by 3. This is your y of omega. Now what do I need? What is my answer? X of omega is equals to y of omega divided by j omega plus pi. Y of omega at omega equals to 0. What is the value? Pi by 3. Y of omega at omega equals to 0, that is pi by 3 into del omega. Now what I need to find? X of omega at omega equals to 2. X of omega at omega equals to 2. So what you will put? Omega equals to 2. So y of omega at omega equals to 2. Again at 2 it is not defined. Why do I do these kind of error? So let's make it t only. Okay, let's make it t. So omega should be put as 1. Just 1 second. Yeah, so omega equals to 1. Why I am doing omega equals to 1? Because I know that at 2 it is not defined. No, like there is a sharp turn at 2. Okay, so better put 2 minus. So just less than 2, that would be 1. So here I am putting omega equals to 1 now. Now the question would become, this point would be t. So here what I need to put? Omega equals to 1 I need to put. Right? So never ever mess up this negative sign. Always see that t and t are there, so negative sign would be there. Otherwise there will be positive. So this is how this formula is very important. T and t both are opposite, so positive sign is there. Okay, so omega equals to 1. So here what we need to calculate now, omega equals to 1. X of omega at omega equals to 1. So y of omega at omega equals to 1 divided by j, omega equals to 1 I need to put. So j into 1 plus pi square by 3 del of 1. What is the value of del of 1? Delta t or delta omega or anything that is defined at omega equals to 0 only. At omega equals to 0, they will give infinite amplitude, right? But at omega equals to 1, they will give 0 amplitude. So this part will be gone. So now our answer is, now our A value, here I am directly writing the value of A. So our value of A will be y of omega at omega equals to 1. What is that? Pi by 3. Pi by 3 divided by j. So answer will be minus pi by 3j. This is the answer. All good? So this is how we will be solving the question. It feels like that it is a very big question, but it is actually very easy. So what did I do? First I saw that there is a running integration, that means convolution with ut. Convolution with ut means I can apply the property here. Which property I am applying? Convolution multiplication property. Convolution in time domain, multiplication in frequency domain. Then I did this, y of omega divided by j omega plus pi y of omega at omega goes to 0 del of omega. Then I need to see that what is our x of omega. X of omega will be equals to minus infinity to infinity xt e to the power minus j omega t dot dt. Now I can put omega equals to 1. If I put omega equals to 1, then the value of a I will get. So in x of omega I need to put omega equals to 1. So here I need to put omega equals to 1. So these kind of questions will be solved with a good amount of patience. So dial of 1, this will be gone. Now y of omega at omega equals to 1 divided by j. So now your target is to find y of omega. This is your yt. We remember there is, array yaar, it was sine 3t by 2t, right? I wrote down sine 2t by 3t. Really sorry guys, like those who have solved it on their own, they will have to change. Really sorry for these errors. So I completely changed the question actually. This would be 2, this would be 3. It was sine 2t by 3t. So here I am making sine 2t by 3t, but actually in the previous problem it was sine 3t by 2t. Okay, just blunder I did here, so that's why I need to change the problem. So sine 80 by pi t. So from minus a to a it is going with the amplitude of pi by 3. So sine minus a to a it is going. So sine 80 by pi t, this is something that I remember, but this is not the given form. So I made it sine 80 by pi t, then pi by 3 here. So pi by 3 minus 2 to 2. So this is what I am getting. My x of omega is y of omega divided by j omega. Then this part is gone. Here the amplitude is pi by 3. So pi by 3 divided by j. So minus pi by 3j. This is the answer that we are getting. All good? All fine? Let's see the next one. Let's see this question. Minus infinity to infinity, something then tau minus tau plus t. Are you able to relate what is happening here? Convolution. Again, convolution is happening, right? X of t, if I write down x of t convolution with yt convolution ht. So how will I write it down? Y of tau h of minus tau plus t dot d tau. The same thing is happening here, where y of t is sinc t and your h of t is sinc 3t. Say yes or no? Right? Minus tau plus t sinc 3t. So this is the scenario. So what is happening here? Xt is equals to yt convolution ht. This is what I need to calculate. So I just need to calculate x of t. So I need to convolve this and this. So basically what is your yt? That is sinc t. So sine pi t divided by pi t. Convolution with sine. C will be replaced with pi. So sine 3 pi t divided by whatever the angle is there divided by 3 pi t. So I need to convolve both of them, which is a tougher process, right? Convolving sinc function will be a tougher process. So what I will do? I will apply the property. So first I will apply the property and find x of omega. So from x of omega I can find x of t. What I will do? First I will find x of omega. What will be x of omega? Convolution in time domain will result in multiplication in frequency domain. So that would be equals to y of omega dot h of omega. Now whatever the result that you get, from here you can get this x of omega if you are having. So from here you can get x of t. Are you able to understand this point? Right? So sine pi t by pi t and then sine 3 pi by 3 sine 3 pi t by 3 pi t. So what is your yt? Yt is sine pi t by pi t. Sine pi t by yt. So can you draw y of omega? Yes. y of omega will be sine 80 by pi t, y of omega versus omega. So that would be sine 80 by pi t. That means it will go from minus pi to pi. It will go from minus pi to pi. Sine 80 by pi t, it will go from minus pi to pi with the amplitude being 1. And then you are having h of t sine 3 pi t by sine 3 pi t by pi t, because I need to make the form of sine 80 by pi t. So 1 by 3 I am taking outward, sine 80 by pi t. So your h of omega sine 80 by pi t. So it is going from minus 3 pi to plus 3 pi. Value of a is minus 3 pi. Value of a is minus 3 pi sine 80 by pi t with the amplitude of 1 by 3. This is your h of omega. Well and good. Now what you need to do? You need to multiply both of them. There should be multiplication between both of them, because what I need to calculate, y of omega into h of omega is equals to x of omega. So what will be your x of omega? So again and again I am telling the same thing. If you solve these kind of questions in the examination hall, there should be good amount of patience, nothing else. X of omega versus omega. So between minus 3 pi to pi, there is 0 into 1 by 3 will be 0 only. So the limit will go from minus pi to pi only. Basically between minus pi to pi it will be non-zero. Between minus pi, this will be minus pi and pi. Multiplication, you know how to do the multiplication. So from pi to 3 pi, it is having non-zero value, but it is having 0 value. So 0 multiplied with anything will be 0. Now between minus pi to pi, this is having value 1 and this is having value 1 by 3. So what will be the answer? 1 by 3 only. The answer is 1 by 3. So this is your x of omega. From here, can you write down your x of t? From here, you need to write down your x of t. So you can see the form sine 80 by pi t. This is the form. And then what is the amplitude? 1 by 3. So what is the answer? X of t is 1 by 3 sinc t. This is the answer. 1 by 3 sinc t. So this is your xt. So convolution of sinc t with sinc 3t is giving you 1 by 3 sinc t. All okay for you? All good? Okay then, so this is the answer. How did we solve it? Again I am repeating it. Xt was yt convolution with ht. Sinc t was given, sinc 3t was given. So what did I do? Sinc t sin pi t by pi t, sinc 3t sin 3 pi by t by pi t. Look, people would remember the standard results. I have seen that some people would remember the standard result that sinc t convolution with sinc t is this sinc 2t convolution with sinc 2t. Then you take the minimum value, then you take the maximum value. All these things you will not be able to remember in the examination hall. Okay, if you have already studied this subject, then you might feel like that, sir, I will remember some standard results and in the examination hall I will apply that. Those standard results you will be forgetting because there are 10 number of subjects, no? So always try to minimize the learning, that what you, sorry, always try to minimize the remembering part, that you should remember the minimum part, the least possible part. So here I can also write down some standard results, but they are not helpful in the examination hall. In the examination hall, this process will be helpful. So better than remembering some standard results, better focus on the process. So process is very simple, right? If you feel like that I can remember the standard result, then you can make the standard result, right? Sinc AT convolution with sinc BT. Then from here you can make some standard results. Will be equals to sinc of something divided by something here, minimum of A, B, all these things would come out. So those standard results you can make, but you will not be able to remember in the examination hall. So in the examination hall, you follow this process. Sinc t is given, sinc 3t is given. You write down sinc t, you write down sinc 3t. Then you know that I need to do the convolution in time domain. That will be multiplication in frequency domain. 1 by 2 pi will not come. Then multiplication in frequency domain. This is the multiplication that I have done. I know how to write down the Fourier transform of sine 80 by pi t minus pi to pi, sine 80 by pi t minus 3 by 2 3 pi with the amplitude of 1 by 3, 1 by 3. Then you did the multiplication minus pi to pi 1 by 3. Then sine 80 by pi t, sine 80, this is a, sine 80 by pi t with the amplitude of 1 by 3. So 1 by 3 sinc t. This is the answer. All good. Sinc 2t, convolution with sinc 2t, convolution with sinc 2t, convolution with sinc 2t. Then you need to find the value of x of 0. Can I do this process that my x of 0 will be equals to sinc 2 into 0 will be 0. So sinc 0, convolution sinc 0, convolution sinc 0, convolution sinc 0. It doesn't make any sense, right? It does not make any sense. First you need to calculate sinc t, then after that you need to put t equals to 0. Sorry, first you need to calculate xt, then you need to put t equals to 0. So first I will calculate xt and then I will put t equals to 0. So my first task is to calculate x of t here. How will I calculate x of t? Convolution is done, right? Convolution in time domain will result in multiplication in frequency domain, right? So if I say my yt is sinc 2t, then what I will see, x of omega will be y omega into y omega, convolution multiplication into y omega into y omega. So that would be equals to y of omega to the power 4. So yt is sine 2 pi t divided by sine 2 pi t. So 1 by 2 sine 80 by pi t, sine 80 by pi t. So what you are getting, y of omega. What is your y of omega? Your y of omega is, where is a, minus 2 pi to 2 pi. A is minus 2 pi to 2 pi. Sine 80 by pi t. And what is the amplitude? Amplitude is 1 by 2. But your x of omega is equals to y of omega to the power 4. So if I need to convert it to x of omega, then what I need to do? Or let's keep it here. If I need to make x of omega, then what I will do? Y of omega to the power 4. That means this amplitude will be having the power 4. Now what I need to calculate? X of t at t equals to 0. X of t at t equals to 0. So one way would be that from here I find x of t. I know the value of x of omega, from here I find x of t. Can I find x of t from here? Yes. Basically from here, if I take the inverse Fourier transform, I can find x of t. So what will be my x of t? My x of t will be sine 80 by pi t, sine 80 by pi t, sine 80 by pi t. If you just as you see rectangular, sine 80 by pi t and amplitude of 1 by 2 to the power 4. That means amplitude of 1 by 16. So this is your xt. Xt is sine 2 pi t divided by 16 pi t. What I need to calculate? X of t at t equals to 0. Indeterminate form it would be there. What you will get? 0 by 0 form, because what you need to calculate? X of t at t equals to 0. So 0 by 0 form you will get, you need to differentiate. So if you differentiate this, what you are getting? 2 pi cos 2 pi t and divided by 16 pi, right? And then you need to put t equals to 0. What I am applying? I am applying L'Hopital rule. So what I am applying? L'Hopital rule I have applied. So 2 pi cos 2 pi t, differentiation of sin 2 pi t would be 2 pi into cos 2 pi t divided by differentiation of 16 pi t would be 16 pi. So x of t at t equals to 0, I have applied the L'Hopital rule, differentiated upper side, differentiated lower side, and then put t equals to 0. What I am getting? 1 by 8. So this is the answer. This is the final answer of x of 0. Or what you could have done, what you need to calculate, x of 0. You know the formula of x of t, that is minus infinity to infinity x of omega e to the power j omega t dt, right? And if in the integration you see x of omega, that means here there will be 1 by 2 pi, right? What do you need to calculate? T equals to 0. If you put t equals to 0 here, what you are getting? 1 by 2 pi minus infinity to infinity x of omega. Again there is an error. Always I do this error here, d omega, x of omega d omega. So calculate the area of this graph and then divide by 2 pi. You will get x of 0. So what will be your x of 0? 1 by 2 pi. What is the area of this graph? Base into height. What is the base? 4 pi. What is the height? 1 by 16. So this and this got cancelled. What is the answer? 1 by 8. So x of 0 is coming out to be 1 by 8. So this would be 2. 2 divided by 2 into 1 by 6 would be 1 by 8. So x of 0 is 1 by 8. This is also 1 by 8. Okay. So multiple ways are there. So this is the process. Are you able to understand the process? Right? They could have asked only the xt value. So this would have been your xt. So xt is this. This would have been your xt. Or it would be written as 1 by 8 sinc 2t, right? It would be written as 1 by 8 sinc 2t. Because here also I need 2. So sin 2 pi t divided by sin 2 pi t into 1 by 8. So 1 by 8 sinc 2t. And sinc at t equals to 0 will throw 1. So this value will be 1 by 8 only. So 1 by 8 will be the answer. So just very simple process is there. Just follow the process and your answer will be achieved. You need to find the Fourier transform of sin 80 by pi t whole square. This we already know, right? But do it using the convolution multiplication property. So x of t is sin 80 by pi t into sin 80 by pi t. Sin 80 by pi t into sin 80 by pi t. This is your x of t. So what I am saying, I am assuming my y of t as sin 80 by pi t. So what will be your x of omega? X of omega will be multiplication in time domain will result in convolution in frequency domain, but divided by 2 pi. So this is your x of omega, and from here I can get my, okay, I need to find the x of omega only. So can you draw y of omega? Yes, surely I can draw y of omega. Sin 80 by pi t, standard form it is sin 80 by pi t. So between minus a to a, between minus a to a, between minus a to a, amplitude being 1, amplitude being 1. So this is your y of omega, right? Again I need to draw the same thing. What I need to do? Convolution. So convolution of rect pulses, have you studied it? Convolution of rect pulses, have you studied this particular thing? Yes, if you remember, there was a standard way of solving it. So what did I tell you? Lower limit added minus 2 pi, minus 2a. Upper limit added plus 2a. Then you see the width. What is the width here? 2a. And what is the width here? 2a. You need to pick the minimum width. What is the minimum width? 2a only. So from lower limit to 2a and from upper limit to 2a. Now this will be the transition point. So the final answer will be triangular. Final answer will be triangular here because this is the transition point. So from lower limit to 2a distance, from upper limit to 2a distance. So this will be the transition point. What is the value of slope? Slope will be 1 into 1. So slope will be 1. Slope will be equals to 1. So what will be this point? If this distance is 2a, so this point has to be 2a. Because 2a divided by 2a, slope will be 1. Next slope will be minus 1, but I need to check the initial slope only. So this is how we will get it. This is the answer of y omega convolution with y omega. But what is your x of omega? X of omega is 1 by 2 pi y omega convolution with y omega. That means whatever y omega convolution y omega you are getting, you need to divide it by 2 pi. That will be your x of omega, right? So this is your, now from here I need to calculate x of omega. So just your amplitude will be divided by 2 pi. Amplitude will be divided by 2 pi. So 2a by 2 pi will be a by pi. 2a by 2 pi. This amplitude 2a by 2 pi will be a by pi. So minus 2a minus 2a. Now can you, this is your x of omega. So yeah, this was your x of omega. There you go. This was your x of omega, right? And x of omega can be written in this form. X of omega will be a by pi triangular omega minus center upon width of one side. So this is your x of omega. And you can directly see this was only our way. What we used to do, sine 80 by pi t whole square. That means the limit will go from, this 2 would come here, the limit will go from minus 2a to 2a, the limit will go from minus 2a to 2a with the amplitude of a by pi. And whatever the multiplication was there, the same factor would come out. So a into a by pi. So here we would have got a into a by pi. So this is our x of omega. Say yes or no. Okay, so just we applied the convolution property here and we got our answer. Well and good. x1t is having a Fourier transform of x1 omega. x2t is having a Fourier transform of x2 omega. x1t and x2t both are given. You need to find y of omega, which is equals to minus infinity to infinity x1 omega x2 omega, so x1 omega dot x2 minus omega plus alpha dot d alpha is equals to y of omega. So first you need to find y of omega, then y of omega is having inverse Fourier transform of yt, then you need to find yt. So have the patience and see what we are telling here. What is your y of omega? Can you tell me? Y of omega is actually x1 omega convolution with x2 of omega. Do you agree to this point? x1t convolution with x2t. What that would be? x1 to dot. Okay. There is an error here. x1 to. Now this is right. Are you able to understand this point? x1t convolution with x2t was given as minus infinity to infinity x1 to x2 of minus tau plus t dot d tau. So similar thing is happening here. x1 omega convolution with x2 omega is given as x1 alpha dot x2 minus alpha plus omega d alpha. So from here what will be the answer? You will be getting y of omega. So this is your y of omega is x1 omega convolution with x2 omega. Convolution in time domain. Now from here if I need to find y of t, so convolution in a frequency domain, convolution in frequency domain will be equals to the multiplication in time domain. Say yes or no. Look, what was the property? x1t convolution with x2t will result in convolution in time domain will result in multiplication in frequency domain. But this is not we need. We need convolution in frequency domain. That means I need to do the multiplication in time domain. So multiplication in time domain will result in convolution in frequency domain. But if you are doing the convolution in frequency domain, then you need to divide by 2 pi as well. So from here what you are getting, x1 omega convolution with x2 omega will have the inverse Fourier transform of 2 pi into x1t dot x2t. So surely you will multiply x1t dot x2t. Surely you will multiply x1t with x2t. But don't forget to multiply by 2 pi as well. Are you able to understand this point? x1t dot x2t will be having the Fourier transform of x1 omega convolution with x2 omega. But if you are doing the convolution here, 2 pi factor will also come. So from here what you get to know is that x1 omega convolution with x2 omega will have the inverse Fourier transform of 2 pi into x1t dot x2t. So 2 pi into x1t dot x2t. So what will be your y of t? So here I am finding y of t. So y of t will be these multiplication sine 2t divided by 2t dot sine 3t divided by 3t. So this will be your yt. Okay, so this is the final answer of yt. But this yt I need to find, but y of omega, what about y of omega? So y of omega is convolution of x1 omega with x2 omega. So you need to do the convolution here. Y of omega is x1 omega convolution with x2 omega. One thing you can do that you are having yt, so from here you find out y of omega, which is not possible because this is not a standard signal. If it is not a standard signal, then perform this particular thing, no? So can you draw the diagram of x1 omega? Yes. Can you draw the diagram of x2 omega? Yes. Because this will be x1 omega will be rect, because this is sampling rect. So this will also be rect, this will also be rect. And convolution of rectangular pulses we can do very easily. So better we will solve here only. Okay. So this I will draw, this I will draw. Basically I will draw x1 omega, I will draw x2 omega, and then I will convolve them. So do this process, I will take a break and then I will come back. Okay, so from going from here to y of omega is not that easy. So directly I can solve here only. So if they were only asking y of omega, then what I would have done? x1 omega convolution with x2 omega. Then I would see that this is sampling, this is sampling. So in the frequency domain it will be rectangular, and for the rectangular pulses I know how to do the convolution because that is a standard process. See the width, lower limit, higher limit, see the width, initial slope, and then zero slope, negative slope. All these process we have already studied. So do that process and I will come back. You can also take a break if you want to take a break. Okay, yeah, welcome back. So what we needed to do, we need to convolve two signals. So here x1t and x2t are being multiplied, but what we need to find the convolution of x1 omega, x2 omega. Now I know that x1 omega will be rectangular and x2 omega will also be rectangular, and convolution of rectangular pulse, it is a standard process. So I can find my x1 omega and then I can find my x2 omega, and then there is a standard process of convolving two rectangular pulses. So I prefer convolving x1 omega and x2 omega here. So what I will be getting? Why I am putting t? Really sorry. Versus omega. So what will be your x1 omega? Sine 80 by pi t, right? Sine 80 by pi t. So a is going from, the limit will go from -2 to 2. So omega value will go from -2 to 2 with the amplitude being 1. With the amplitude sine 80 by pi t, amplitude being 1. Amplitude being 1. And what about x2 omega? x2 omega. So this can be written as sine 80 by pi t. So pi get cancelled, sine 30 by 30 we will get. So sine 80 by pi t. This is the form I need to make. So pi by 3 is the amplitude here. So limit is going from -3 to 3. What is the value of a? Value of a is 3, and the amplitude being pi by 3. Amplitude being pi by 3. It is going from -3 to 3. What I need to do? I need to convolve both of them because this is my y of omega. This will be your y of omega versus omega. So add up the lower limit -2 -3. It will be -5. Add up the upper limit 2 plus 3. It will be +5. Calculate the width. Width here is 4. Calculate the width. Width here is 6. So which is the lower width? Lower width is 4. So from here 4 distance away, this will be point -1. From here 4 distance away, this point will be 1. So how we will start? We will start from minus infinity like this. Then there will be a initial slope, then constant, and then decreasing slope till 0. So this is how you convert two rectangular pulses. Now what about this slope? This slope will be pi by 3 into 1. So slope here will be pi by 3. Now this width is 4. This width is 4. So this point has to be 4 pi by 3. Say yes or no? Because 4 pi by 3 divided by 4 will be giving the slope of pi by 3, right? This width, this height has to be 4 pi by 3, right? This height has to be 4 pi by 3. So if this height is 4 pi by 3, 4 pi by 3 divided by 4 will give the slope of pi by 3. Say yes or no? All good? So this is your y of omega. So this is what we wanted to find. All good? So this is our y of omega. So let's see the question. In the question they were asking y of t and y of omega. Y of omega was convolution of x1 omega, x2 omega. We saw the signal x1t, x2t. When we convert into time domain, convolution in frequency domain will result in multiplication in time domain. So that we got to know that it is 2 pi x1t, x2t. So from here also we could have find out y of omega, but this is not a standard signal. It is not a standard signal, so we don't know the direct answer. So for that what we did? We have to convolve the signals only. We have to convolve the Fourier transforms only. Then we saw the signal. This was a sampling signal, this was also a sampling signal. And I know that sampling signal in frequency domain will result in rectangular pulses. And I know how to calculate the convolution of rectangular pulses. And that we did. So we just needed to find the Fourier transform and then we needed to do the convolution. Well and good. So this is what we did. So this is our y of omega. All good. Let's see the next question. In the next question they have given x1 omega, x2 omega, and then they are asking the convolution. So that means you need to convolve sampling, or you can say sinc function, to the square of sinc. Is it easy? Do you know any standard process for convolution of sampling functions or sampling square function or sinc function? Is there any standard process? No. That means now I need to apply the property. So some property has to be applied. That's for sure, because I don't know the standard process, Are you able to understand this point? So now I need to apply the property x1t dot x2t will have a Fourier transform of 1 by 2 pi x1 convolution x2. So from here x1 omega convolution x2 omega, x1 omega convolution x2 omega will have inverse Fourier transform of 2 pi into x1t dot x2t. And once I get this value, I can calculate its Fourier transform. And when I calculate its Fourier transform, what I will get? This I will get. Are you able to understand this point? What I need to calculate? My target is to calculate x1 omega convolution with x2 omega. This is my target. So what did I thought of? I can apply some property that x1 omega convolution with x2 omega will have inverse Fourier transform. That means what will be the inverse Fourier transform of this particular thing? That means it would be coming from 2 pi into x1t dot x2t. So once I get this particular thing, after that I can calculate its Fourier transform and I will get x1 omega convolution with x2 omega. Inverse Fourier transform and then Fourier transform. Then I will get the same thing. Say yes or no, right? So what and why I am not doing the convolution directly? Because I know that this is not a standard signal. I don't know how to convolve two sampling functions. But I know one thing, that it would have come from a rectangular pulse and this would have come from a triangular pulse. Say yes or no? This would have come from a rectangular pulse, rect t, and this would have come from a triangular pulse. Right, because frequency domain is sampling square, that means time domain would have been triangular, and frequency domain is sinc, that means time domain would have been rectangular. So what do we know? A rect t by tau will have a Fourier transform of a tau sampling omega tau by 2. What is this? x1 omega, that is sine 2 pi omega divided by 2 pi omega, because c will be converted to pi. It can be written as sampling of 2 pi omega. Say yes or no. This is your x1 omega. It can be written as sampling of 2 pi omega, right? So here your tau by 2, here your tau by 2 will be equals to 2 pi. If I compare, so my tau by 2 will be equals to 2 pi, because I need to compare it. So from here, what is the value of tau? Tau will be 4 pi. Tau will be 4 pi, and that's it. This is what I need, and a to a I can cancel out. So rect t by 2 pi, sorry, rect t by 4 pi will have a Fourier transform of 4 pi sampling of omega tau by 2, 4 pi by 2, so omega into 2 pi. This 4 pi can go here, this 4 pi can go here, or you could have find out the value of a as well. Basically, you could have find out the value of a. From here, a tau will be equals to 1. If I don't cancel it out, this is how we used to do it. So here, what is the factor? Factor is 1. So what is the value of a tau? A tau is equals to 1. So from here, value of a is equals to 1 by 4 pi. So 1 by 4 pi rect t by 4 pi will give you a tau sampling of omega tau by 2. And this is equals to sampling of omega 2 pi omega. Sampling of 2 pi omega is equals to sine 2 pi omega divided by 2 pi omega, which can be written as sinc of 2 omega. Yes, this is what I needed to find. So this is my rectangular signal. What is my rectangular signal? So this is my x1t. I have got x1t. And what is my target? My target is to find x1t dot x2t. This is my target. So as of now, I have got x1t. Now I need to find x2t. So for that, what I remember? A triangular t by 2 will have a Fourier transform of a tau sampling square omega tau by 2. So from here, sampling of 3 omega is given. That means tau by 2 will be equals to 3. So from here, tau is equals to 6. And there is no factor. That means a tau is equals to 1. That shows that a is equals to 1 by 6. T by 6 a tau sampling square omega tau by 2. So this is something that we will get, and yeah, we are getting the same thing. So this is our x2t, right? So what we need to do? First we need to draw x1t, then we need to draw x2t, and then we will get the multiplication, right? So what is our x1t? x1t is t minus center upon time width. So complete time width is 4 pi. Complete time width is 4 pi. So one side is 2 pi, other side is minus 2 pi, and here amplitude is 1 by 4 pi. What about this one? T minus center upon width of one side. T minus center upon width of one side. Width of one side. So here width of one side will be 6, here it will be minus 6. And what is the amplitude? 1 by 6, right? So this is your x1t versus t, and this is your x2t versus t, and both needs to be multiplied. Both needs to be multiplied. What is this point? 2 pi. What is the meaning of 2 pi? Minus 6.28, roughly minus 6.28, and this is 6.28. So between 6.28, basically minus 2 pi would have been somewhere here, and plus 2 pi would have been somewhere here. You need to multiply both of them. Can you do the multiplication? Surely you can do the multiplication. Basically, this particular part will be multiplied with 1 by 4 pi. But between minus 2 pi to minus 6, between minus 2 pi to minus 6 would have been somewhere here. Plus 6 would have been somewhere here. So between minus 2 pi to minus 6, this was 1 by 4 pi, but this was 0. And 0 multiplied with anything will be 0 only. So what do you think? What will be the final answer here? What is the multiplication? So this is what multiplication will throw. This is what your multiplication will throw. So this is your multiplication is throwing. Between minus 2 pi to minus 6, everything was 0. Then it will be triangular. So x1t dot x2t. x1t dot x2t. So 1 by 4 pi into 1 by 6. So that would be 1 by 24 pi, right? 1 by 4 pi into 1 by 6. So that would be 1 by 24 pi. 1 by 24 pi. So this is what we are getting, x1t dot x2t, x1t dot x2t. But what is our target? Our target is, I am calling this as yt. Okay, what I am doing, I am calling this as yt. So our target is to find 2 pi into x1t dot x2t. So what is our yt? Yt is 2 pi into x1t dot x2t. So this will be multiplied with 2 pi. This will be multiplied with 2 pi. So what I will get here? 12. So this was your 24 pi and I will multiply with the 2 pi. So what I will get? 1 by 12. 1 by 12. This is my yt. And from here you need to find y of omega. What you need to find? You need to find Fourier transform y of omega. So what do you think, what will be your y of omega? It would be sampling square, that's for sure, right? It would be sampling square, that's for sure. How you can write down? This is your yt. So what is your yt? A try t minus center upon width of one side. This is your time domain. So what will be your frequency domain? Or A2 sampling square omega 2 by 2. So what is the answer? Sampling square 3 omega divided by 2. So this is the final answer. This is our answer. So basically, convolution of these two, sync 2 omega, sync 2 omega, convolution with sampling square 3 omega will result in sampling square 3 omega by 2. So this is the answer. So the point is, all these questions are easy. It may seem tough in the examination hall. It may seem tough that sir, how we will solve. But you need to believe yourself that I know everything. I know everything. Just step by step, if I follow, then my job will be done. Here I should not write rect. I should have just written rectangular in time domain. Rectangular in time domain. And this will be triangular in time domain. So this is the first thing that will click to me, that I need to find x1 omega convolution with x2 omega. I need to do the convolution. I don't know what is the standard process of doing the convolution of a sync and sampling square. Then what I can see, I can convert it into time domain. If I convert it into time domain, then what I will be getting? 2 pi x1t dot x2t. That means I will have to multiply a rectangular signal with a triangular signal, and that multiplication I can do. And if I get that particular multiplication, then I can convert it to, after the multiplication, whatever the waveform I can get, and from there I can get my Fourier transform. So I will get my final answer of x1 omega convolution with x2 omega. So this is what I did, 2 pi x1t dot x2t. So I find out x1t, then I find out x2t, and then I multiply both of them. X1t was easy only, a rect by tau, and then I multiply both of them. Then I got to know this, but I did not want x1t dot x2t. I wanted 2 pi into x1t dot x2t. So this is the waveform. This is the final waveform I am getting. I just need to calculate the Fourier transform now. So so this is how I calculated the Fourier transform, and the Fourier transform came out to be sampling square 3 omega by 2. There you go. This is the answer. Okay, very easy. Next, we need to study about Parseval's theorem. So Parseval theorem will be commenting on energy, right? It will always comments on energy. But forget about the statement, forget about Parseval theorem, anything you forget about, every single thing. Just answer me this particular thing. We are just doing a integration, which is x1t dot x2t dot dt. This is what we are doing. Can you perform this integration? From this integration, we are going to get a very good result, and that result is more important than the Parseval theorem. Okay, from this particular result, we will derive our Parseval theorem as well. So let's start. What I will be doing is that minus infinity to infinity, I am keeping x1t as it is. I am writing down the how I will write down x2t. So x2t can be represented as 1 by 2 pi minus infinity to infinity. I am saying that the Fourier transform of x1t is x1 omega, and Fourier transform of x2t is x2 omega. This is what I am saying. So x2t can be written as 1 by 2 pi minus infinity to infinity x2 of omega e to the power j omega t d omega, and then after that for the whole there is dt. Do you agree to this point? What I am doing, I just replaced my x2t, because what could be your x2t? Your x2t could have been 1 by 2 pi from the Fourier transform. Can you calculate your inverse Fourier transform? That means, can you calculate your time domain signal? Yes, 1 by 2 pi x2 omega. Here there is t, so here also there will be t. There will not be any negative sign, into d omega. Right? So 1 by 2 pi can come outward. From here what we can see is that this derivation is not important, but the final result is important. So 1 by 2 pi is a constant value that can come outward. Now in this integration is done with respect to omega. So x1t is a constant value for this particular integration. Say yes or no. What I am saying, x1t is a constant value for this integration. So can I take x1t inside? Surely you can take x1t inside. What I did, this x1t I am taking inside. x1t x2 omega e to the power j omega t d omega. You perform this integration, and after that you integrate it with respect to time t. This is what I am saying. 1 by 2 pi minus infinity to infinity. Then again here, just a second guys. Yeah, sorry for the interruption. So here, now a very important step would come. A very important step of derivation would come. So I am writing down in this manner: minus infinity to infinity x1t e to the power j omega t dt dot x2 omega d omega. What did I do here? I just took this e to the power j omega t x1t e to the power j omega t then dt, and then I put it in a box, and then x2 omega d omega. How did I do it? Look, let's see this integration. I am just assuming that my x1t is 3t, okay, and x2 omega e to the power j omega t is this whole function. Let's just say x2 omega is omega, then e to the power j2t, or I should write e to the power j omega t only, dot d omega dot dt. This is the scenario, right? So first I need to do this process. I need to follow this process. So what is actually happening here? Can I do in this manner? 3t into e to the power j omega t dt. This will be a function of what? This final integration will be a function of what? It will be a function of omega only, no? 3t e to the power j omega t dt. This will be a function of omega only, because why is that so? Because you are putting the constant limit of t. What you are doing, you are putting the constant limit of t. So whatever the integration that you get, after that you will put the constant limit of t. So t will be gone, only omega will be left. So this particular integration will be a function of omega. So from this integration I will get something function of omega. So what I will be getting, something function of omega. After that what will be left? Omega will be left, dot d omega. Now you need to integrate with respect to omega. Now you will put the limit of omega, and eventually you will get a constant value, and here also you will get a constant value only because you will be putting the limit of t. This whole function is a function of t only. Basically what is the scenario? If I do this particular integration, what will be the answer? It will be a constant value. But if I do this particular integration, 3 omega t dt, what will be the answer? It will be a function of omega. Why is that so? Because I will be putting the limit of t, but omega will be a constant here. Are you getting this point? And if I do the integration with respect to omega, then it will be a function of t, because I will be putting the limit of omega. So t will be a constant value. So here in the first integration, here the scenario was x1t was a constant value, so I took it inside. Then what I did, I made this integration as the integration of t first. So if I solve this particular integration, I will be putting the limit of t, so I will be getting a function of omega. and that function of omega is multiplied with another function of omega, and you are again integrating with respect to omega, and then you are again putting the limit of omega. Is that clear to you or not, what I am doing? Look, derivation is not that important, but the same thing we are going to study in mathematics as well. Even in EMFT we study the same thing, that this is how two limits are there. So this is how I can break it. x1t, x2 omega e to the power j omega t d omega dt. So what did I did? I took all the t terms aside, and then I am integrating with respect to t and putting the limit of t. So I will get a function of omega, which will be multiplied with the function of omega, and then you are integrating with respect to omega, putting the limit of omega. So after this step, everything will be a omega function only. So this is how you can break it. So this was the important step, that how I broke it down. Okay, this was just a formula. So this was important, that how I broke it down. Now what is your x1 omega? X1 omega is minus infinity to infinity x1t e to the power minus j omega t dt. Now in place of omega, if I put minus omega, what I will be getting? Minus infinity to infinity x1t remains as it is. In place of omega, if I put minus omega, so x1t e to the power j omega t dot dt, x1t e to the power j omega t dot dt, what that would be equals to x1 omega. So what I am getting? 1 by 2 pi minus infinity to infinity. This whole integration can be replaced with x1 of minus omega dot x2 of minus omega d omega. So this is what I am getting. On the next page I am writing it down. x1t dot x2t is equals to 1 by 2 pi minus infinity to infinity Fourier transform of one signal, although here there is negative, Fourier transform of one signal, Fourier transform of another signal, but mirrored image dot d omega. This is the answer you are getting, a very, very important term. Along with that, I can write down another form as well. Basically, two signals are in multiplication, no? So how I can write it down? Minus infinity to infinity x1t dot x2t will be equals to 1 by 2 pi minus infinity to infinity Fourier transform of first signal dot Fourier transform of second signal, but mirror image d omega. Minus infinity to infinity x1t dot x2t will be equals to 1 by 2 pi Fourier transform of one signal dot Fourier transform of another signal, but mirror image dot d omega. There you go. Very, very important conclusion. Very important. It can be asked in 1 mark in true or false. Okay, it can be asked in 1 mark in true or false. So this is the conclusion that we have made. Minus infinity to infinity x1t dot x2t will be equals to 1 by 2 pi minus infinity to infinity Fourier transform of first one, Fourier transform of second one, but mirrored image omega. Or what can happen? Basically, how did I get this step? Whatever that you did with x2t, the same thing you need to do with x1t. So you will get this answer. Basically, here you are getting x1 minus omega, x2 omega. So this is the answer you are getting. How you can get this answer? Two signals are in multiplication, no? Two signals are in multiplication. So whatever the process that you did with x2t, the same process you do with x1t, and keep x2t as it is. Keep x2t as it is and do the same process with x1t. Which answer you will get? This answer you will get. Are you able to understand this point? These are in multiplication, right? And I am not sure if I am writing down correctly, because dot dt. Right, two signals are in multiplication. So here also they are in multiplication only. So what you can say? First Fourier transform as it is, another one Fourier transform but mirrored image. First Fourier transform as it is, another one Fourier transform but mirrored image. Then you need to integrate it, divide by 2 pi. So this is what we get, a very, very important conclusion. So instead of just remembering only one statement in our Parseval's theorem, we should remember it in this manner. Now there are some other special cases. So what did I tell you? 1 by 2 pi minus infinity to infinity Fourier transform of first one. What is the Fourier transform of first one? X1 omega. Fourier transform of second one. What is the Fourier transform of second one? X2 of omega minus omega. Because what is the Fourier transform of X2 conjugate t? If I am saying that X1t is having a Fourier transform of X1 omega and X2t is having a Fourier transform of X2 omega, then what will be the Fourier transform of X2 conjugate t? That would be X2 conjugate minus omega. X2 conjugate minus omega. But when we write down this identity, what we do? In place of omega, we put minus omega. In place of omega, we put minus omega. So this will be plus omega. Basically, direct Fourier transform you need to write down here, but you need to take the mirror image. Here I wrote down the direct Fourier transform, but I took the mirror image. So here also I did the same thing. I wrote down the direct Fourier transform, but I took the mirror image. So minus sign was gone. Is that clear to you? Dot d omega. So in true or false, it can be asked that which of them is true. So this is a true identity, right? What about this one? Minus infinity to infinity x square t dot dt. Can I write it down in this manner? Minus infinity to infinity x1t dot x2t dot dt. Say yes or no. Surely I can write down in this manner. Minus infinity to infinity Fourier transform of first one dot Fourier transform of second one, but mirrored image dot d omega. And blunder I am doing. What is that blunder? That I am forgetting 1 by 2 pi. Another thing, all these things can be written in terms of f as well. But when you write down in terms of f, this will come as it is, this will come as it is, but omega will be replaced with 2 pi f. And 2 pi will come outward and it will cancel out this 2 pi. This we have already seen, right? Whenever you write down anything with respect to f, this 2 pi will not come into action. So with respect to f, what will be the answer? Minus infinity to infinity x1t dot x2t dot dt minus infinity to infinity Fourier transform of first one dot Fourier transform of the second one, but mirrored image dot df. Because omega is replaced with 2 pi f and 2 pi came outward, so 2 pi got cancelled. Minus infinity to infinity x1t dot x2t dot dt. How you can write down? First one inverted, or you can say mirror image, second one as it is dot df. So all can be written in this form as well. Similarly here as well you can write it down. What about this one? This would be minus infinity to infinity x1 f dot x2 conjugate f dot df. What about this one? Minus infinity to infinity x1 f dot x2 of minus f df. What about this one? Minus infinity to infinity. First tell me what this will be equivalent to. What this will be equivalent to? When you multiply a signal with its conjugate, what do you get? Mod of that and then squared. What it is representing? Energy of xt, right? When you multiply a signal with its conjugate, what do you get? Mod of xt square. And what is mod of xt square dot dt integrated over a complete time window? What is that? Energy of xt. So this is your energy of xt, right? That would be equals to 1 by 2 pi. Now look here. Now look here. So 1 by 2 pi minus infinity to infinity. Fourier transform of first one x1 omega. Fourier transform of second one x1 conjugate minus omega but inverted dot d omega, right? So what you are getting? 1 by 2 pi. When you multiply a signal with its conjugate, what do you get? Mod of that signal squared. Mod of that signal squared. So what did you get to know? Energy of xt is equals to this particular thing, and this particular thing is equals to this particular thing. So energy of xt is this, which is coming out to be equals to this one. And can you write down in terms of f? Yes, omega will be replaced with 2 pi f and 2 pi will get cancelled out. So this is the final conclusion we are making. Energy of xt is equals to minus infinity to infinity mod of xt square dot dt 1 by 2 pi minus infinity to infinity mod of x of omega square d omega. That would be equals to minus infinity to infinity mod of x of f square dot df. This is known as Parseval's theorem. But Parseval did not do anything very specific. Okay, he did not do anything that we don't know. We already know this particular thing. If we know this particular thing, then we can find out the energy very easily. Even in the when we are studying Fourier series, at that time also I told you that don't remember the name of Parseval. Okay, don't remember the name of Parseval. You can just directly see that C naught square plus mode of C1 square plus mode of C2 square plus mode of C3 square plus mode of C of minus 1 square plus mode of C of minus 2 square. In that manner, you can directly see. So Parseval just tells about energy, but everything we already know. So what is the bottom line? What is the most important statement? That is the most important statement. From here, the things have come out, right? So these kind of questions I am expecting important. These kind of questions I am expecting that it will be coming in your examination. They will give minus infinity to infinity x1f dot x2f dot df. Is it equals to this particular thing? Say yes or no. Is it true or false? So what you will do in the examination, that sir, first thing I already know that multiplication of two signal x1t dot x2t and then integrated over a complete time window will be equals to, in terms of omega, but they are talking in terms of f. So in terms of f, if I write down, then 2 pi will not come outward. So Fourier transform of first one, Fourier transform of second one, but mirrored image dot df. Now here what they are asking, x1 minus t. Here in place of t you need to put minus t. So in place of f you need to put minus f. In place of f you need to put minus f. But this is the option they are saying. So what they actually doing is that this is something that I need to calculate now. So what I can say, Fourier transform of second one as it is, Fourier transform of second one as it is, Fourier transform of second one as it is, Fourier transform of first one, what that would be, x of minus f, but I need to take the mirror image. So what it would be, x1 of f. So x1 of f dot df. There you go. Are you able to understand this point? Second one as it is, Fourier transform of first one, what that would be, x1 of minus f, but I need to take the mirror image, so this minus sign would be gone. So x1f dot x2f dot df. That's it. So this is the first statement. Minus infinity to infinity x1f dot x2f dot df, x1 minus t, x2 minus t dot dt. What about the second one? Is this correct? Second one, is this correct? No. We can directly see. Or it might be correct. Let's check. It might be correct. Let's check. So minus infinity to infinity x1t dot x2t minus t, x1t dot x2 conjugate minus t dot dt. So what I will write down, minus infinity to infinity. They are not doing anything with x1f. So x1f as it is. What about the second one? So what will be the Fourier transform of this particular thing? That would be x2 conjugate minus f, but because of minus t, another sign will be, it will be plus f. But now here what I will write down? Here I will write down the mirror image. So another minus sign will come into action. Are you able to understand this point? What I am saying? What is the Fourier transform of x2t? That is x2f. What will be the Fourier transform of x2 conjugate t? That would be x2 conjugate minus f. What will be the Fourier transform of x2 conjugate minus t? So in place of t, if you are putting minus t, so here in place of minus f, you will put plus f. So this is the answer. So Fourier transform of x2 conjugate minus t is x2 conjugate f. But here what do you put? Here you put the mirror image, minus f dot df. There you go. So this is the second statement, which is also true. So both true, none is wrong. Is that clear to you? So very, very important thing, that just the bottom line is, if you remember this particular thing, then everything is very easy. And you should remember this statement as well. Okay, this statement as well, because we will be using it somewhere. Which statement? Minus infinity to infinity, energy of xt is equals to the, yeah. So this is something I will write it down here. Note. So what we get to know, energy of xt is equals to minus infinity to infinity mode of xt square dot dt. That was equals to 1 by 2 pi minus infinity to infinity mode of x of omega dot d omega. Can I call this particular thing as energy of x of omega? Can I call this as energy of x of omega? If I give you a signal called x of omega and I ask you what is the energy of x of omega, what you will do? Sir, minus infinity to infinity mode of x of omega, then take the square d omega. So is this energy of x of omega? Yes. Energy of x of omega divided by 2 pi. So what you are getting from here? That energy of x of t is equals to energy of x of omega divided by 2 pi. So if you directly don't know the energy of xt, if it is becoming tougher to do this integration, but you know how to find out the energy of x of omega, then you can take help of this particular identity. You can take help of this particular property, right? So energy of x of t is equals to energy of x of omega divided by 2 pi. And if I need to write it down in terms of f, then what I will write down? So from here what I am getting to know is that energy of xt is equals to energy of x of f. Okay, we will be using these properties in solving the problems. Some important standard areas. Do we remember all these standard areas? Minus infinity to infinity sampling t. What was the area of this particular thing? In basics of signal we have wrote it down. What was the area? We will surely solve some problem based on this Parseval's theorem. But before that, we are just revising our area that we directly remember. Do you directly remember the area of sampling function? That was pi. Do you directly remember the area of sinc function, standard sinc function? That was 1. What was the area of sampling square? That was also pi. What was the area of sinc square? That was 1. Now you can prove it using your Fourier transform. Because sinc t, what will be the Fourier transform of sinc t? Sin at by pi t. So from minus pi to pi with the area, with the amplitude being 1. So this is your Fourier transform of sinc t. Fourier transform of sinc t. Say yes or no? Fourier transform of sinc t. Right? And what did I tell you? X of omega is given as minus infinity to infinity x of t e to the power minus j omega t dt. Now if you put 0 here, in place of omega you put 0. So x of 0 will be minus infinity to infinity xt dt. In place of xt what I am putting? Sinc t. So sinc t dot dt will be equals to, find out its Fourier transform and find the value at omega equals to 0. What is the value at omega equals to 0? That is 1. So what is the answer? 1. So what this integration will throw? 1. So this is how you can calculate it. We can do it for sampling square. Let's do it for sampling square. Sampling square t. Sampling square t. It can be written as sin square t divided by t. Can be written as sin at by pi t. This is the form we need. So multiply by pi square. Do you agree to this point? What will be its Fourier transform? Its Fourier transform would be sin, it will be triangular, will be going from minus 2a to 2a. This is a, right? A value is 1. So it will be going from minus 2 to 2. Minus 2 to 2. With the peak amplitude of pi square into a by pi. What is the value of a? 1. What is the value of pi? Pi. So peak amplitude of pi. Peak amplitude of pi. Right? So this is the Fourier transform of this particular signal, that is sampling square t. And what will be your minus infinity to infinity sampling square t dot dt? That will be, find its Fourier transform and then find the value at omega equals to 0. So what is the value at omega equals to 0? That is pi. So yes, we are getting the same thing. All good? All fine? Okay. Same you can do for sinc square as well. You will get the answer 1. How do I remember it? Look, in sampling t, is there any pi? Sampling t, sin t by t, there is no pi. So if there is no pi, in the area pi would come, and in sinc there is already pi, right? So in the area pi would not come. Then do the square. Square will also throw the same result. Whatever the result we were getting without square, the square will also throw the same result. But can you say that, sir, minus infinity to infinity, sir, sampling to the power cube t, this will also be equals to 1. Or sir, sampling to the power 4t, this will also be equals to 1. Absolutely not. How you can say this is equals to 1? Only two standard results are there, sampling t, sampling square t. Luckily they are coming same. It doesn't mean that any power will throw pi. Okay, are you able to understand this point? Oh, not 1, sorry, pi. So are you able to understand this point, that any power doesn't mean that it will always throw pi? No. For power 1 and for power 2, it is luckily throwing pi only. but it is always not necessary that it will always throw pi. Here also, luckily for 1 power and luckily for 2 power, it is throwing the result as 1, but it is not always true. So it's not that you generalize it that any power minus infinity to infinity sampling of any power t dot dt. Is there any pi in sampling t? No pi. So answer will be pi, which is absolutely wrong. Okay, minus infinity to infinity sinc to the power n t dot dt. Is there any pi in sinc? Yes. So answer would be 1. But no, this is not generalized. Are you able to understand this point? This is not a generalized, not any power, only power 1 and power 2. Luckily, we got the same answer. Secondly, I told you a trick to remember that sampling t will throw the area to be pi. How do you remember? Because sampling t is sin t by t, which is not having any term of pi, so in the answer pi would come. And what about sinc t? Sinc t is sin pi t by pi t, sin pi t by pi t, so it is having a term of pi, so in the answer 1 would come. So if pi is already present, so in the answer pi will not come, and if pi is not present, then in the answer pi would come. What about e to the power minus pi t square? This area also you need to remember, this area is equals to 1. E to the power minus pi t square, this area is equals to 1. How do you remember this? E to the power minus pi t square, if pi is coming in the answer, there will be 1. So 5 standard results we remember. These 5 standard results we remember because it will help us a lot in solving the problems. So e to the power minus pi t square dot dt will throw the area to be 1. You can integrate it, but it will take a lot of time. So always remember the final result. Minus infinity to infinity, e to the power minus pi t square dot dt will throw the area to be 1. How do you remember? Always the confusion will be between 1 and pi. We remember the result for 1 and pi. Okay. How do I remember? That sampling is not having any term of pi. So in the answer pi would come. Sinc t, yeah, this is having a term of pi, so in the answer 1 would come. E to the power minus pi t square, this is also having a term of pi, so in the answer 1 would come. There you go. Now these basic things we have already studied, that if area of xt is a, then what will be the area of x of at? That would be a by mod of a. Say yes or no? Minus 2 to 2. What is the area? 4 into 4. If I calculate x of t by 2, that means this point will be 4, this point will be 4. So what will be the area? A into 2, and you can check 8 into 4. So here the area was 16, here it is 32. In basics we have already seen it. So if your time domain is being multiplied with a, that means your time axis is divided by a. So your area will also be divided by a. Say yes or no? Okay. And what about this particular thing? Alpha x at plus b. So alpha is a constant value that will be multiplied with the area, and since you are doing the scaling, this will be divided by a. And if you shift, there is no harm. Basically, whatever the area this is enclosing, if I shift this waveform, this will also enclose the same area. So shifting will not change the area. All these things we have already seen. So you should remember these standard results because a lot of questions will be solved on these standard results only. What if in the examination all this question is coming that find out the area minus infinity to infinity e to the power minus t square dot dt. So you will ask yourself, do I remember any standard result in terms of e to the power minus t square? Something I remember. What is that I remember? So minus infinity to infinity e to the power minus pi t square dot dt, that is equals to 1. Now if I replace my t with t by pi, if I replace my t with t by under root pi, sorry, if you replace your t with t by under root pi, so xt was having an area of a, t is replaced with t by under root pi, so that will have an area of under root pi into a. So this was having an area of 1, so here multiplication will be done with under root pi. So what is the answer you are getting? Under root pi. Now in the examination they are asking the generalized form, e to the power minus at square. What does that mean? That means that this is something that you remember, e to the power minus pi, in place of t what we are putting? Under root a by pi into t dot dt, because at square divided by pi. What will be its result into pi? So e to the power minus at square dot dt. This is something that I am getting. So your t is replaced with under root a by pi into t. So your final answer, the area was 1, that will be under root pi by a. So what is the area here? Under root pi by a. So actually this is the generalized form. E to the power minus at square dot dt will be having an area of under root pi by a. Now in place of a you put pi. What you will be getting? Under root pi by pi. That will be 1 only. So actually this is the generalized form. But this will be tough for you to remember. It may seem like that, sir, I will remember this one. Very easy. But in the examination hall you will be forgetting it, sir. Under root pi or what, nothing I remember. So I told you one trick. Whatever the standard results you remember, sampling t, sinc t, sampling square t, sinc square t. Then e to the power minus pi t square. Only thing you need to remember is, this is not having a value of pi, that means in the answer pi would come. This is having a value of pi, in the answer 1 would come. This is having a value of pi, in the answer 1 would come. That's it. Then you can generalize all these final answer. So minus infinity to infinity minus at square dot dt will have the area of under root pi by a. Okay. Now this is a good question. You need to find the energy of the following signals. First question, xt is given as sine 2 pi t divided by t. A, xt is given as sine 2 pi t divided by t, right? I can see that either I can make it sampling or I can make it sinc, because what I need to calculate, I need to calculate energy of xt. That will be given as minus infinity to infinity mod of xt square dot dt. So one thing I can surely see that it will become a square of sinc or sampling. It will become a square of sinc or sampling, and I already know the results. I already remember the standard results. Say yes or no for the square of sampling and sinc. Do I remember the standard results? Yes. Sinc square t dot dt. It is having a term of pi, so answer would be 1. So this I already remember. So what I thought, that let's make it 2 pi into sinc 2 pi t divided by 2 pi t. So 2 pi get cancelled out. So what we are getting? 2 pi into sinc 2t. Say yes or no? 2 pi into sinc 2t. So sine 2 pi t divided by 2 pi t. So this can be written as sinc 2t. So what we are getting? Minus infinity to infinity 2 pi square, that would be 4 pi square, sinc 2t whole square dot dt. What you are getting? 4 pi square minus infinity to infinity sinc square 2t dot dt. Sinc square t is 1. What will be the area of sinc square 2t? 1 by 2. Time domain is being multiplied by 2. So area will be divided by 2. So what will be the answer? 4 pi square divided by 2. Answer is 2 pi square. No theorem, nothing. No theorem, nothing. I will just see the question. I will write down what I need to write down. Do I remember the standard results? Yes, I remember the standard results. This is my answer. Or what could have clicked to me? This should click to me. Ideally, this should click to me. But in the examination, my mind is always going towards Parseval theorem. So Parseval theorem might click to me. So what I will say? Parseval theorem says that energy of xt is equals to energy of x of omega divided by 2 pi. So my mind is going here. This is my method 2. This is my method 1. Ideally, this should click to me. But what if this clicks to me? That energy of xt is equals to energy of x of omega divided by 2 pi. Can I find out x of omega for this one? Yes, sine 80 by pi t. So what is my xt? My xt is sine 80 by pi t. So pi multiplication I need to do. So can I find out my x of omega? Yes. What will be my x of omega here? Sine 80. It will go from minus 2 pi to plus 2 pi with the amplitude being pi. With the amplitude being pi. This is your x of omega. So energy of x of omega, what will be the answer? Energy of xt will be equals to energy of x of omega. Can you find out the energy of this waveform? Yes, that would be pi square into 4 pi. Energy of x of omega, this will be pi square into 4 pi. This square into the complete width. Complete width is 4 pi. So pi square into 4 pi. All these things we have seen in the basics of signal, right? In the basics of signal, we have seen finding out the energy and all these kind of things. So pi square into 4 pi divided by 2 pi. So what will be the answer? 2 pi, 2 pi, this will be 2. So this is the answer. Although this process should not click to me because this will be much easier and much faster as well. Because I will just see it, I can convert it into sync, or I could have converted it into sampling as well. You can convert it into sampling as well, you will get the same answer. If you have converted it, then you can see that this is the standard function that I already remember. Sync square t will throw 1, so sync square 2t will throw 1 by 2. There you go, 2 pi square is the answer. So this is the answer. Or if my mind is going towards Parseval's only, then I will think of Parseval's theorem. Okay, let's see the B. What we need to calculate? We need to calculate the energy of sync square t. Will the answer be 1? Area of sync square t is 1, so answer is 1. Absolutely not. What you need to calculate? You need to calculate its energy. What is your xt? That is sync square t. You need to calculate its energy, right? Energy of xt. That would be minus infinity to infinity mod of xt square dot dt. That would be minus infinity to infinity. Mod of xt, this is always positive already because square is done. So this is always already positive. So sync to the power 4t dot dt. Now do I remember the standard results here? No standard results. No standard result. Now you will move to your Parseval's theorem. Are you able to understand this point or not? At this point of time, I will be moving to Parseval's theorem. Okay? Because I don't remember the standard results. So in any integration, if I feel like that I don't remember any standard results, now I can move to Parseval's theorem. So what my Parseval theorem says, energy of xt will be my energy of x of omega divided by 2 pi. So this is my xt. What is your xt now? No standard results. That means now you will move to Parseval's theorem. What is your xt? Sin pi t divided by pi t whole square. This is your xt. Can you find out x of omega for this one? Yes. X of omega. Sin 80 by pi t. Sin 80 by pi t. And it will go from minus 2 pi to 2 pi. So it will be going from minus 2 pi to 2 pi. It will be triangular. And what will be the amplitude here? Amplitude will be a by pi. That means pi by pi into 1. So amplitude will be 1. So this is your x of omega. Can you find out energy of x of omega? What will be your energy of x of omega? That would be a square by 3 into the width. Do you remember this particular thing? A square by 3 into the width. For a triangular pulse, any shape of triangular pulse is there. What we need to do? Amplitude square by 3 into the width. So a square by 3 into the width. So what will be your answer? Energy of xt. Energy of xt would be equals to energy of x of omega divided by 2 pi. So what is the answer? 2 by 3. So this is the answer. Are you able to understand this point? What will be the first thing that will be clicking to me, that what I need to calculate? This is something that I need to calculate. There is no standard results for this particular expression. If there are no standard results, then my mind will move to Parseval's theorem. Okay, and when I move to the Parseval's theorem, then I go to know that energy of x of omega, this is something that I am getting. Now what if in the examination hall, this question is coming. This question is coming. Look, if you are too smart, then it will click to you that it is energy of x, energy of sink square t. If you are too smart, it will click to you that it is the energy of sink square t. Then you will make it xt. Only this question is coming. They did not write energy of sink square t. They just asked you to find out this particular thing. So if you are too smart, then this will click to you that sir, this is my xt, energy of xt. You assume this as xt, then I can apply Parseval's. If this is clicking to you, it is good, but it might not click to you as well that it is energy of xt. You may treat it as a separate signal. You know that I cannot do this integration for sure. I cannot do this integration for sure. So something I need to do. I know something about sink square t for sure. What you know that I will be comfortable with sink square t. So what may click to you is that sir, sink square t dot sink square t. If sink square t square is clicking to you, if sink square t square is clicking to you, your job is done. Why is that so? Why your job is done? Because if square is clicking to you, that means energy of xt would click to you. There is no doubt about that. But what if square is not clicking? This is something that is clicking in your examination hall. Right? You will see x1t. What I will call it? x1t. And this also I am calling as x1t. Although after all this process, surely it should click to you that I should apply Parseval's theorem. But what if nothing is clicking? Then I am telling you. So what you will do? I remember one particular thing that two signals are in multiplication. So minus infinity to infinity. First one as it is, another one dot d omega. So you will find out x1 omega, then you will find out x2 omega, then you will take the mirror image and then you will multiply both of them, you will calculate the area and then divide by 2 pi. You will get the same answer. I am just telling what may click to you in the examination. If they are asking this question, energy of xt, energy of this particular thing, then it will click to you that okay, I can apply Parseval's now. But if they are asking directly this integration, they did not write energy of xt or anything. They just asked you this integration. So in the examination hall, it might not click to you that I can apply Parseval's. So always first thing you need to see the multiplication of two signals, right? So this is the process. If multiplication of two signals dot dt is there, you are calculating the area, then you can do one thing. What is that? You calculate their Fourier transform, keep one as it is, take the other one mirror image, multiply both of them, calculate the whole area of the multiplication and then divide by 2 pi. What if the question was minus infinity to infinity, sink cube t dot dt? Can you apply Parseval's here? Someone will say that sir, yes, I will apply Parseval, but now my xt would become sink 3 by 2 dot dt. This is my xt because this is the energy of, this is your energy of sink to the power 3 by 2t. So that would be equals to energy of Fourier transform of this particular thing divided by 2 pi. Do you know the Fourier transform of this particular thing? No. I remember the Fourier transform of square or direct, but not to the power 3 by 2. So this I cannot apply. So now what will click to me? Okay, sink square. Really sorry, I wanted to write sink square here. So now what will click to me? That I can break it down. This is something they are asking. So in the examination hall, it may click to me that I can break it down in terms of square and then a direct function. And why I am doing so? Why I am doing so? Square and a direct function. Why I am doing so? Because I know the Fourier transform of this one, I know the Fourier transform of this one as well. This if I call x1t, this if I call x1t, and this if I call x2t, then 1 by 2 pi minus infinity to infinity x1 omega x2 of minus omega d omega. Now this process would become very easy for me. Do I know how to find x1 omega from this particular signal? Yes. Sink square t. Sink square t. So what is your x1t? Your x1t is sink square t, which is sine pi t by pi t whole square. So your x1 omega is sine 80 by pi t, which will be going from minus 2 pi to 2 pi, minus 2 pi to 2 pi, with the amplitude being 1, with the amplitude being 1. So this is your x1 omega. What about x2t? What about x2t? x2t is sinc t. x2t is sinc t. So sine 80 by pi t. So what will be your x2 of omega? So sine 80 by pi t, where a is this is the thing, right? With the amplitude being 1, sine 80 by pi t. So this is x1 to x1 omega dot x2 omega. Then what you need to do, x1 omega dot x2 minus omega. That means you need to take the mirror image. So this is a symmetric. So what will be the mirror image? The same graph. So if this is your x2 omega, then I can write it down as x2 of minus omega as well, right? Because both graphs will be same. What I need to do now? Multiplication. So minus 2 omega to minus omega, everything will be 0. Here there will be minus omega, here will be plus omega. So from plus omega to infinity, everything would be 0. From minus infinity to minus omega, everything would be 0. What will be the amplitude here? 1 by 2. And what will be the amplitude here? That will also be 1 by 2, right? The amplitude here will be 1 by 2. Why is that so? Because if you cover the distance of 2 pi, then amplitude is increasing by 1. So if you cover the distance of pi, then amplitude will increase by 1 by 2. So this point will be 1 by 2, this point will be 1 by 2. You just need to multiply both of the signals now. So what will the multiplication throw? Multiplication will throw this particular thing, x1 omega dot x2 omega. So from minus pi to pi, from minus pi to pi, it is non-zero between minus pi to pi. So at minus pi, this is throwing 1 by 2 and this is throwing 1. That means this amplitude will be 1 by 2. This amplitude will be 1 by 2. And this amplitude 1 into 1, this point amplitude will be 1. Okay. So x1 dot x2 omega, omega. Here this is minus omega. What is your final answer? Actually, your final answer is this particular thing. Basically, what is my answer? My answer is 1 by 2 pi, then area of this graph. So 1 by 2 pi, area of the upper graph, area of this graph, x1 omega dot x2 of minus omega. This is my final answer. So what is the area of this graph? I can calculate the area very easily. That would be pi, this would be pi into 1 by 2, because here this width is pi and this height is 1 by 2. So pi by 2 plus 1 by 2 into base is pi into height. So pi by 2 plus pi by 4, that would be 3 pi by 4 and into 2. So area is 3 pi by 2. So area is 3 pi by 2. The area you can calculate very easily. This area you can calculate very easily. You can see this structure. So the area of this structure would be 1 by 2 into addition of parallel side, that is 1 by 2 plus 1 by 2 plus 1, and then height. This height is pi. So 3 by 4 pi into 2. So 3 by 2 pi. So area is 1 by 2 pi as it is, 3 by 2 pi. So pi to pi get cancelled. Answer is 3 by 4. So this is the final answer. So if someone asks you minus infinity to infinity, sinc t, that is coming out to be 1. Minus infinity to infinity, sinc square t is also coming out to be 1. Minus infinity to infinity, sinc cube t is coming out to be 3 by 4. And minus infinity to infinity, sinc to the power 4t is coming out to be 2 by 3. It came out to be 2 by 3 only, no? In the last problem, it came out to be 2 by 3. So continuously it is decreasing. Here 1 to 1 stage constant. This is 0.75. This is 0.66. So 1, 3 by 4, 2 by 3. Right? So this is the answer. 3 by 4 is the answer. Okay, let's check back the calculation again. Let's check the calculation again. I guess it is right only. I hope there is no error in the calculation. Minus 2 by 2, 2 pi, minus 5 to pi. Then the multiplication 1 by 2, 1 by 2, 1, 1. Then area 1 by 2, area would be 3 by 4 pi into 2 pi. So 3 by 2 pi, pi get cancelled, 3 by 4. Yeah, okay, fine. This is the area. Okay. Do this one on your own. Think about it and calculate the energy of this particular signal. What you need to calculate? You need to calculate the energy of this particular signal. Do it on your own. A very good question, and this will test everything that you have studied till now. So do it on your own. I will take a pause and then I will come back. Okay. Yeah, welcome back. So you try this one. Sine 2t by pi t dot sine 3t by t. So this is our C. What is our xt? Sine 2t by pi t, sine 2t by pi t dot sine 3t by t. Let me check it again. Sine 2t by pi t dot sine 3t by t. Okay. One thing I know that if I do the mode and then I take the square dot dt, I don't remember any standard result. Basically, I need to find energy of xt if I see this particular thing. There is certainly no standard results at all. You can convert it to sampling, you can convert it to sampling as well, but here sampling 3t would come and here sampling 2t would come. So 2t into 3t, both are completely different. So sampling square you are not getting. So you don't remember any standard results. No standard results. And if there is not any standard result, what you will do? Parsevals. Parsevals. And what does your Parseval theorem says? That energy of xt is equals to energy of x of omega divided by 2 pi. Okay, and if you don't want to carry this 2 pi, then you can directly write down energy of xt is equals to energy of x of f. You can do the calculation in f domain as well if you don't want to do the calculation in omega domain. So you can write down energy of xt is equals to energy of x of f if you don't want to carry this 2 pi. But usually we do the calculation in omega domain only, so that's why we are doing so. Now what is my xt? Do I directly remember the x of omega here? Is there any standard result of x of omega? Again, no, right? There is no standard result of x of omega. Basically, what is your xt? Xt is multiplication of two signals. Xt is multiplication of two signals, and those two signals are sine 2t by pi t and sine 3t by t. This is the multiplication of these two signals. This is your xt. Do I remember any standard result for this? No. That means again I need to apply the multiplication convolution property. So multiplication in time domain will result in convolution in frequency domain. Divided by 2 pi. So this will be your x of omega. Do the convolution and then divide by 2 pi. So x1 omega I know, x2 omega I know, and then I need to convolve both of them. What this will be in the frequency domain? Rect. And this will also be rect in the frequency domain. In your frequency domain. In your frequency domain. And convolution of rectangular pulses I already know. Job is done, question is solved. Just now I need to do the calculations with good amount of patience, nothing else. Okay, so signal system questions, like it might feel difficult, only I would say 100 people will be able to solve this kind of question in the examination. Energy of this particular signal, nothing will click to them. But you just need to believe yourself. If the question is coming on sync, sampling, some area or anything, it will be solved with the help of Fourier transform. And you know every single thing about Fourier transform. That belief you need to have. Just write down the things, whatever that is asked, And once you write down, you will be able to understand what I need to do. Are you able to understand this point? Okay. So first, what I need to find? I need to find this x of omega. So first I need to find x1 omega. What will be my x1 omega? And then I need to find x2 omega. So let's find out x1 omega. And then I will find out x2 omega. So your x1 omega is sine 80 by pi t. So it is going from -2 to 2 with the amplitude of 1. -2 to 2 with the amplitude of 1. What about x2 omega? x2 omega sine 80 by pi t. So pi here and then pi here. Sine 80 by pi t. So it will go from -3 to 3 with the amplitude of pi. -3 to 3 -3 to 3 with the amplitude of pi. What I need to do? I need to do the convolution and then divide by 2 pi. So first I will do the convolution. So when I do the convolution, this is what I will be getting. Lower limit added, -5. Higher limit added, -5. Here the width is 4, here the width is 6. So width is 4. Width is 4. Initial slope will be pi. 1 into pi will be pi. Initial slope will be pi. So till this point everything is 0. Then initial slope being pi, then it becomes constant, then minus pi, and then goes to 0. So this width is 4, so this point will become 4 pi. So this is your x1 convolution with x2, x1 omega convolution with x2 omega. But then you need to divide by 2 pi and you will get your x omega. So you need to divide by 2 pi. So if I divide by 2 pi, this point will become 2. So now I am getting my x of omega versus omega. Are you able to understand this point? x1 omega convolution with x2 omega. What I am getting? Width is 4, width is 6. So this is something that I was getting with the slope here being, slope initially was pi here. Slope was pi here, right? Because pi into 1, slope was pi. So this point would have been 4 pi. But if I need to calculate x of omega is convolution divided by 2 pi. So amplitude will be divided by 2 pi. So 4 pi divided by 2 pi will be 2. Okay. So your x omega was actually 1 by 2 pi and then the convolution. Right. So now what is my final answer? Energy of xt is energy of x of omega divided by 2 pi. Can you find out the energy of this signal? Yes. I can break it down into 3 orthogonal signals. This is an orthogonal signal. This is another orthogonal signal. One orthogonal signal, second orthogonal signal, and the third orthogonal signal. So 3 orthogonal signals are there. That will be a square by 3 into 4, a square by 3 into 4, plus a square by 3 into 4. This width is also 4. So a square by 3 into 4, plus this width is a square into 2. A square into 2 divided by 2 pi. What I am doing, if you have studied your basics of signal, then you would know what I am doing. A square by 3 into width, a square by 3 into width. So a square by 3 into width. This width is 4, this width is 4. So total width is 8. So what you are getting? 32 by 3. Right? 16 by 3 plus 16 by 3, 32 by 3 plus a square by a square into this width, because this is a square. So 4, 2 square 4 into 2, 8. Right? So multiply by 4 divided by 4. So 32 by, no, this is something I should not do. So 32 by 3 plus 8. What we are getting? 32 by 3 plus 8. 32 plus 24 divided by 3. So 6, 5. So let's do the calculation directly, and then divided by 2 pi. Then divided by 2 pi. Okay. So I will do the calculation. 32 by 3 plus 8 divided by 2 pi. 32 by 3 plus 8 divided by 2 divided by pi. 2.97. So answer is 2.97. This is the answer. So in this question, everything is tested actually. Your whole knowledge is tested for in this whole question. In this whole question, we have applied everything. Started with A, B, and then C. Sin 2t by t dot sin 3t by t. So this is the answer that we are getting. How we started? We saw the signal, no standard results, nothing. So I need to apply the Parseval's theorem. Energy of xt is energy of x of omega divided by 2 pi. Now xt is multiplication of two signals. That means this will be equals to convolution of two signal divided by 2 pi. So convolution of these two signal I need to do, and then I need to get divided by, then I need to divide by 2 pi. So our first task become to find out x of omega. Then I find out x of omega. Standard result sin 80 by pi t, and then here sin 80 by pi t with the amplitude of pi. And then you do the convolution. This is the convolution you are getting. Width is 4, width is 6. 4 width, 6 width. Lower limit, high limit, 4 width, and then from here we are getting, this is our x of omega, and then divided by 2 pi also we have done because the slope was 4. So this is our x of omega. Now I need to calculate energy of xt, which will be equals to energy of x of omega divided by 2 pi. What is the energy of x of omega? A square by 3 into 4. So 4 by 3 into 4, 4 by 3 into 4, then a square into 2. So this is 8, this is 32 by 3. So 8 plus 32 by 3 divided by 2 pi is 2.97. This is the final answer. Okay, so this is the way we will be thinking. We need to apply this particular formula as well sometimes. We can directly think of these kind of things, or if it is clicking to us that I can apply Parseval's theorem, then I can apply Parseval's theorem as well. So you know a lot of things. You already know a lot of things, just you need to have the patience in the examination hall and have the confidence on yourself. Then you will be able to solve the question on Fourier transform, that's for sure. So there is one small topic also left, Fourier transform of a Gaussian pulse. So what is the Fourier transform of a Gaussian pulse? So this is known as Gaussian pulse. Okay, this is known as Gaussian pulse. In our communication system, we will again take this Gaussian pulse, but as of now for EC and electrical, both of the students and instrumentation student, this is known as your Gaussian pulse. So can you draw the diagram of xt? Gaussian pulse is e to the power minus 80 square. Do you remember the area of this Gaussian pulse? What is the area of this Gaussian pulse? That is under root pi by a. You actually remember e to the power minus pi t square will have an area of 1. So here in place of t you have put under root a by pi. So under root pi by a, this is the area. So at t equals to 0, the amplitude is 1. At t equals to infinity, the amplitude is 0. So this is how it is going. Is it an even signal? Yes, because x of minus t. What will be x of minus t? E to the power minus a minus t square. That would be equals to e to the power minus a t square. So x of minus t is equals to x of t only. So same thing is happening here, right? So x of t. So this is the graph of your Gaussian pulse. I need to calculate its Fourier transform. So what I can do? I can do this particular thing, x of omega is equals to minus infinity to infinity x of t e to the power minus j omega t dot dt. A very tough process, will take a lot of time. Can you do this integration? A very tough process. So now I will do something smartly. Xt is equals to e to the power minus 80 square. What I do, I differentiate on both of the side. If I differentiate on both of the sides, what I am getting? So this is something I am getting, right? Now I can write it down in this manner. This is just a derivation, nothing else. So let's write down in this manner. Minus 2a t into e to the power minus 80 square t into xt. Say yes or no? Because e to the power minus 80 square is xt only. What will be your dy dt xt? Now I am calculating the inverse. Now I am calculating the Fourier transform. So what will be the Fourier transform of d by dt xt? That will be j omega x omega. minus 2a. What will be the Fourier transform of this particular thing? J dy d omega x of omega, right? Xt was having a Fourier transform of x of omega. What was the Fourier transform of t xt? That was j d by d omega x omega. And what was the Fourier transform of dxt by dt? What that was? That was j omega x omega. This was the scenario, right? Now what I can do, j to j is getting cancelled out, right? J to j is getting cancelled out. So what we are getting, omega into d omega, this d omega I am taking here, omega into d omega, then j to j is getting cancelled out, divided by minus 2a, divided by minus 2a, and then dx of omega divided by x of omega. Do you agree to this point? Dx of omega, this d omega goes here, this x of omega coming downward, minus omega into d omega, dx of omega divided by x of omega, and then this jj getting cancelled out, minus 2a is getting downward. All okay for you? What is the integration of dt by t? ln t, right? So similarly, if I do the integration on both of the sides, what I will be getting? Minus omega square by 4a, and then there is a constant, then ln x of omega. If I want to add a constant here, then I would add a constant ln c. Basically, here also constant added, here also constant added. So at one side only you need to add the constant. So I am adding the constant on this side only. What I did, I just did the integration. So minus omega square by 2, already 2a was there, so minus omega square by 4a, ln x of omega plus ln c. So from here what we are getting? ln c into x of omega minus omega square by 4a. So c into x of omega e to the power minus omega square by 4a. So x of omega is coming out to be c into e to the power minus omega square by 4a. This is your x of omega. But you need to find out this c. What is this constant value? Look, this c actually gone 1 by c. So 1 by c is another constant. So this another constant I am keeping as k. Basically here a constant is coming. That's it. That's the bottom line. ln c of omega, ln c x of omega, you agree to this point? Minus omega square by 4a, because this property I have applied. ln m plus ln n. So ln m into n. So this is the property I have applied here. Now this c will go downward, 1 by c it will become. So 1 by c is also a constant. So another constant I am keeping. Basically I am keeping 1 by c as k. So k is also a constant, 1 by c is also a constant. So basically here constant into e to the power minus omega square by 4a. This is your x of omega. So now I need to find the value of this constant. One thing I know, x of omega at omega equals to 0 is equals to minus infinity to infinity xt dot dt. Do you agree to this point? Right? Because minus infinity to infinity xt e to the power minus j omega t dot dt is equals to x of omega. If you put omega equals to 0, then this is something that you get. So what you can understand from here? What you can understand from here is that x of omega at omega equals to 0. What that would be? You put omega equals to 0 here, e to the power 0 will be 1. So that would be equals to k. And that would be equals to minus infinity to infinity xt dot dt. And that would be equals to minus infinity to infinity e to the power, what is your xt? Minus at square dot dt. Right? Your xt is minus, your xt is e to the power minus at square dot dt. E to the power minus at square dot dt. So k will be equals to, what is the area of this particular thing? Under root pi by a. So your k is under root pi by a. So from here your x of omega is under root pi by a e to the power, e to the power minus omega square by 4a. This is your x of omega. So our xt was e to the power minus at square. This is our xt, e to the power minus at square. This was having a Fourier transform of, under root pi by a e to the power minus omega square by 4a. This was the Fourier transform. What is this? Gaussian, and this is also Gaussian. Basically, if you draw the diagram of x of omega, if I draw the diagram of x of omega, what I will be getting? What I am drawing? X of omega versus omega. If I put omega goes to 0, what I am getting? Under root pi by a. If I put omega equals to 0, I am getting under root pi by a. And if I put omega goes to infinity, I am getting 0. Here also omega goes to minus infinity, again I am getting 0. This is even, yes, this is even, right? X of omega is equals to x of minus omega, so this is even. So if you put omega equals to 0, or you put omega equals to, if you put omega equals to 0, or you put omega equals to infinity, then it will be 0. If you put omega equals to 0, it is throwing under root pi by a. If you put omega equals to minus infinity, then it is again throwing 0 only, right? So this is how the graph is going. This is how the graph looks like. So what do you see here? This is also Gaussian only, no? Here if I say this is the Gaussian nature, this is the Gaussian nature, the Gaussian nature says that whatever the function is there, it will be squared in the exponential. This is what Gaussian nature says. So x of omega, it is squared in the exponential. So if time domain was Gaussian, then your frequency domain is also Gaussian. This is something that I have written here. If this was Gaussian, then your frequency domain is also Gaussian. Because what Gaussian says, x of t, so t square in the exponential, x of omega, so omega square in the exponential. So both are having the same kind of structure. So in the time domain, if you are having a Gaussian waveform, then in the frequency domain, its frequency spectrum will also be Gaussian. So e to the power minus at square will have a Fourier transform of under root pi by a e to the power minus omega square by 4a. You should remember it, okay? What I am writing to remember. Because directly a lot of time the question has been asked on this particular formula. To remember, REMEMBER. To remember. You need to remember this formula. What is the Fourier transform of e to the power minus at square? Under root pi by a e to the power minus omega square by 4a. Let's see another form. In place of a, if I put pi, what I will be getting? Under root pi by pi e to the power minus omega square by 4 pi. So basically under root pi by pi will be gone. So e to the power minus omega square by 4 pi. This is what I will be getting. Can you convert it into f? This is your x of omega. What will be your x of f? So here omega will be directly replaced with f, but here e to the power minus 2 pi f whole square divided by 4 pi. So e to the power minus 4 pi square f square divided by 4 pi. So what we are getting? E to the power minus pi f square. So e to the power minus pi t square is having a Fourier transform of e to the power pi f square. So this can also be there in your mind. If it is not there in your mind, you can derive it. E to the power minus pi t square is having a Fourier transform of e to the power minus pi f square. This should be there in your mind, or at least you keep this particular thing in your mind. Very, very important. Derivation is not important. Whatever that I have done here, you can understand it. But e to the power minus at square will have a Fourier transform of under root pi by a e to the power minus omega square by 4a. Okay, e to the power minus pi t square will have a Fourier transform of e to the power minus pi f square. All good, all fine. So that's it. This video has become a bit longer, but we have studied a lot of properties here, right? I know it has become a longer video, but I hope you understood a lot of concepts here, right? Yeah. So that's it. I hope you enjoyed this video. In the next video, we are going to study about filters. What we are going to study? We are going to study about filters. So LTI system you can say, or you can say filters. So there we will study about LTI system, and then I will tell you a statement that every LTI system can be identified as a filter only. What is the meaning of filter? Then we will see different kind of filter. Then we will see what kind of time domain signal will make the filters in the frequency domain, and we will solve some questions based on that. So next lecture is also very, very important. So now a lot of things have been compiled up in Fourier transform, right? It might seem like that, sir, this has become a lot of things have been compiled up. How we will study all these things? So anyway you need to study it. Anyway you need to understand that in the examination, like 100% there will be one question from Fourier transform. You see past year trends, there has not been a single year where the question is not coming from Fourier transform. Surely there will be a question from Fourier transform. That's 100% sure. and nothing will come out of these class notes only. Everything will be from the class notes. And Fourier transform becomes very tough for the students. Sometimes 2 to 3 questions can be asked from the Fourier transform in the examination hall. And a lot of people find difficult to Fourier transform, but we have been seeing all the problem solving technique, right? I could have simply wrote down that there is a property called multiplication convolution property, and there you go. There is a property, there is something called Parseval's theorem. Okay, this is the Parseval's theorem. But how do you use those property? How you actually understand those property? What is the actual meaning behind those property? How those property came into action, and how to utilize those property in the problem solving? So this kind of things you are seeing, and that's why it is becoming a bit lengthy as well. I understand that Fourier transform is going a bit lengthy, but surely in the examination hall you need to have the confidence that whatever that I have studied, the question is coming from that part only, but now I just need to take care of the things, that I know everything. I will just write down what the question is asking, from there what I can conclude. So all kind of questions we are solving, and a lot of questions we will solve in the assignments as well. So you need to have some confidence on yourself in case of Fourier transform. Okay, and I'm not dropping a single topic, so you will be able to solve all the problems, that's for sure. So let's study about filters, and then we will study about sampling. Eigenvalue and eigenfunction we will study in the Laplace transform. Okay, there is a topic called eigenvalue and eigenfunction that we will be studying in Laplace transform, because after the Laplace transform it would become very easy for us to understand that particular topic. Okay, then yeah, thank you very much.